And here we go.
There's the deluge. Here's ignition.
Doubling up.
Did he just do a kerbal?
Back to the moon and beyond.
Put that in the big bag, Gino.
Back at home, we all have a lot of work to do, but from here, it sure looks like a perfect flow.
Propulsion continues to be nominal.
We did have an observation.
Equalize.
343 unfolds to go.
It's orange.
Water towers can fly!
Bingo! Right in the center.
Where's Jacqueline? There it is!
That was surreal.
That's not what we want to see.
No.
Oh my God.
Yikes. You bet. Sure. We don't need any more of these.
And we're back. Hello, everybody. We are still watching SLS. This is the second part of our coverage of the Artemis II Wet Dress Rehearsal as NASA prepares the rocket, which is going to launch 4 human beings to the moon in maybe as soon as 7 days. We'll see if hydrogen has anything else to say about that over the next few hours or so. My name is Ryan Caton. Right now, also on commentary, we have Philip Sloss and Dee Wise at the Kennedy Space Center. Philip, do you want to just give us a quick rundown of some of the things we've seen today, some of the hydrogen-related problems we've seen today, and kind of what we should expect to be seeing over the next few hours or so?
Sure. So they've had to stop hydrogen flow at least a couple of times on the core stage. I'm trying to remember if I believe going all the way back to sort of right before lunchtime, they gave the go, I think, to begin tanking around 11:25 a.m. Eastern, if I recall correctly, and things went well. It seemed like for about the first 2 hours, and so they got significantly into fast fill on the core stage liquid hydrogen tank. They got over half full then they started seeing concentrations of hydrogen in the cavity, in the umbilical cavity between the two plates. There are these two tail surface mass umbilicals that you're looking at here. The liquid oxygen tail surface mass is on the left. Liquid hydrogen tail surface mass is on the right. You have a ground plate that mates up to a vehicle side plate, and there is a cavity, a little bit of space between the two, and they're flushing that with gaseous helium to reduce the flammability risk, but they're also measuring what's coming out of a vent port. And so they're seeing too much hydrogen, and so every time that it goes over the upper limit, they've had to stop flow. And so I'm not sure how far behind schedule we are now, but they did just enter topping mode. And so if I recall correctly, there are a couple of level sensors at the top of the tanks that tell you when you get to 98% full and then 100% full. And so usually when they get to the 98% sensor, that's their signal to slow down the flow rate to a slower rate. We just got that, maybe 10 minutes ago. So they should be getting close to replenish now. But that slowed down, that forced them to stop loading liquid hydrogen on the ICPS, the interim cryogenic propulsion stage, which is the in-space second stage for the vehicle. In the meantime, it seems like the liquid oxygen loading has gone more to plan. The difference between the two being for this launch, they overlap the hydrogen loading sequence, at least in a nominal sense, whereas for liquid oxygen, it was the same. They do them one after the other, but it looks like they're probably going to end up being full on the liquid oxygen side, kind of like with Artemis I first, even though you shouldn't typically see that. But I think right where we are right now is I think one of the last things they said in discussion about the situation was they were just going to continue with the loading procedure and probably continue with the test and see if they can manage the hydrogen concentrations. They're hoping that because when you sort of throttle back the flow rate of hydrogen into the bottom of the stage, that they will see lower hydrogen concentrations in that area and be able to continue the test. And so I think the hope is that they can just continue and press ahead as far into this timeline as possible. The next big step would be to send the closeout crew out to the White Room and let them run through their Orion closeout procedure. And they would need to do that in order to run through the terminal countdown sequence, because this time the White Room and the crew access arm have to be swung away from the vehicle in terminal count, and that would happen at the T-minus 8 minutes and counting mark. So it's possible, because it's a ground side thing, it is possible that they could work their way around that if they wanted to just focus on the propellant loading and the terminal count sequences. But that was a big objective of this test, was the Orion closeout procedures. So we are still waiting to see all 4 propellant tanks in replenish. I think the last tank to get there will probably be the interim cryogenic propulsion stage liquid hydrogen tank, because they had to stop flow for that at the same time when they stopped flow for hydrogen into the core stage. So, but I think that's kind of where we're going, which is we're headed to try and get into replenish on all 4 propellant tanks, and then see if they decide to send the closeout crew out to the vehicle, because that closeout process could take up to 4 hours. And then again, just from a situational awareness here, where we do have the countdown clock up here in the news center at Kennedy Space Center. The countdown clock went into a 40-minute hold at T-minus 3 hours and 30 minutes at 4:20 p.m. Eastern. So we should be coming out of that hold and resuming the clock here at the top of the hour at 5 p.m. Eastern.
Good deal. And that clock at the press site lawn is the L- clock, which we also have in the top left corner. In terms of just how far behind that liquid hydrogen topping is, if we say that started at about 40 minutes past the hour, in terms of, so what would that have been, like L- 4 hours and 20 minutes on our clock in the top left? I believe, according to the timeline I have in front of me, that it's meant to begin at L- 7 hours and 40 minutes. So they are a good 3 hours behind schedule on the liquid hydrogen side of things. But as you were saying, the liquid oxygen side of things seems to have been going much better, because they've already loaded oxygen onto the vehicle with a lot less trouble than they are having with the hydrogen. So I wouldn't say... Personally, I would say they're 3 hours behind, but they are, with the hydrogen side of things at least, it is 3 hours behind. But I wouldn't say the entire count is 3 hours behind at this point.
Right. I think if probably the easiest sync up point would be when they send the closeout crew out, or maybe again the step before that being when we get if we can get a time tag on when they see all 4 propellant tanks in replenish. So some of them may already be there. Liquid hydrogen, even the core stage liquid hydrogen, could get into the replenisher fairly quickly after they get into topping. But once we see all 4 propellant tanks in replenish, to kind of look at where that was and where that was on the timeline, and that'll probably give us at least a little bit better idea about how far behind. But that, again, this L- clock, which is about to come to, we're about to get to 5 p.m., and that L- clock is just telling us how much time there is until 9 p.m. Eastern. It's very doubtful, I think, at this point that they're going to, well, I don't know if I should say that, but I would say doubtful is reasonable to say that they're going to be ready to run their first terminal countdown, and for a simulated T0 at 9 p.m. I would expect it to take for them to run into the test window a little bit, even though it's 4 hours long.
There's plenty of time to sort these things out, and of course we would never want to see a delay, but NASA has been making a very intentional effort to not set a launch date in any way, shape or form. They've simply been saying these are the windows which we could launch in. We will only give you a date when we have completed this wet dress rehearsal testing, when we have reviewed the data, and when we are confident that we can launch. And those are those mission dates which are currently available as of before when this testing started. So, we don't want to see a delay, but there is time for a delay, and it is much better in the long run for this mission's success if they can get everything sorted, however annoying a delay may be, especially with that hydrogen. Pesky hydrogen. And that top view, by the way, is our telescope, which is zoomed in at the base of the vehicle, and you can see those two tail service mast umbilicals there. So that is the root of the problem. That is where the hydrogen leaks are occurring. So that's why we've zoomed the telescope into that part of the rocket, because you can even just make out one of the RS-25 main engines. You can see some of the venting also beneath the mobile launcher platform there, which is pretty cool to see, despite the heat haze.
Yeah, it's a lot of air between here and the rocket to contend with, but I use the break in between the two streams to run out there to move to that shot, because we've still got the venting from up higher by the liquid oxygen tank on the rocket, but the venting down at the base of the rocket and visibility of the TSMUs seemed like a nice change to the shot.
Speaking of the weather, D, I know it's been chilly in Florida, to say the least. How is the weather today?
Well, it is chilly, but it's actually not too bad. I believe we're around 50 degrees now. So we were seeing freezing temperatures the last 2 nights. There were icicles outside, actually, just yesterday. But it has warmed up throughout the day, and even though it'll cool back down this evening, it's not expected to pass back under the threshold of freezing again. And so it's been sunny, it's been clear skies, it's honestly been beautiful. I know most people in the area are not used to these sorts of temperatures, and it is cold. But apart from the cold, which right now isn't too bad, it's truly just been a beautiful, beautiful weather.
I can't see a cloud in the sky, at least on this view, so looks pretty nice blue skies to me.
Absolutely, and it is worth noting, like, there is some wind, but it's not crazy howling wind. But I know we have one view that was looking at the flag a bit earlier. That's definitely blowing, but like, I would not complain one bit if Artemis launched in these conditions. Hopefully with this sun. But we'll have to wait and see when that happens.
I think we found the sun, especially on this view from inside the pad. But one benefit of that kind of nuclear detonation on the left-hand side of the screen is that it kind of gives us a nice backlight for the venting going on from the core stage. Makes it a little bit easier to spot, at least from this perspective. You can see there the venting from just above the liquid oxygen tank on the core stage, which has been going for a little while at this point, as we now pass beneath L-4 hours in today's first run for this wet dress rehearsal.
And we did see the countdown clock just pick up at the hour, and so we're at T-minus 3 hours 30 minutes and counting.
That is wonderful to see.
And so they'll go down to 10 minutes, T-minus 10 minutes, and they will hold there. And that's probably that'll be where they ultimately sync up with any kind of terminal countdown test that they're going to do tonight.
Mm-hmm. Yeah, that is the final built-in hold in today's countdown, or in the countdown in general, I should say. There are 3 planned holds. One that starts at L-11 hours 35 minutes, I believe. There's another one that starts at L-4 hours and 40 minutes, and then there's the final T-minus 10 hold, which is meant to start at L-minus 40 minutes. It's meant to be half an hour, but because it's a hold, they can keep going. What? And we are being told there is 100% loading of liquid oxygen and liquid hydrogen on the core stage, 100% liquid oxygen on the ICPS upper stage, and 61% hydrogen on that stage. Although the curious thing is, the oxygen dial on the core stage is 100%, but the dial isn't 100%.
That's got to be a hydrogen issue for oxygen too. yeah, you can see the ICPS is slightly behind. But yeah, I think again for the countdown, the planned hold for the planned hold at T minus 10 minutes was supposed to be 30 minutes in duration. So if they've been following the timeline with the countdown clock, and so for a 9 p.m. targeted T0, I believe they would start that hold at what 8:20 p.m. Eastern, and then we were likely to see that extended for some period of time.
Yeah.
So, and one of the aspects of the overall propellant loading process is the engine chill down, especially on the hydrogen side, and we don't really know where that is because that would have also been interrupted by when they stopped flow for liquid hydrogen, and so we don't know if they obviously need to catch up on loading the upper stage with liquid hydrogen, but we don't know if they need to catch up on the engine bleed as well. So, and I'm not sure that might be too much inside baseball for the NASA feed, unfortunately.
Indeed, and the information that NASA is providing us is saying that the core stage is in replenish for the hydrogen, and it's still in fast fill for the upper stage. So, interesting information. We will continue to keep an eye. It is very useful when that graphic comes up with the fueling information. Of course, this is a wet dress rehearsal because they are fueling the rocket. It is a rehearsal for NASA's teams to get everything ready. It's also a rehearsal for us to get everything ready because for Artemis II, we are going to be deploying a lot of cameras and deploying a lot of gear and doing a lot of work in the background to bring you the best views possible as we get ready for this launch. Because, it's not every day you send 4 humans to the moon. In fact, it hasn't been so for over 53 years at this point. So it is a very special event for us, and we want to bring that to you and share it with the world because, we're space nerds, we're NSF, that's what we do. So we're going to do our best to bring this to you all, and hopefully we can bring you some coverage which you will enjoy watching. Fingers crossed as soon as 7 days from now, depending how this test goes. But you never know. It's better to be safe than sorry. And of course, helping us to create that coverage is everybody watching the stream right now, especially everybody who's pressing that like button, by the way. But of course, especially the people who are supporting us, like Connor, who has become a PadRap member. We have Jeffrey becoming a PadRap member. We have Benjamin becoming a Red Team member. And of course, as always in chat, we have Bideford, who is very generously always supporting us, this time with a $25 super chat. They're saying, please, time for helping the algorithm by hitting the like button. We need 1,000 likes. I agree with that message, Bideford. And thank you so much for your support and encouraging other people to help us out as well. Because, we are beholden to the almighty YouTube algorithm. So any help we can get with that is greatly appreciated. So again, Bideford, thank you so much for your support. We also have a WDBF radio with a $10 super. No message, but just a $10 super nonetheless. So thank you for that support as well. It genuinely goes a very long way into helping keep the cameras running, keep the hamsters running in the wheels that generate the power to keep all of these feeds going. So yeah, it is greatly appreciated to everybody watching right now. Let's have a look through here for some more questions. We have a question here from Bill P, who is asking, as they use helium as their inert gas for cavity venting, is that because it's more efficient with hydrogen than nitrogen and carbon dioxide, or is it just a design choice? Philip, that has your name written all over it.
Yeah, they do use gaseous nitrogen as well, but if you think about it, because you're talking about hydrogen, if you were to mix nitrogen and hydrogen together, you would freeze the nitrogen. It wouldn't necessarily stay in a gaseous state. So they use helium to purge when they're trying to purge hydrogen cavities in particular. So that's why they use helium for that.
We also have Brian, who's asking, are there any concerns for liquid oxygen burn-off with the loading times? I think they kind of negate this with the insulation, right? That's the reason why we call the big orange rocket the big orange rocket.
Yes, and they're sized. I think they're sized for with a little bit of margin. But when they talk about, even when they were talking about for the first launch for Artemis I, and how long it would take to recycle between attempts, they built in the idea that you're talking about not just a propellant loading, but also a 2-hour long launch window plus some margin for situations like this. So, in this case, though, they have plenty of time between even a first launch attempt on Sunday night they will take tankers into the truck tankers, not Starship tankers, over to the hydrogen and oxygen spheres and replenish those before the first launch attempt, assuming that they're going to make an attempt on Sunday or maybe the day after.
Exactly. We have another brilliant question here from Steve, and they're asking, Shuttle had the beanie cap on top of the external tank to vent liquid oxygen to reduce ice. Does SLS have something similar? If so, where? And I think visually we can say there isn't a beanie cap because it would be on top of the launch abort system, and I don't think that would be incredibly useful. But Philip, is there a similar system in use for SLS, like what the beanie cap did?
There's no beanie cap, but you do see the core stage venting the vent at the top of the liquid oxygen tank. So that and it's a little hard to see on our camera off to the side, but for this vehicle they are able to vent the gaseous oxygen boil off just out into the open overboard. I think one of the reasons that they did that for shuttle was because it was a side-mounted vehicle and you had requirements for the orbiter tiles, the thermal protection system, and you at least had the requirement to not have ice or any accumulation of debris on the vehicle above the orbiter. And so that's why they vented that away from the nose of the external tank, was to avoid getting some sort of a buildup of frost or ice on the nose of the tank.
I think we can actually see this picture here. You can just about see it peeking out just to the bottom left of the white and black tracking marker on the core stage. I think that's it.
Yeah, is it possible to zoom in? The vent, interesting. The vent seems to be angled down, as opposed to just sort of venting out. Just venting straight out.
There we go.
Yeah.
So if you see
so.
that black and white tracking marker, left. You just go down and to the left. You can see it sticking out slightly.
Yeah. So you've got you've got those 4 sort of fingers in the foam. It's to the left of that, and there's actually to the left of the tracking marker, but slightly to the right of the vent is a just vent that allows that area of the launch vehicle stage adapter and the forward skirt to vent, because you also have a nitrogen purge in those areas for flammability purposes, and so that has to vent out also. That's just gaseous nitrogen on fueling days. But another reason why they don't want anybody out there for very long, generally speaking, is that you have not just nitrogen purges through those dry volumes, but then they also get vented out into the open air, and so that's obviously a hazard, a safety hazard for anybody who would be in the area.
Exactly, and that picture was actually part of a new NASA update. Thanks for that, NASA, which says, quote, fueling of the Space Launch System is proceeding on all fronts following earlier pauses on liquid hydrogen flows. They continue that liquid hydrogen and liquid oxygen in the core stage are in the replenish phase. Liquid oxygen has also reached the replenish stage on the upper stage. That's they're using the word stage quite a lot in that sentence. Replenish mode keeps the tank at flight-ready levels by replacing any cryogenic propellant lost to boil off. On the upper stage, the liquid hydrogen fill has moved into fast fill. Following both stages of the rocket being in replenish mode, the launch director will assess readiness to send the Artemis closeout crew to 39B to proceed with Orion closeout operations, including hatch closures. So that confirms what we were seeing earlier a few minutes ago on the fueling graphic NASA was providing. Again, they're not providing that the entire time, so we can only show you that when they show us that, which is slightly annoying, but it does give us periodic updates into the percentage of the fueling on each of the tanks on this rocket that we are keeping an eye on. So that is a more positive update from NASA. Again, they are running a little bit behind on that hydrogen fill, but I think it's, correct me if I'm wrong, but I think it is at least a positive step that they have managed to get the hydrogen tank on the core stage up to 100%, and they have managed to work through the leakage to completely fill that tank with hydrogen.
Oh, it's absolutely like a positive step. The fact that we've gotten this far, I think our spirits were slightly dampened earlier as we started to see echoes of some of the countdowns from Artemis 1. But now that everything has since been proceeding well, I think that's a really positive sign that, maybe it will complete their wet dress rehearsal as needed today as they work closer. We're at about 3 hours and 45 minutes according to the clock, so we'll have to wait and see. There's no counting your chickens before they hatch or whatnot, but we'll just have to wait and see, and this is certainly a positive step forward so far.
This might just be my eyes, but I'm not sure if that is a new vent that has appeared right next to the ICPS, just above the seam between the ICPS and the core stage.
No, I think that's right, because when the stages get close to full, then they will start venting to obviously control the pressure, and so you will see. I believe ICPS has 2 oxygen vent ports, and so I do see at least one of them that's beginning to slowly vent. But I mean, again, if the tank, I think the last we saw it was around 60, so maybe 2/3 full. Maybe it's probably more than that now. But I don't see anything. Oh, I'm just looking to see if that was an update. But I apologize, it was muted. But I agree with what Dee was saying earlier. I think that it is probably somewhat instructive. To one thing that I'd forgotten about for the launch attempt that succeeded for Artemis 1 is they took a long time to deal with the valve that had gotten that they needed to send the red crew out there for. So I do think we will see when they get to stable replenish, if they're ready to send the closeout crew out, when that happens and how and what time that is. And so we might not be hours behind. It's possible that maybe we're only an hour or so behind. And that's reasonable, I suppose, if you're talking about a 4-hour test window tonight. I think the bigger picture question, though, is, and I'm sure this will get asked tomorrow if they do the post-test briefing tomorrow, is what happens the next time you tank this vehicle? Do you have the same thing happen again? And is this a reasonable thing in terms of babysitting propellant loading to do that every single time you need to tank this vehicle? Because it's possible that you may have to do it more than once more.
Exactly. We've got a few more questions coming in. We have Box, kind of on that point of that post-testing conference. Box is asking, how long after the wet dress rehearsal will we receive a possible launch time? Philip, do you know? I would say it will probably be at least a day or so.
Yes, and I think probably so. One of the nice things is that it sounds like they're going to do a separate briefing, a separate post wet dress rehearsal briefing tomorrow, and but then I'm still expecting that if they conduct a flight readiness review later in the week, maybe Wednesday, maybe later than that, that we will get a briefing at that point. And that was where they were supposed to set a launch date, was in the agency level flight readiness review. So we should at least get some idea, if they do a briefing tomorrow, whether they're still progressing down that timeline. Obviously, if they don't do a flight readiness review, then we know what that means, which is that they're not ready to go. But what I would say, if on a nominal timeline today, if we had had an uneventful test, we were probably looking for the flight readiness review, maybe Wednesday, maybe Thursday, and then they would set a launch date then. And again, the thing is, of course, they only have three nights in a row left in this window: the night of the 8th, the night of the 9th, and the night of the 10th. So they're going to have to pick one of those as their starting point. And so it's already kind of been narrowed down by celestial mechanics which day it's going to be. They can pick one of three now for their first launch attempt, or they can punt to March.
And they have plenty of launch window availability going forwards in March and April. Of course, it'd be a shame to see it pushed to that point, but that is simply from I want to see this thing launch as soon as possible point of view. I'm not the person in charge of launching the rocket and putting crew on board, so obviously we want them to do the correct reviews and everything required for that process. We have got a little bit more support over the past few minutes. First of all, Amy saying a awesome day for a wet test and progress with a $15 super chat. Thank you so much for your support. Patrick, who has picked up the Blame Hydrogen t-shirt, saying public shaming does work. Because, as soon as we published that merchandise, suddenly the core stage filled up to 100% without issue. So I think there is something in there. We also have Dramatic becoming a PadRap member. Turtle Sanctuary with a $5 super chat saying, Philip gets the hard questions. Here's one for Ryan. How do you pronounce the atomic symbol for hydrogen backwards? Well, it's just H, isn't it? H is the same. It's just one letter. So H forwards is the same as H backwards. I'm not quite sure on that one, Turtle Sanctuary, but thank you for the support nonetheless. We have Crafty Geek as well supporting us with a $5 super, saying, good job bouncing back, SLS. Remind me, Blue Origin's human landing system isn't hydrogen fueled, right? All of this talk about lunar hydrogen when it's so tough on Earth. Well, it actually is hydrogen filled. But Philip, as you were saying earlier, there are many, many stages, upper stages, fueled by hydrogen. And they don't seem to have the same leakage problems that SLS has with its core stage.
Right, and I'm not sure. It would actually be kind of interesting to compare the sizes of, for instance, the cislunar transporter that Blue Origin is designing to the core stage, and how big the tail service mast umbilicals. We did hear, and I'll forgive me because I'm going to use the English units, but the quick disconnect diameters on the tail service mast umbilical for hydrogen it's an 8-inch diameter quick disconnect for the fill and drain line, and a 4-inch diameter for the bleed line. And so I'm not sure they're going to be that big. I'd actually be kind of curious how big the quick disconnects are going to be on Starship for their fuel and oxidizer. But yeah, it's you can't necessarily, just like you can't necessarily publicly shame everything into existence. I'm not sure that we can extrapolate from this vehicle to anything else.
Yeah, and that is 20 centimeters and 10 centimeters respectively on those disconnect sizes. And finally, we have a whopper of a super chat. We have a $50 super chat and no message from John. Thank you so much for that support. But yeah, no message, but $50 of support, which is a considerable amount of support. And we are extremely grateful for every bit of support, but especially big support like that, because it means we can keep doing what we are doing and bring you the best coverage possible of humanity's return to the moon, which is very exciting, and still, still every time I say that, it's still a pinch me moment, because it's hard to believe that it's actually maybe finally upon us. The taxpayers have spent God knows how many billions of dollars, or whatever currency you use, on this vehicle. So many years have been spent on this vehicle, so many working hours have been spent on this vehicle, and finally it's on the pad and ready to launch, or nearly ready to launch 4 people to the moon, which is it's so kind of relieving to finally be in this position to launch Artemis II. We have another question here from Dave asking, if they can't do the February launch dates, do they do another wet dress in March, just a tanking test, or will they move straight to launch attempts? Philip, what do you think?
I think that if they can't, they don't have to wait until right ahead of the launch period. I think one of the reasons that they scheduled this test, or this was the soonest that they could get to it, either Saturday, either a tanking day on Saturday or a tanking day today, just because of all the work it took to get the vehicle ready to roll out in mid-January. So, long way of saying, if they wanted to, they could do another tanking test next week, or they could do a tanking test every week. I don't know that they would necessarily do that, but if they feel like they need to do another tanking test and push to March, they would have most of this time to do that, and they wouldn't necessarily have to wait until right up against the window. It's just they've one of the reasons why, if for instance the February window was a week later, they might still have enough time to address whatever they've found today, and then be ready to launch. And so we were sort of a chicken and egg thing where maybe they're ready to launch next week, and it's just that they don't have a launch window until March at that point. And so they were hoping everything lined up so that they would be ready to launch by either the 6th or the 8th, and we're just going to have to wait and see whether they can still get there. And so it'll be interesting to see how far they get today, and where they and definitely to hear how they feel tomorrow. If they're able to get through everything, they won't have 4 hours to work with for a launch window. They'll only have 2. And so one of the things I'm going to be curious to see here is when they get, if they're able to do their terminal countdown runs tonight, when do they get to the first one? How far past 9 p.m. are they? And we're getting the graphic up here, and so we can see the ICPS liquid hydrogen is up to 86%. So we're here, 5:25 p.m. Eastern approximately. I think on a nominal timeline, they would probably have wanted to be sending the closeout crew out about an hour ago. That it would have sort of coincided with when the clock picked up at 5 p.m. Or actually, when the clock held, which would have been 40 minutes earlier at 4:20 p.m. I'm sorry. But I think there are going to be these questions. And then again, something that also occurs to me is I don't understand why the ICPS liquid hydrogen is at 395 degrees Fahrenheit, minus 395, and why the core stage is minus 295. And I'm wondering if that typo is also hydrogen's fault. But anyway, aside from that, it is going to be interesting to see kind of how they're looking at this philosophically tomorrow, if they are able to accomplish everything that they want to get to, but it takes them, they eat up a lot of that 4-hour window, a lot more than they were planning to. Because I think that's, to me, that's the obvious question at this point is next time you go to tank this, how confident are you that you're not going to see the same thing that we saw today?
Right. And just for a quick comparison, the last time we were seeing this graphic, it was about just over 20 minutes ago at this point, and the hydrogen was at 61% on the upper stage. So they've fueled it by a good 25% or so since that point. Or has it just gone down? It's just gone down from 87 to 86%. I don't know if that's just a sensor being triggered or if they are now
Maybe it's an estimate.
offloading.
It's
Yeah.
possible that
Oh, it's back up.
also possible that it's also possible they're right on the right on the threshold of the
Right.
86.9, and they're also losing a little bit to boil off at the same time.
Right. Okay. Well, it's just gone back up to 87, so that is probably what it was. So okay, now it's back down to 86.
Yeah. I mean, you would think fast fill would be faster than the boil off rate, but what do I know?
Right. Yeah. Fast fill, maybe not fast enough fill. Maybe we need faster fill. That's what we need.
But then they're not seeing any leaks on ICPS, so there's that.
Yeah. Still seeing that vent from the stage as well, which has been going for a good while at this point. But yeah, this is certainly. If you were to ask me a few hours ago when we first got reports of those hydrogen leaks on the core stage, if this was going to be a good tanking test, I would have been a little bit skeptical of that. But it is fully loaded now on the core stage and getting to that point on the upper stage. So certainly plenty of data is being collected by NASA teams at this point as we continue to count down towards that simulated launch window, which we are probably expecting to be delayed just a little bit, but we will have to wait and see. See if we've got any more questions. Again, if you are just joining us on part 2 of the Artemis II Wet Dress Rehearsal, make sure to tag us in chat at NASASpaceflight or at NSF, and that brings all of your questions into the chat. Or if you want to do an order on the store, there's a checkbox you can tick when you do your checkout. So if you want to send a message that way, you can also do so. And that comes into the same queue in the background here, so we can bring them on the screen. Have a look through here. We have a question here from. Well, actually, we have 2 questions here. We have Resisto Jet and we have Phobos. Resisto Jet asking, is Artemis II fully fueled before the crew enters the Orion capsule? And we also have Phobos, who is asking, why do they fill up the tanks way earlier compared to Falcon 9, where they complete only a couple minutes right before launch? Is this just for testing? So, Philip, do you want to just explain some of the differences? Because if for people who might have, started getting involved in spaceflight over the last few years, they might be very used to the fact that SpaceX puts the crew on the rocket and then fuels the rocket. But for a very long time, I think always, NASA has done the opposite, right?
That's correct. I think in the past, and we're seeing the fueling graphic, and interestingly, the ICPS total is still kind of stuck there. So I'm wondering what's going on with that. But this is more of a traditional way of loading the vehicle, where and this is a traditional vehicle where the propellants are stored close to boiling point, as opposed to super cold or super chilled or densified, depending on what you want to call it. But what they do is they load all 4, in this case, well, they load all the stages with their propellants. They get into a stable replenish mode where the flow rates are very low, and then that's when the crew gets on board. And that's how they did it in shuttle. That's how they did it with Saturn, although I don't know that they necessarily used I don't know that they called it stable replenish. It's a little bit before my time, but I think they did get to a stable point in fueling the vehicle, completed, quote unquote, completed fueling of the vehicle before the crew got on board. What SpaceX has done, and I think if you recall back to the first launches of Falcon 9, they actually did it this way at the very, very beginning, but then they saw the performance benefits from densifying the propellants, supercooling them, and then they've also continued to pursue. They just have continued to pursue that, and the idea of making the fueling process as short as possible. And so I think they're continuing to you've seen them continue that process and that evolution out even farther with Starship. And I think this is just the traditional way of doing things. So I think if you saw a Falcon or a Starship where the fueling process was a little bit longer, then the crew would just have to be on there for longer. But the crew also only has a limit to the amount of time that they can lie on their backs before liftoff. So I'm not. It would be interesting. I can't recall off the top of my head how long before propellant loading, but I think they would still be able to. The crew would still be able to get on board a Starship before they started fueling that. But this is just the way. This is the way that they do it, and it didn't take the difference between shuttle and this system is that there's the additional stage, the interim cryogenic propulsion stage. But then you have a bigger, the core stage is a bigger, the tanks in the core stage are bigger than the external tank, significantly bigger. And so it takes a little longer to fuel that. But then you also have 2 stages, and they all have to you have to finish loading on all 4 of those tanks before you can load the crew onto this vehicle. So, and one of the other things that might be kind of interesting tonight, I wouldn't necessarily expect it, but I guess it is possible, that the closeout crew might be able to get through their timeline in a little bit shorter period of time. I wouldn't necessarily predict that, but that may be one way that they can pull things in, because I think if this were a launch attempt, they would be looking to try and make up some time, because I do think we will see how far into the window that this takes them before they can actually make a terminal countdown run. But if you were only looking at a 2-hour window, I think we'd be wondering about how close to the end of a 2-hour launch window they were going to get.
And just a few moments ago, we saw the graphic again with the fueling numbers, and the liquid hydrogen on the upper stage was dropping from 66% to 65%, and then back up to 66%. So, I'm not an expert. I won't call myself an engineer, and I don't understand this vehicle as much as NASA understands this vehicle. But that is now multiple minutes where the supposed fast fill hasn't exactly been filling that tank. So that's certainly something we are going to be keeping an eye on. We'll see if NASA provides an update at all. The last update we got from them was 25 minutes ago, so we will see if anything else comes in shortly, but that certainly doesn't seem like fast fill to me.
Yeah, I agree.
Let's have a look through here. We have a little bit more support that's been coming in over the last 10 minutes, so I'll make sure to thank these people. First of all, Jared not only gifted 5 Red Team memberships, but became a member themselves. Thank you very much for that. Aid Astra says, we need ludicrous fill. I think the ICPS needs that. And Hop Haze, with a $5 super, is asking how many Toyota... I don't even know how to pronounce that. Mirai? How many Toyota Mirai's worth of hydrogen does it take to fully fuel SLS? Cheers from Indianapolis. Tell Phil to hurry up. What is your estimate there, D?
Yeah, so I did a few quick calculations, and it's roughly 25,676.4 Toyota Mirai's worth of hydrogen in SLS, if I did my math right.
That's a lot of cars. Now, D, do you expect there to be more or less cars parked at the press site on launch day?
I think purely based on limitation of press site parking, it is certainly going to be less cars than the amount of hydrogen that would be needed to fill SLS.
Okay. Well, I was just thinking, because maybe, if they need to do a 24-hour turnaround and they run out, then they could use the cars to, tap in.
I don't think NASA
to the hydrogen supply.
I don't think NASA would want all the hydrogen cars to be stranded at the press site.
Or, when they launch the rocket, they'll have a load of hydrogen they won't need to be using for 3 years. Why not donate some to the press corps, Anyways. We also had Chris with a store message. Chris has got the Blame Hydrogen shirt saying, I'm coming to the Cape this weekend, hoping for a launch on Sunday night. Well, if they can get this ICPS loaded, that could potentially happen, but it's not looking the most straightforward process right now. I'll say that for the time being. And Duthima, sorry if I pronounced that wrong, but thank you for gifting a Red Team membership nonetheless. So many memberships have been gifted on this stream today. It is wonderful to see. So thank you so much for all of this support, because we literally could not do it. We could not do this without it. I know I say that a lot. It might sound like a broken record, but that's because it's the truth. We genuinely could not do this without your guys' support. So it means a lot to helping us do this and bring this to you, and hopefully broadcast the return of humanity to the moon in a week's time. We have a question here from Tom Collins, who's asking, why is the hydrogen tank on the ICPS smaller than the oxygen tank? And D, this is simply because hydrogen is atom number one. It's element number one. It's much, much, much less dense, right?
I am actually not sure the specifics of that, comparing them all to the core stage. I think Philip might have the solid answer on the explanation, because it looks very different from the proportions you see on the core stage.
What I'm doing is I'm going to go see if I can pull up the SLS reference guide. But I think if you were to just eyeball the tanks for the ICPS and same for the core stage, the physical dimensions of the liquid hydrogen tank are larger than the liquid oxygen tank, if I said that correctly. But because hydrogen is much less dense than oxygen, you get this. It's somewhat counterintuitive is the way I put it. But let me pull up the numbers for the because when you look at the gallons, for instance, and they seem a little bit counterintuitive to me. But if you just look at the dimensions of the tanks, they do look. But let me pull them up for grins.
We'll stand by for
that. At least attempt to pull them up for grins.
In the meantime, we're getting a wonderful sunset over 39B here. So certainly no lacking of views with this tanking test. With not only the D, how many cameras have we got set up? How many NSF cameras have we got set up right now looking at this rocket?
Oh, okay. So actually less than I planned on. It was we were still setting up extra cameras while live, so you might have noticed a few things. But right out here in front of the building we're at, we have 5 cameras there. I've got another camera on the lawn with that RS-25 shot. We've got 3 cameras that are in their permanent installation here on the building. And on top of like all of our own cameras capturing this, there are also there's different hardware necessary for us to bring in these NASA feeds like you have on the right. So we've got a whole bunch of that stuff that's all necessary in order to put this production together. And believe me when I say, when we actually get to launch day, it will be a significant number more than this still.
Yeah, and, you know, I'm not going to leak anything, but all I'm going to say is the area around the press site, there's only really one cell tower to connect to, and it's on top of the vehicle assembly building. So when you have thousands upon thousands of members of the world's media there, and they're all streaming from their phones, and everyone from Titusville is streaming on their phones, all of those networks kind of shut down. So we've been doing a lot of work to kind of prepare to actually have an internet connection, at the very least, to actually get the feeds out of Kennedy to everybody's screens.
Yes, we were hoping to have that up and running, and we will very, very shortly and give that all a full test. But even today, we've started noticing some of the LTE issues. You notice it on any big launch when there are more people than anticipated. And even though it's a very small fraction of those people that will actually be here on launch day, you're already starting to notice impacts to the infrastructure. The internet connection here is degraded. And so there's a lot that goes into making sure that we have reliable connections for all the cameras, that we have backups, and that we can continue to communicate and provide these feeds to you, even when, like, you'd think that, hey, we're pretty close to civilization, it should have a good connection, right? But there are so many things you aren't prepared for, all the RF. You just have to be ready for that, and we've been doing a lot of work, and we'll be continuing to do more work throughout this week leading up to launch.
And I believe we may have just gotten an update, yes, from NASA on that ICPS, the interim cryogenic propulsion stage, saying, quote, following the vent and relief test on the ICPS liquid hydrogen tank, NASA teams have entered the topping phase of fueling liquid hydrogen. The vent and relief test verifies that the vent and relief valves operate correctly to maintain safe pressure levels inside the upper stage liquid hydrogen tank, while topping ensures the upper stage tank reaches full capacity. Following topping, teams will move to replenish mode, keeping the ICPS tank at flight-ready levels into terminal count. Meanwhile, all other propellant tanks on SLS are in replenish mode. So that means the hydrogen on the core stage, the oxygen on the core stage, and the oxygen on the upper stage are all in replenish mode right now. The hydrogen on the upper stage is just now catching up. So maybe those differing percentages we were seeing earlier might have had something to do with the vent and relief test, that they were just kind of temporarily pausing the load. But at least according to NASA's official word here, they are going ahead to fill up the rest of that tank, which is something that I'm very happy to read, at least. Philip, I don't know if you've managed to find the SLS, what did you say, like the SLS user's guide
the
or
reference
something?
guide, but
The reference
unfortunately
guide.
they don't do a breakdown of the capacities for the ICPS between the tanks. But I think if you look at them, you can see again the hydrogen tank is the one. They're oriented differently than the core stage, where the oxygen tank on the core stage is above the hydrogen tank. On ICPS, the hydrogen tank is the 5.1 meter diameter tank, and that's the part, the actual exposed part of the stage that you can see. So it's in this view, it's right below where that checkerboard, where that photogrammetry marking is. That's actually not part of the stage. That's the Orion stage adapter. So but that's all we're seeing here is the liquid hydrogen tank of ICPS, whereas the liquid oxygen tank and the mid-body and the RL-10 engine are all packed inside the launch vehicle stage adapter below it. And so the liquid, I don't know what the diameter is of the liquid oxygen tank, and I'm not sure that that's specified in here either, unfortunately. And so it's possible that Wikipedia has numbers, but I'm not sure whether they're pulling those from the Delta 4 cryogenic stage, which is the same diameter as the ICPS, but they did stretch the length of that tank by about 1.5 feet. So that would obviously affect the capacity as well. But yeah, so unfortunately we don't have hard numbers on the capacities of the tanks, how many gallons they hold and how much that weighs.
And we have a comment here from Mike following up to your calculations on the Murai D, because they're saying that the calculations is almost exact the total number ever built. I don't know if D is still with us.
Yes, I am. Sorry, I was realizing perhaps the graphics might have been switched around because, like you were saying earlier, this is a test run for everything. So I think the graphics might have displayed stuff, but as expected. Like the hydrogen tank is larger than the oxygen tank rather than the other way around. But yeah, the same number of the total ever built. There has to be some sort of meetup at some point. All the Mirais get together within SLS and they see who's holding the most or hydrogen.
Yeah. Maybe a little photo shoot maybe for Artemis 3. Or maybe Artemis 2, depending on how long it gets delayed. Oh, who said that? Anyways, swiftly moving on. Let's see here. We have Cool Guy J1. They're asking, when are we going to land on the moon? It's such a short and simple question, but nobody seems to have a conclusive answer. I think I'll just go around the room on this one. Let's start with Philip. Philip, when do you think Artemis 3 is actually going to happen?
I think it'll be. I don't think it'll be by 2028. But after that, I'm not sure. I'm frustrated by not having enough information to even make an educated guess. It's which I find to be silly, because in a way the secrecy actually makes me more pessimistic about that than it would otherwise be. So that's kind of my answer.
What do you think, D? When Artemis 3 ?
I've shared my thoughts on this on a TFT before, and I don't want to sound overly pessimistic, but I think I will be pleased if it happens before we hit 2030, to be totally honest. Like there's a lot of work to do with the actual systems, getting people on the moon, and I really hope that the timelines earlier than that hold, and we just aren't seeing on the public side quite how close some of these systems are. But we'll just have to wait and see. I really hope I am wrong and that date is sooner.
And we have got a ticker update from NASA that all stages are in replenish, which should mean all of the tanks, so both tanks on the core stage and both tanks on the upper stage, are at 100%. So that means this rocket is finally fully stacked. Fully fueled. Which is, I think that's good news.
Right, and this is when the next thing we would be expecting to hear is that Charlie Blackwell Thompson, the Artemis launch director, gives a go to send the closeout crew out to the pad. We might even see some vehicles in the NASA shot, and maybe, I don't know if we can see it from ours or not. You'd have to actually be able to see the pad's surface. Yeah, no, we would be able to see it perhaps from here. But hopefully we will get a ticker update before we start seeing vehicles. But I guess either one of those will count as confirmation.
Yeah, we are expecting the big white Closeout crew van to drive past, if that's what they'll be riding in, because that is probably the easiest vehicle to pick out amongst all of the other vehicles. One of the great things about the vehicles involved in this program is that, unlike at Starbase, everything isn't either a white pickup or a Cybertruck. At Starbase, every single vehicle is a white pickup and a Cybertruck, and you can't tell anybody apart. But the great thing is, at NASA, at least they actually paint on the side of the vehicles what is inside. So the Closeout crew have their own Closeout crew van, which we can actually distinguish amongst all the other vehicles operating at the Kennedy Space Center. So Julia is informing me they are currently staged next to the press site right now. So as soon as they get the call out to head to the pad, I'm pretty sure we will be able to show that pretty soon.
Yeah, that's interesting. I haven't had a chance to go look out. I haven't had a chance to go outside and take a look in a while. But yeah, we should keep an eye on that, because that probably would be the fastest indication we would get that they're headed out there. Interesting, because they did talk about, I spoke with Taylor Hose, who's the Closeout crew lead, a couple of weeks ago, and he talked about them staging at the AB11 roadblock, which is out here by the press site by OSB2, but then that they might go into the AB5 roadblock, which is up at the split where the crawlerway splits between Pad A and Pad B. This is up by the observation gantry, where, if for folks who are familiar with the Kennedy Space Center Visitor Complex tour. But under these circumstances where they've had issues, it's possible that they're not quite doing the exact same thing that they would do on launch day, because they're not going to have to they're not going to do the crew ingress part of the closeout procedures. They'll go up there, they'll make sure that the crew module's configured to close the hatches, and then they will be spending a lot of time on Orion hatch closure, LAS hatch closure, and then doing the final white room breakdowns, and then leaving the pad. But we're at this point now, we're waiting. And originally we had expected, again on a more nominal timeline, to see all stages in stable replenish around 4:20 p.m. And so we're about 90 minutes behind that. But again, we'll just have to see. We'll just have to see where things go from here.
Yeah. But even so, on a launch day timeline, that sort of timeline is also when we would expect to see the crew heading out to the pad, by which point the closeout crew would have been there before the flight crew gets to the pad. So that would have been several. I'm just looking through the timeline here of when the closeout crew assemble at L-5 hours and 40 minutes. Closeout crew to the white room at L-4 hours and 40 minutes. So they would have already been there around the same time that the replenishment would have started on all stages there. So slightly different timeline.
Yeah, well, I think the plan was to send both crews at the same time at this point in the count, where all stages are replenished. Then they would send both crews at the same time. It's just that the closeout crew is starting about 15 minutes ahead, since they're here at the press site, or adjacent to the press site, and the flight crew is back at the ONC building in the KSC industrial area. It's down Kennedy Parkway. So, but this would be, and again, when you started talking about launch window, I was thinking, well, that's the thing here, is how far into the launch window are we today at this point, and how much time can they make up? But again, of course, this isn't a launch day, so.
Yeah, this is a simulated window, doing everything apart from putting people on board the rocket and actually launching the rocket. The final point we are expecting to go up to is T-minus 33 seconds, which is on launch day, when the ground launch sequencer would send that go for automated launch sequencer command and basically hand off control to the rocket from the ground system. So we are, of course, not going beyond that point today, because we are not launching today, regardless of the status of the rocket and the status of the ground systems. Let's have a look for some more questions. Bloz Aviation is asking, do they remove the crawler from the pad before launch, and if so, how? And Philip, as soon as they kind of set the platform down, I believe they roll the crawler to the gate, but do they then move the crawler even further away before launch?
Yeah, that's correct. So the crawler, the mobile launcher sits on pedestals wherever it is sort of permanently. So either at the park sites outside the VAB, inside the VAB, or out at the pad. So when the crawler goes to move it somewhere, it rolls in underneath the mobile launcher, picks it up off the pedestals, and then takes it where it's going. So when they rolled out, they lowered it hard down on the pedestals. That's a big milestone. And then immediately, within hours, rolled out to the outside the pad gate. They should have rolled probably back to the old Apollo mobile service structure park site, which is again sort of adjacent to that observation gantry area where the crawlerway splits between pad A and pad B. But I believe they could even they could even bring it all the way back out here to the crawlerway. Their maintenance yard is out here outside the VAB as well. If I had to guess, without being able to see it, they've probably moved it back past the pad gate. But I'm not sure we've gotten a heads up exactly where they've positioned it for launch.
Apparently, it is by the gantry, the Launch Complex 39 gantry.
Okay. And there used to be a, I can't remember if there were pedestals there, but there used to be a place where you could, obviously, I was calling it the mobile service structure park site, and that's where they would park that, I think, during launch operations. And that was their temporary thing. But and then they used to park shuttle mobile launcher platforms out there as well. So that's a typical place for them to go park.
Yeah, it's a little convenient location that just off the crawlerway that it can be parked at. And I am just looking at some satellite imagery from Sentinel-2, which is a Earth observation satellite, and I think I can just make out the crawler parked there, just by the 39 gantry. So if you are on the Explore tour and you head out to the gantry, keep an eye out for the crawler, because that literally just rolled 2 weeks ago, this giant rocket out to the launch pad. So that's pretty cool. Starting to get some more purple hues in the sky at this point as the sun sets over Florida. But we are staying live, and thankfully NASA has a lot of lighting around 39B, so we can continue to get some good views of the rocket even when the sun sets. And just seeing the final moments of sunlight here before it dips below the horizon at the end of the day. We've got a little bit more support in chat. First of all, we have Arthur with a $5 super saying, I'll be out at the Cape for the launch window. Go Artemis, and hello from the MBL team. D, that might be somebody you might have run into at the MBL.
It certainly is. Hello, Arthur. Thank you for the support, and it's great to see your name in chat.
We have Drunar saying, did NSF install the D-Link network router?
Actually, yes. That is supporting 3 of the cameras out there today, and it proved to be helpful. We avoided it at first, and we're running into network issues, and we got it in place, and things seem to be more stable. Kevin, let me know if it stops working so smoothly. But yeah, we have that running to help smooth things over.
Bideford is in chat again, saying with a $25 super, thank you so much for your support, Bideford. They're asking, are you allowed to run Starlink while filming to upload to YouTube? I believe we use Starlink at the press site, right, D?
Absolutely. So it's something we don't put all of our cameras over. There are challenges that come with Starlink. You'll hear us talk about things like the satellite handovers, and those have gotten far better with time, but you will still have momentary dropouts. So that introduces challenges when you're putting together feeds, and the latency difference from Starlink to other connections also introduces more challenges. But for something like Artemis, these are incredibly important missions. We're absolutely going to be having Starlink out. We're going to have stuff on basically every form of connection we can to make sure we have as much redundancy as possible. So even if something does go wrong, something does stop working, we have other systems that aren't connected to that so that we still are able to bring you these excellent, excellent views.
We have Turtle Sanctuary with a $10 super. They're saying, in future, please don't bully hydrogen. You wouldn't like hydrogen when hydrogen gets angry. That is a good point. But, you know, hydrogen needs to stop leaking. Just saying, hydrogen needs to stop leaking. It's very annoying.
I think hydrogen was already angry twice today, and that's what brought us to where we are now.
Exactly. And we have Rory gifting a Red Team membership. So thank you, everybody, for all of the support on today's stream as we count down in this first and hopefully last Wet Dress Rehearsal for Artemis II.
I hope so.
Yeah. Have a look through here because we've got some even more questions in the queue over the last few minutes. One of them from ResistoJet, who's been asking some very good questions today. They're asking, does the Closeout crew practice loads on the ground and each person have a strict set of things that they need to do? Well, Philip, I know they're numbered, but does that number also designate kind of their role and what tasks they have to do on launch day?
Yes. So the lead is Taylor Hose, who I spoke with. He's number one. Number two is the astronaut support person, and that's supposed to be Andre Douglas. He's the prime ASP for the closeout crew. Both he and Jenny Gibbons, who are the backup crew members for Artemis II, both trained on that, and so we've seen both of them out there, either in the ONC building with the crew, or out at the pad. But number three is the lead suit technician for the launch and entry suits, and so he will actually accompany the crew from the ONC building when they go out to the pad. But I think today he's just going to ride with them from out here at the roadblock adjacent to the OSB2 building. And then 4 and 5 are Orion technicians specifically. So, pardon me, that's I believe that there are just 5 people who are going to be a part of the closeout crew. And then we do see some other personnel in the ONC building in those sort of white jumpsuits, but I don't know that they're necessarily. Somebody was trying to look for the closeout crew there, I think.
Oh, yeah, there we go.
Okay.
They're headed to the pad right now.
All right. So yes, and we should see. Let's see. I think I saw somebody pointing this out either earlier in the stream or something like that. That you're still seeing tour buses go by. Go out there. You're still seeing, and so. Yeah, it's a little different because I think usually you would see on a launch day you'd see a roadblock, up here somewhere. But given the amount of auto traffic here, I'm not sure that there is one. But yeah, that's a good sign, and we would want to see that van continue out there to the pad. But so what is it? It's a little bit after 6 p.m. Eastern time right now, and so it's still in that sort of 90-minute ballpark from when we expected to see them go out to the vehicle on a nominal timeline. So, but again, and unfortunately, we're not expecting to see them in the White Room tonight. But then again, big picture, NASA has given us the strong impression that we will get a much more complete array of cameras and enthusiasm, I think, than we got today from them for this test. And so I don't, maybe this is hydrogen karma for them not going full out for this test today, but we will see them in the White Room on launch day.
And while the closeout crew heads to the pad, NASA is providing us with a new update on the fueling state of the entire vehicle, and I'm very happy to report that every single tank is at 100% fully loaded on the core stage and the upper stage. So all of the oxygen and all of the hydrogen is on this vehicle, is replenishing, which is a very nice, stable state to be in to send that crew to the pad.
And it looks like they fixed their graphic. So they either raise the temperature in the ICPS liquid oxygen tank by 100 degrees, or they just fix the graphic.
Yeah, I'm gonna hazard a guess that they might have just fixed the graphic, although the color is still the wrong way round on the graphic,
right?
Because it's still saying that the oxygen is in the hydrogen tank and the hydrogen is in the oxygen tank, which I don't think is the case.
Well, I guess I'll count one of those things as a win.
Yeah. And we were just seeing there, we have one of our cameras trained on the ramp up to 39B, and that is when we should see, that's where rather we should see that closeout crew van going up momentarily. So fingers crossed we see them riding the ramp up to the top of 39B very shortly as we head up towards the pointy end of the count. Still, 3 and a bit hours left to go, considering the delays that we've had. But apart from that, Philip, I'm not sure if we'll see any more kind of visual indicators, maybe until the crew access arm retracts.
Yeah, well, we will see the closeout crew leave the pad area. So when we see them drive up here, they'll park. There's a structure just kind of the lightning tower on the left, kind of obstructs it, but that's the structure. There's an elevator that they take up to to the level where they can get out and then walk across the zero deck of the mobile launcher and then get in that elevator and go up, kind of like in really large buildings where you can't take one elevator from the ground all the way up to the top. But we will see when they're done. They'll break down the white room. They'll swing away the dock seal, and then they will repeat those steps going in reverse. So they'll come down the elevators, get back in their van, and come back away from the vehicle. If they continue with the countdown this way, the nominal timeline would have had them leaving the pad before the countdown got to that last hold. I think now we're likely to see that hold extended, and they will still be there finishing up. But we will be looking to see when, because I don't think that we've actually gotten quote unquote confirmation. I think it's self-evident that they're going to the pad, but we have not gotten a confirmation from NASA that they're doing that yet. So we'll just be watching. I hope we'll get a chance to see the van drive away, and then we will. I'm not sure what they're going to do with the countdown clock when they get down to, because when at some point the L- clock is supposed to become the T- clock, and so then the only thing we'll be able to visually see is the crew access arm swing away from the vehicle, and then when they cut off and recycle, it should extend back up to Orion relatively quickly. So I'm not sure. I'm not sure exactly what we're going to see tonight, especially in terms of situational awareness when we get down to the final countdowns.
And a few minutes ago, about 5 minutes ago, NASA posted a new update to their blog post saying, quote, NASA's Closeout crew is preparing to head to Launch Complex 39B. So I think that was probably written before that point, because
it's possible because Taylor Hose did talk about this going from one roadblock to another. It is possible that is part of the sequence. So maybe they are just redeploying, and they still there is some either decision or something else that needs to happen before they're released to go all the way to the pad. So this is still a good view to keep an eye on, though.
So they could be waiting rather kind of near the gantry area at the edge of the blast danger zone to stay out of danger before being cleared into the pad. Is that what you're saying?
That area is where there are. I'm not exactly sure what the terminology is, but there is a small crew of, I guess, what I would call first responders who are stationed there in an emergency, and so the crew would have to get themselves out to that area in those MRAP vehicles that are parked where the slidewire baskets would end up if they ever had to use those. But they are stationed out. That's at least closer to the pad, and so that's my understanding of where the closeout crew, where that AB5 roadblock is versus the AB11 roadblock, which is out closer to where we are here in this sort of Launch Complex 39 area around the VAB.
Nonetheless, we are keeping an eye at the base of the ramp there. And the nighttime is also giving us a excellent view at the flare stack for the hydrogen there at 39B, which is wonderful to see. Keeping burning off the excess hydrogen there, keeping everything safe. We continue to count down. Let's see if there's any more questions. I'm scared to look over at the question queue in case the van pops up from above the trees there, but I'll try and look for some more questions in the meantime. Work hard, play harder is asking, did they reinforce the elevators? If you are not aware, on Artemis 1 there was a little bit of a problem where there was some damage to the mobile launcher. But Philip, do you know if they've done any work to reinforce the elevators, or are they just going to accept the fact that the solid rocket boosters are very powerful and SRB versus elevator, I think the SRB will win?
Yes, but it is the former. They did reinforce the protections. I think they were supposed to have I don't think they're called blast doors, but they did have they did have protections that they'd installed, but they weren't strong enough, and so they've beefed up those protections for based on the experience of the first launch. I mean, probably the longer term damage to the mobile launcher that occurred from the launch was the damage to the pneumatic lines, which prevented the normal automatic pad washdowns that occur, and so that solid rocket booster exhaust residue was allowed to sit on the structures, and that's very corrosive, and it did damage to those before they were able to go out there, and so the liftoff and the climb out busted some pneumatic lines, which and those I believe those were using nitrogen, and so we were just talking about how when they're doing nitrogen purges on the vehicle, it's not a good place for people to be, because there's only so much nitrogen you can take in the air. So 100% is not good. And so because they had a busted nitrogen line and that was leaking, they were not able to go into the pad area post-launch for, I think, several days. Whereas typically they'll send the initial crews out there, if it's safe, within hours, if not hour, after launch. So if I think, although the blast doors and the protections for the elevators were maybe more picturesque, I guess, repairing the pneumatic lines took a lot longer and were a much bigger problem. If they eliminated if they were able to get the pad washdowns and not blow out any of the pneumatic lines, but they had some elevator damage, I think they would take that. I'm sure they don't want either of those to happen, but that was the bigger issue for the Artemis I launch in terms of damage to the mobile launcher structure.
Continuing on, I still don't see the van, so I'll be asking more questions.
Where did you just just out of curiosity, where did you see that update, Ryan? I don't see that on the blog. Maybe I'm having a caching issue with my browser.
The update where they said the Closeout crew was preparing to head to 39B. I refreshed. It says it's the latest one in there for me at 6:03. Okay. It says it right at the bottom. It's like the last It's like the last sentence before they say a 24/7 live stream. Blah 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 blah.
Right. I'm just not seeing it, but that seems very intentional the way they phrase that.
Yeah.
As opposed to going in, that they're preparing to go in. So I'm not seeing that right at the moment. But I'll take your word for it.
Might need to do a hard reset there.
Maybe.
we've been refreshing the block so many times today that it's blocking your IP or something.
Right. Or maybe they're listening to the stream.
Maybe. We have a question here from Mario asking, do you think Artemis II will be smoother than the first test regarding S-words and other aspects? I'm not sure whether you're referring to today or whether you're referring to Artemis 1, but Philip, what do you think? Do you think the launch attempt will go smoother than today?
Well, I guess probably the best way to put it is I'm a lot less confident than I was maybe 4 hours ago or maybe 5 hours ago. And so, yeah, I think where we are right now, there's some explaining that needs to be done. Of course, that doesn't really change anything. The vehicle's going to behave the way the vehicle behaves. But yeah, at least to me, I am at least surprised that they're seeing this with it's a new set of hardware. They did all of these upgrades. It'll be really interesting. The situation's different again. We just seeing this at a different point in the loading procedure, but this to me this generates a lot more questions about what we're going to see and when we will see them make a launch attempt than beforehand. And so it does suggest that they still have learning to do here. And so I'll be curious if they think there's a way to that they're going to be able to reset for the 8th as if this was an uneventful. And to be fair, nobody's taken that off the table at this point. I wouldn't completely rule it out. It would certainly be interesting for them to have. I mean, and again, if anything, the thing to me that I find sort of more disconcerting is the fact that they had to stop flow multiple times. If it had just been once, if it had just been early in the procedure, and then they'd run their troubleshooting procedure, and then had no speed bumps after that, then I think I would feel differently about it. And so, in the absence of an explanation, it just generates more uncertainty about what we're going to see in the next week or so.
Indeed. So we are still waiting for that Closeout crew to emerge. So definitely seems like they're just waiting. They've kind of gone forward a little bit, but they're still waiting for the go-ahead to actually enter the pad itself with the vehicle fully loaded with liquid oxygen and liquid hydrogen at this time, as we are now L-2 hours and 42 minutes away from the opening of the simulated launch window for today's wet dress rehearsal. But everything, at least in terms of replenish, seems to be continuing as normal. NASA still reporting that the all stages are in replenish, so at least that is good news on that front. But apart from that, we still have not got any information on what exactly the Closeout crew is doing. We did see them drive past a few minutes ago, but they have not emerged at the pad yet, so they're somewhere between the press site and the pad, most likely waiting near the gantry. Which is kind of like a forward operating area they have before they head out to the pad. And let's have a look through here for some more questions. In the meantime, if you are just joining us and you have a question, feel free to tag us in chat at NASASpaceflight or at NSF, and that brings it into a nice queue we have to line up all the questions, and it makes it a lot easier for us to answer them on stream. Let's have a look through here. We have Barney Rubble, and they're asking, how are the solid rocket boosters filled with solid fuel prior to assembly and rollout? Philip, if you were able to take us through kind of how those boosters are cast before they're taken to the Kennedy Space Center.
Well, these are shuttle cases, but I guess it's similar to the new composite cases, but the cases are. The cases are prepared for casting the material in them, but they're lined with insulation, and I'm simplifying, but then in at the Northrop Grumman facility in the Promontory, Utah area, so this is like north of Salt Lake City, the cases, they go into casting pits, and so they're put in the pits inverted, and they actually pull a vacuum in the casting pits before they cast the propellant. You obviously don't want any air bubbles in the propellant because it will cause the instability in the burn rate. But that's how they do it. They do it. They're loaded vertically, inverted into the casting pits, and then they pull a vacuum on those. They will insert a mandrel that's like a forming, and so they cast the propellant around that mandrel, and then it's allowed to cure. The casting's done at an elevated temperature, and then those are taken out of the casting pits, and then they go through a series of other final assembly and production phases. So you've got 5 segments in the motor assembly. The center segments are simpler, so to speak. The forward segment has an igniter in the top, and the aft segment has the nozzle in the bottom, and those are sort of the extra assembly steps that occur for those 2 segments.
And then once all of that is sorted, that as far as I'm aware, they're essentially loaded onto a train and taken to NASA Kennedy, and then the final stacking actually happens inside the vehicle assembly building. So I can't,
right.
sometime in
But
2024 that started for this launch, right?
Right, but I mean, these segments were cast many years ago. So just again, big picture, Northrop Grumman finished the Artemis 3 segments in 2022, I believe. So they finished the Artemis 3 segments. They're probably going to finish the Artemis 4 segments this year. And then they just go in storage. And so they won't, NASA will let them know when they need them. And what they do now is they will put all 10 segments on the same train and send them all at once. They did it a little differently for shuttle, but now they will send the only piece of hardware that I think they send separately now are the nozzle extensions, which are also called exit cones. But then the rest of the shuttle or the rest of the SRB hardware is actually here at Kennedy Space Center. So the forward assemblies with the nose cones and the aft skirts are refurbished and assembled here at the booster fabrication facility, which is sort of between the industrial area and the VAB.
Regarding those segments, I actually have a question because for the core stage engine set on this flight, one of them, as we were talking about earlier a few hours ago, one of them had to be swapped out for an engine from the Artemis 3 set, which then one of the Artemis 4 engines went to Artemis 3, and then this Artemis 2 engine has been bumped up to Artemis 4. Can they do something similar with the solid rocket motors, the segments? So, for example, if there was one segment which, I don't know, got damaged for whatever reason, would they be able to swap in another segment, or are they set specific? Do they have to stay in a set? Do you know?
I think during shuttle, I believe that they could do that. They could swap. There may have been matches between individual segments within a set, but they do intentionally cast the motors using the same. When they cast them, they tend to want to cast them all from the same batches of propellant. But what they're trying to protect against is an unacceptable amount of thrust imbalance between the two. There's an allowable difference in the thrust between the two, but because the boosters they provide most of the thrust and therefore provide most of the steering authority for the vehicle while they're firing, you can't have too much of a thrust imbalance because that'll exceed the control authority of the vehicle in general to fly in the right direction. So, but I'm not sure whether it's on a segment by segment, the left hand A segments and the right hand B segments, or whether it's the entire sets.
So does that mean, is that because like if they cast them at different times, the density will be different, so the thrust is different?
I think there's probably enough variance that they do tend to want to match them. But that's a good question. I'm not sure how much of a variance they see from, when they're mixing propellant, because it takes I think several dozen. They're gigantic bowls, these mixing bowls, and that we saw them at a tour again last year. But you still need dozens of those to fill the entire, all of the segments in a particular motor. I'm not sure how many it requires for a single segment, but it's still quite a bit. So you wouldn't necessarily mix the entire batch for the entire all 10 segments and then load them. So there has to be some variance there, but I don't know if they're willing to quantify that for us either.
Mm-hmm. I just when you said mixing bowls, that just gave me a brilliant idea for the merch store, which is a an SRB propellant mixing bowl. I'll forward that one over to the store team and see if we can get that in the shop with a whisk as well. You can whip up your own SRB. Don't try this at home. Your own SRB propellant.
Yeah, definitely don't. Well, if you're going to use something else for propellant.
Yeah. Just on that left view there, we're getting a wonderful zoomed in view through the atmosphere of the base of the vehicle. And is that the engine chill, or going? Are those vents happening and kind of falling rather into the
Yes.
trench
Those
there?
that's just gaseous oxygen venting out of the drain lines for the RS-25 engines. So the chill down, that might be a part of the chill down loop on the oxygen side, but then the hydrogen side is more, has to be, you can't vent that into the air, because then you could any spark could cause a big old pop. So but yeah, that's the engine, the engine vents, the RS-25 engine vents there, and then you've got the boil off vent up at the top of the oxygen tank at the top of the core stage, and then we should at some point see the ICPS. I believe they have 2 vents, if I recall correctly, and so we will see a little more venting from the ICPS here eventually. And so I was looking to see, because they'll come up on the east side of the crawlerway. I'm not even sure if there's a roadway on the other side, and then they'll drive across the bridge, if I recall correctly, the bridge that the rotating service structure had back in shuttle days, to cross over to this. To the west facing side of the of the mobile launcher deck.
Yeah. Anyways, as you can see there, that camera at the bottom is zoomed in on the base of the pad, so we are keeping an eye out for the Closeout crew van to appear, hopefully at some point soon. We saw them leave the press site area a good while ago at this point, so we're just waiting for them to continue their way up to the pad. Anyways, we have a few questions in here. First of all, D, I'm going to throw this one over to you. We have Big Papa 05, and they're asking, why is the orange not turning to white like Falcon 9? And that's pretty much because Falcon 9 isn't insulated, but SLS, it is insulated.
Yeah, so SLS has that Sophie, that orange Sophie. It's kind of iconic. It's the big orange rocket. It's one of the things, like, you think of SLS, you have to think of that insulation, and because of that insulation, in part, we don't get the same frost forming on the outside of the rocket. Now, Falcon 9, with its metal walls, it doesn't really have any sort of insulation between its tanks and the environment. So the frost forms, and we get a layer of ice on the outside, which, I mean, it makes for cool shots, especially once that soot has built up, seeing all that ice falling away from the rocket. But here they are trying to be as efficient as possible with their propellants, and it's more complicated than this, but like having that insulation is part of allowing SLS to be able to support these windows despite already going into fueling. They can support a 2-hour window, and they aren't worried about the temperature shift like Falcon 9 is, but that also has to do with Falcon 9 using the cryogenic supercooled propellants. But yeah, it's all because of the insulation and allowing ice to form on the majority of the outside of the tank.
And we are also seeing those vents coming off. I'm seeing some people in chat, they're asking what those vents are. You'll see a couple of them near the kind of the orange conical structure. That's the top of the core stage. That's the adapter, rather, between the core stage and the ICPS, the upper stage. So just below, you'll see a bigger vent. That is just above the core stage oxygen tank. And then just above the cone, you'll see a smaller vent that's coming from the interim cryogenic propulsion stage, the upper stage of the rocket. So those are completely normal. Those are expected. And those are just kind of venting the kind of boil-off propellant that is no longer needed because it is boiled off because of the cryogenic temperatures. They can't last at those temperatures forever. So you need to make sure that you can get the gaseous elements out of the rocket whilst keeping the liquid elements within. And we were talking about the SRBs just a moment ago, Philip, and we have Mr. Fancy Zach, and they're asking, can the SRBs gimbal? And you were saying a moment ago they do provide most of the control authority, and they were actually the other day doing some preparations to make it so they can gimbal.
Yes, I'm not sure what you're referring to though, but yeah, the solid rocket boosters have they use the same it is shuttle hardware, and so the thrust vector control system for the boosters is a hydraulic system. It uses a hydrazine fueled. It uses hydrazine fuel to turn a turbine to generate the hydraulic pressure for the systems. That is the shuttle hardware, and so both the RS-25 engines and the solid rocket boosters have two thrust control vector actuators. So for the RS-25 engines, they're called pitch and yaw, I believe, the pitch and yaw actuators. And just to differentiate between the two, the SRB thrust vector control actuators are called rock and tilt. And so each booster has two redundant hydraulic systems to give you some single fault tolerance. And so that's how the vehicle does the roll program. For instance, the booster nozzles are basically pointed in the opposite direction to give you that roll program. But they're also doing it's actually, as in shuttle, a roll and pitch program. And if any of you caught the edited video that NASA put out, I think it was last week, they put out some edited video of the crew training, and we actually did hear Reed Weissman in a launch simulation. And instead of he went back to the old way that shuttle crews made that first call after liftoff, which was to call it roll pitch, which was only used for the crews, I think, for the very early shuttle launches, and then they just abbreviated that to roll program. But it'll be a combination of those two, and that's done with the solid rocket boosters after the vehicle clears the tower.
That hydrazine loading is what I was referring to the other day. We saw crews heading up to the pad to work on those SRBs, and they have to,
24th. Yes.
Yeah, they have that full kit to keep them protected from the hydrazine, which is, well, you don't want to inhale that in any way, shape, or form, do you?
Yes, it's very nasty. It should not be used as perfume or cologne. And so, they because of that, they have to clear the whole launch pad area, so they basically have to stop work on the rest of the vehicle in order to do that operation. And so they figure out when a good time to do that is. And so that, I think, was performed back on a Saturday. I think it was January 24th. And the core stage, or not the core stage, the shuttle orbiters used to use the same type of system with hydrazine fueled, where hydrazine fuel was used, was burned to turn turbines. And that was important for shuttle, for both the engines, gimbaling the engines during launch, but then also to drive the control surfaces for the orbiter. So the rudder speed brake, the elevons, and so they needed something that could be restarted at the end of the mission. Since the core stage only needs them for about 8 minutes or 10 minutes, they modified the core stage to delete the hydrazine part of that from the system, and so the RS-25 engines are gimbaled hydraulically, but they use a helium spin start system on the ground, and then that's bypassed as the engines come up to main stage by gaseous the gaseous out pressure from the engines as they're burning is used to spin those turbines. And so eventually the boosters, if they ever do get to that next generation Bolle boosters, they will transition to an electric thrust vector control system and to completely get hydrazine off of the vehicle. Of course, they don't get it off of Orion though.
Yeah. for those of you just joining us, the reason we are staring so acutely at the base of the pad is because we are awaiting the arrival of the Closeout crew. So a few minutes ago, I say a few minutes ago, probably almost an hour ago at this point, we saw the crew making their way out to the launch pad. They drove by the press site in their van, but they haven't emerged yet. So we believe they're currently standing by before the launch pad. So they've kind of gone to a forward staging area where they will then depart to the launch pad. We're not sure when that will be. There hasn't been any update from NASA for over half an hour at this point. So we will stand by for any more information. Or if we see that van make its way up the ramp there at Launch Complex 39B. That is what we are waiting for if you were just joining us. So fingers crossed we see that soon, because that would be another sign that things are progressing. Over the past few hours, we have seen a little bit of troubleshooting with the hydrogen on the core stage. NASA attempted to fuel it, go ahead with fast fill. A couple of times they had to pause because of leaks getting out of control or going beyond accepted limits on the tail service mast umbilicals. And then eventually, I'm not sure if it was on the third attempt or on the fourth attempt, they managed to get that core stage up to 100% hydrogen fuel loaded. And right now, as we stand, we have 100% in the hydrogen and oxygen tanks on the core stage and in both tanks on the upper stage as well. So we are in replenishment mode as it stands, and we are just awaiting that Closeout crew, which is going to be kind of the next visual indication we have of things progressing forwards. Let's have a look through here. If you have any questions, of course, tag us in chat at NASASpaceflight or at NSF. D, we have a question here from Do You Like Jazz? I have a feeling that might be a reference to the B movie. And they're asking, does Artemis II have an instantaneous launch window, or do they have the ability to hold to troubleshoot?
They absolutely have the ability to hold. So they actually have holds built into the count that we're anticipating. And if they need to extend holds and adjust that launch time, they absolutely can. So a lot of the launch windows that we are looking at in the coming 2 or 3 months are about 2 hours long. So they have the ability to target a time in that window, go through certain fueling ops, then they still have time to pause those ops, figure out any issues, resume ops, or adjust that T0 a bit as needed. So that's one of the benefits here. Unlike the Falcon 9, they do have the ability to actually troubleshoot in the event something goes wrong after fueling has started.
Just one of those differences that we are getting used to, or you might be getting used to, with the SLS rocket. It is, in the nicest way possible, it's a little bit of a more old-fashioned way of doing things compared to some of the other rockets which we cover quite closely over the past few years. But, you know, if it ain't broke, don't fix it, you know?
I have to say, I'm certainly glad that SLS has the ability to adjust that time rather than having to S-word at the first moment of an issue during propellant loading.
You know, yeah.
Well,
that is
be fair,
one of the annoying things.
Yeah, but to be fair, I think the way to argue the other side of it, I think the idea that you're especially seeing with Falcon is to make the system so reliable that you don't ever have to scrub. I mean, now again, they do scrub every once in a while, but the launch rate that they have at this point, I wonder what the percentage of launches on the first attempt are now. It's probably relatively high.
It's definitely a significant number, and I think we can gloss over that you said that S word tonight a couple times now.
Sorry, I don't. To me, I'm sorry, I'm
you're
not
good.
If I had that power, I wouldn't be doing this.
That's super fair, and yeah, I certainly wouldn't be opposed to more reliability in the SLS systems. We touched on that earlier. We're talking about just launching more often, leading to improved reliability. We saw it like with Delta IV Heavy. Once it had sat for a while and then they started to get back into things, then they started having repeated holds and repeated issues with ground systems that came up. But I hope SLS can get to the point where the actual ability to integrate and such is the limiting factor, and that they have to think about reliability. I like crossing my fingers we get lots of SLS launches. More rockets, more better.
Yeah, we might actually get a daylight launch too at some point.
That would be nice. I'm sure D would appreciate that.
Yeah,
absolutely. We need a daylight SLS launch. It's going to be sad if we're only getting these night launches. I want the imagery with the blue sky in the background.
I have to say that the Block 1B is, at least aesthetically, my favorite configuration of SLS. So more SLS launches, in my opinion. I at least want to see the Block 1B launch, because the Block 1, you know, it does the job, but it's kind of like it almost feels like, we don't have an upper stage. ULA, can we have some of your upper stages, please? That's what the Block 1 feels like to me. The Block 2, the Block 1B actually feels like a rocket which was kind of thought through a little bit more before they put it together, and I think it just looks a little bit nicer, but that's just my opinion. And it's kind of closer to the Saturn V in terms of height, so it's almost like a more of a like-for-like comparison compared to the Block 1, which is a little bit shorter. But anyways, we have some more support coming in from Liz Clark, who's become a Red Team member. Thank you very much for that, Liz. And we have Kerry, who has been, or is that saying Dr. Holly? Hello, Dr. Holly, saying Blame Hydrogen is perfect for this chemistry teacher. Yes, getting the Blame Hydrogen t-shirt and the SLS assembly t-shirt as well. Thank you very much for getting that, Dr. Holly. Great to see you in chat. Let's have a look through here for some more questions. Again, if you have some questions or comments, tag us in chat at NASASpaceflight or at NSF to bring it into our queue here, and that just helps to filter out the rest of the chat, makes it easier to bring those questions on stream. Let's have a look through here. We have a question from Lynn. Philip, I don't know if you're going to have to bring out the SLS reference guide again, but they're asking how thick is the insulation and how much does it weigh? Is that information we know?
I think I don't think we know how much it weighs, but I think even the thickness has become it's I don't know, semi-secret. I want to say because actually the other thing that one of the other little aspects of this is that they insulate not just the tanks, but then they also insulate the main propulsion system lines inside the engine section and inside the, for the liquid oxygen feed lines. Those are all insulated as well. But so you'd have to account for that a little bit with the weight for the weight for the vehicle. But I want to say, and it does. The thickness varies from the liquid hydrogen tank, which has a thicker foam because of the temperatures are lower, versus the oxygen tank. And I can't remember, but it's on the order. And again, I apologize because I'm using English units because that's kind of what the vehicle's still based on. But it's in the 1/2 of an inch, 3/4 of an inch ballpark, somewhere around there. But it does vary from tank. It varies from article to article, and the application is a little different from one element to another because either the difference between oxygen and hydrogen, or the geometries that you're dealing with for the inner tank, or the and then the engine section. That actually is the one element that doesn't have the foam on it. And then another one of those things that makes it complicated is that conical adapter, the launch vehicle stage adapter. That foam is there really for insulating against ascent aerodynamic heating, as opposed to trying to insulate that compartment where the lower tank and the engine are for the interim cryogenic propulsion stage. That's not necessarily insulating the cold inside there from the relative warm of the atmosphere. It's just for ascent heating. So you could use other types of insulation. And I still have this outstanding question, which I won't go too far into, but you see those little dark circles on that conical adapter. I'm still trying to find out if that is thermal protection system coating or if it's just a metallic door and they didn't need it, because they never did sort of close the loop on that. So I'm still trying to find out what they're using, because it's sort of like, so you have foam, the orange is foam, the white is white paint over cork, and that, so you have all sorts of different, and then believe it or not, the solid rocket boosters have some of that, have other types of thermal protection insulation on them as well.
I wanted to also point out super quick, we did have Scott Manley in chat saying about 6 centimeters, so going with that varying dimensions, and great seeing you, Scott.
Apparently he owns a piece, so it can't be that secret if he owns a piece.
Yeah, no, I think it's thicker than that, but yeah, it's been a while.
Scott has just tweeted at us, actually. We will bring that on screen as soon as we can. When we
he just sent another message in chat. Measuring again, it's more like 4 to 5 centimeters. So like 1.25 to 1.5 ish.
We will. I will make sure to
okay.
bookmark that, and we will bring it on screen as soon as we can. But at the moment, we are waiting for that crew, closeout crew van to arrive. So I will make sure we bring that up later when we have a moment, because that's a very interesting picture. Thank you very much for that, Scott.
Yeah, I would be interested in what that. I'm assuming it's like a coupon, but what that's from.
Mm-hmm. Okay, let's see. Actually, I'm going to hit a little bit of support very quickly. First of all, Moldy Space. Hello, Moldy, gifting a Red Team membership. Thank you very much for that. We have Didier Magia. Sorry if I pronounced that incorrectly, but thank you for your support. They're saying, I'm a Lockheed Martin employee. I work stress engineering on the Orion crew module propellant system and structure. Thank you for the coverage. I'm listening to your coverage whilst working in AR4 right now. Well, that is a very kind message, and thank you for tuning in, and thank you for your work on the Orion systems to actually make it exist, because without the people working hard on the rocket wouldn't exist. So thank you for your hard work, and thank you for supporting us, trying to share your work with the world, because it is a very, very, very exciting moment in time. I can't think of anything else happening on the planet right now which is more exciting than sending 4 humans to the moon. So, yeah.
You mean
very exciting stuff?
More exciting than the Super Bowl? Are you sure?
I have to say, I'm not quite sure how your world championship works when only teams from the United States can compete. But, just saying.
That's a good point. I don't, because they do call it World Championship for some reason. But but you know what? I think I'm confusing. I think Scott's probably right, because I'm confusing the thickness of the foam and the thickness of the structures themselves. So I don't think the numbers that I'm quoting might be for the structure and not for the insulation. But I'd still be interested in what this coupon sample or what the picture is of.
Well, Scott has just said in chat that it is the remains of a tank they blew up at Marshall, and they cut off pieces to give to visitors.
So that's the structural test article that they tested to failure in, what was it, December 2019. So maybe I guess I'm assuming that would be on the other side of the tank that did not unzip.
Yeah,
that's interesting. But yeah, I think the numbers I'm thinking of were just the metal substrate itself.
Mm-hmm.
But that's also an interesting chat message. So that person, it sounds like that person is working over in the O&C building in the industrial operations zone on the Artemis IV crew module.
Very interesting. So yeah, genuinely, thank you for watching. Get back to work, but thank you for watching. It's always wonderful to see people from the industry who actually worked on the stuff we're showing and come in chat and say, hey, I worked on that thing, because it's when the rocket you've been working on for so long finally launches, it must be such a great feeling of relief and joy when it works, because, you know, so many different components, so many different people, so many different nations, so much has had to happen and come together to get to this point where, for the first time in 53 years, we are getting ready to launch humans back to the moon. And we have an update from NASA that the Closeout crew is departing to the White Room. Quote, as part of the Artemis II Wet Dress Rehearsal, NASA's Artemis Closeout crew and pad rescue team are en route to pad 39B. The Closeout crew will head to the White Room inside the crew access arm on the mobile launcher and are responsible for securing the Orion spacecraft and ensuring all access points are properly configured before simulated crew ingress operations. The White Room is the environmentally controlled area at the end of the crew access arm, providing a clean and safe space for astronauts to enter Orion on launch day. During the wet dress rehearsal, the Closeout crew will close the spacecraft's hatches, verify hatch seals, check environmental conditions, and confirm all systems are ready for the next steps in the countdown. And they continue to go on, saying we can watch live views, which you can do right now. So hopefully that means we should see the van arrive momentarily. Fingers crossed we'll see the lights driving up the ramp to 39B. But if NASA says they're on the way, they're not too far away. They're only going to be a couple miles away, so it shouldn't take them too long to get there. And that's if they were parked by the gantry, which is about 2 miles down the road. So we will stand by to see if they show up at some point. I'm not saying anything, but maybe they just need to, maybe they'll be there in a minute. Either way, in the meantime, we have David, who has been getting the Blame Hydrogen shirt. Does SLS really stand for Space Leak System? Well, I can say it is leaked on more attempts than it has launched so far, because it's leaked a lot of times and it's only launched once. So, you know, I'm sure that could also be applied. We also have the Senate launch system. That's a fun one. You know, multiple different acronyms we have, or initialisms for SLS. We also have Martin Can becoming a Red Team member. Thank you for your support. And we have Rosebud53 with a $20 tip at tips.nasaspaceflight.com. They're saying, been here all day. I had no idea how complicated, fascinating, and informative this would be. Thank you for this one. Well, yeah, it might seem like a longer stream, because it is a longer stream, but there is so much to talk about with this rocket, because we don't really get to talk about this rocket that much because of its slower launch cadence. So when we have the opportunity to talk about this rocket, it's great to have that opportunity to talk about it. We can talk about it for a long, long time. Lots of things to talk about. We are now approaching the L-2 hour mark. That is 2 hours to the opening of the simulated launch window today. Of course, if you're just joining us, this wet dress rehearsal is testing everything apart from putting crew on the rocket, so there's no humans on board, and apart from actually launching the rocket. So we're doing everything apart from those two things. And right now we are awaiting the Closeout crew to arrive at the launch pad. And essentially the visual things we will see is them closing the hatch to the Orion spacecraft so that the crew access arm could then be retracted away from the rocket. And according to NASA, about 5 minutes ago, they were headed to the pad. But unless they're driving extremely slowly, I would have assumed they would be there by now, but we are standing by.
Yeah, well, you never know where those speed traps are.
Yeah, you got to be careful. Yeah, if they were going at 30 miles an hour, they should have been here already, so they must be going even slower than that. Or maybe the NASA PAO was a bit optimistic on sending out the update. Because, yeah.
I did not ask how fast they drive, but they probably don't go too fast.
30 miles an hour though, that's not ridiculous, right?
No. But I have not driven out there. I can't remember if there are any speed limit signs out there. So
I don't know if they hit a pothole.
I'm
Maybe
sure
a
we've
flat.
got our speed limit signs, but I don't think the speed limit is what would be bringing them down to this speed. I think they're just taking their time, potentially.
Yeah. But, 6
I
minutes.
wonder how much. Yeah, I wonder how much time it would take. Because on the one hand, if this was a launch day, then we would be talking about how close they were getting to the end of the window. But I mean, this is not the part of the procedure that is going to take the longest. So, to be fair,
maybe the van battery has run flat and they need to jump start it. Literally thinking of anything that could be delaying them at this point. If they were meant to be on the way 7 minutes ago.
Question. I wonder how fast the motorcade for the crew goes. Just ballpark, because I don't think they're going. I don't think they're going really fast. But in that case, it's several vehicles driving at the same time. So
yeah,
this is probably just one vehicle. Well, I take that back. It actually might be a couple vehicles.
Even so, 8 minutes is a suspiciously long time to drive 2 miles.
Yes.
In any case, we will continue to watch the base of 39B as we have been doing for quite some time at this point. But fingers crossed we see that van showing up in a second with the closeout crew indoors, or inside rather, headed up to the mobile launcher. And I actually have a question about that mobile launcher, because of course at 39A and at Slick 40 and at 41, the towers are fixed in place. Like the towers are on the ground, so there's an elevator that goes down to the ground. How do they actually get onto the mobile launcher platform? Do they have to take stairs up and then get into the elevator in the mobile launcher, or is there like a connection or so? How do they actually get on board? Because it's that's quite a jump.
I'm pretty sure they have stairs up to the platform at the base of SLS, then they make their way to the elevator to go up the tower. Philip may know for sure, but I'm pretty sure it is just stairs up to the base there.
Well, I think they would have to have stairs for emergency purposes, but I believe there's an elevator in that, and I don't know what that structure is. But again, it's the structure that you can see the lightning tower in silhouette on the left. You can see that sort of that gray structure that towers over the base of the mobile launcher. That's where the elevator is for that. That's a fixed structure at pad 39B. So they'll take, and there's a fair amount of equipment. I think there's some pictures that NASA released of some of the lockers that they're taking equipment up to the white room in. And so they'll take that in the elevator for sure. I'm not sure if they could haul that up the stairs. But they'll take an elevator up at least closer to the zero deck of the mobile launcher, and then walk across the zero deck to the mobile launcher's elevators. So we probably won't be able to see that until launch day. I guess it's possible, given if the lighting is right, we might be able to see some movement. But first, we would need to see the van. We're still waiting for the van.
10 minutes now since they supposedly departed for the pad, and still no sign of the van. I'm starting to think they got lost and they're at 39A somewhere.
Or they've decided to go around the back way to try and hide from the cameras.
2 miles is the new 2 weeks.
Yeah. Oh dear. Still no sign of the van.
Is it hydrogen again?
Hydrogen has struck the van. Check engine light came on. Well, I think Drunar has it. Drunar with a $2 Canadian super chat saying $93 billion space program derailed by flat tire. they're just stranded on the side of the road somewhere between the pad and the gantry. Who knows?
It's sort of like a watched pot. So maybe take some more questions while we're waiting.
Yeah. Well, first of all, Aid Astra says the van had a hydrogen leak. And we have K Webb with a $50 tip at tips.nasaspaceflight.com. And they simply say, thanks, NSF. I've been watching all day. Great stuff. Well, thank you for your support, because, again, I know I've said it before and I'll say it a million times again. Like, we genuinely could not do what we do without all of your support. It takes a considerable amount of effort, capital, and just equipment to be able to bring you all of these different views from our own cameras, from NASA's cameras, from the Kennedy Space Center, where connections are going to be extremely limited on launch day, and we have been building out basically a brand new set of servers to actually put all of these camera feeds together and send them to your eyeballs on your screens at home. There's the van. The van is on our screen. The van is en route to the pad. We have visual of the van. Yippee! It only took them 12 minutes to travel 2 miles. And they're at the top of the ramp now. Yeah, I mean, that is very slow. And then I crossing the bridge.
Yeah, I mean, I would assume they go slow here to cross the bridge, but like to get up to the pad surface there. But yeah, they're maybe at that pace. Yeah, that's definitely the van.
That is confirmation. We can see the Artemis logo painted on the side of the van there. And we can no longer see the van. So that was fun while it lasted. The van is now hidden, barely hidden behind the elevator there. And it looks like it's parked up by the elevator. I suppose that makes sense. It's parked up by the elevator, right?
Yeah, I think so. I mean, it's possible that I can still see some flashing lights, so it might be underneath that bank of stadium lights. Yeah, there you can just to the right of the
Yeah, you just barely make it out through there. Jerry in the back channel saying that if they were traveling 2 miles in 12 minutes, that's 10 miles an hour.
Yeah, that seems that's like a motorcade. Maybe they were shaking hands, working the crowds. I don't know.
Yeah, or maybe they went the wrong way round. Who knows?
Maybe there was a booster in front of them.
Yeah. Perhaps they had to wait for the police at the entrance to Massey's Road to let them in, because we are hearing that the super heavy booster at Starbase has started to get frosty, which is a great sign for the Human Landing System program, because, well, this is actually the first time that a version 3 Starship super heavy booster has been loaded with cryogenics, considering the last one kind of blew up when it was filled with room temperature air. It wasn't a great start to the program, but they've been making progress ever since, and it's great to see a Super Heavy Booster version 3 actually receive some cryogenic fluids inside. So that's a wonderful progress on 2 fronts of the Artemis program today. We've got an SLS rocket fully frosty, and we're starting to see a Starship Super Heavy Booster get frosty as well. Anyways, we've got some great news with the Closeout crew arriving at the pad. And at this point, Philip and Dee, I'm going to relieve you of your duties because you've been talking for God knows how many hours at this point. But thank you so much for being on the stream. And we'll probably be... oh, no, I believe you're done for the day.
Yes. I'll be around. If you guys need me again, I'm not planning on going until we hear that they're done. So... or they kick me out of the new center, which is possibly either way. So, but yeah, I'll probably go out and take a look around and, maybe get something to eat. But I'll be around here. If you guys need me, I'll come back and check in later.
Well, thank you so much for all your expertise as usual, Philip.
And I'll be running off to the cameras, which I've been running to occasionally while on comms. But it's been a pleasure, and we'll hand it off.
And joining me once again, bit of deja vu for you, in the field, Max Evans. How you doing, Max? Is it any colder now? It's gotten dark since I last talked to you.
It certainly has, but I am indoors, so thankfully I am protected from the very cold breeze that is currently outside. But it has been a bit of a roller coaster out here this evening. Oh, hello. I'm on the wrong microphone. Hang on.
We'll just pretend like that never happened. Let me know when you've picked the right microphone, Max. Stand by for a second.
How about this, Ryan? Do I sound any better?
You do sound a little bit better there. Okay, right. Rewind. Hi, Max. Bit of deja vu. I haven't spoken to you since it was daytime.
You nailed that quote. That was quite impressive. Yeah, it's a bit cold outside, still a bit chilly, but thankfully I am indoors, so not in the cold breeze, but still have a view out the window towards 39B. So it's been a bit of a roller coaster since we last talked, Ryan. But the vehicle is full and now in replenish. Things seem to be trending in the right direction so far, although we are kind of on the edge now in terms of time. But I guess more on that later.
And, of course, we have the Nologist joining us once again. Alex is with us. How you doing, Alex?
Excuse me, going from Philip's Laus to me, it's a downgrade, okay? I would argue that. So, yeah, I don't know if you're on the right track there, calling me that.
The Falconologist. Okay, how about that?
All right.
Anywho, over the last few minutes, we have been getting a bit more support, which I'm going to very quickly run through, because, of course, we couldn't do this without the support. The Telstar86, hello, Telstar86, we always see you in chat with a £2 super chat saying, the van is another SLS, slow locomotion system. You're not wrong. We have Melody CJ saying, when is the actual launch day? Well, if everything goes well today, the earliest window is February 8th, but we will stand by for NASA to confirm that date. NASA isn't actually telling us a launch date. They're not locking anything in until they have done the test, got the data, and they're confident they can meet a launch date. So that's why an actual launch date hasn't been physically, set in stone yet. They are waiting to go through all of the testing before doing that, and rightly so. Thomas says maybe they forgot the key to the gate to the pad. ODST Moody saying, let's bring it into the ticker here. Hey, yeah, we just left headed that way. Guys, I just told them we left, so we have to get in the van, right now. We have Brianna Jones with a $5 super saying, thank you so much for your amazing coverage today. It's helped you to get through the midday as you grade midterms. Hopefully we get some rest. Well, thank you so much for tuning in. Thank you for your support. And it's good to know that we can serve as a little bit of background noise for you as we watch SLS get ready for Artemis II. And finally, we have Mr. PC Scrapper with support there. So thank you very much for your support with that one there as well. We have a question here from Brian Cavett asking, at what point does control go from the Kennedy Space Center to Houston? Will that happen today or only on an actual launch? Alex, I'm not sure about the exact time. Is it at 0 exactly, or does Kennedy also cover a little bit of the launch? Do you know?
I believe it's a tower clear. It tends to be the moment of transition between Kennedy and Houston. So yeah, it's not going to be today. That's for sure. We never hope this to be that kind of situation, right? Like, it's a wet dress rehearsal. Like, even if it were T0, to be fair, we're not reaching T0 on this countdown test either, because this is going all the way to like 30 seconds, which is when the ground computers hand over control of the count to the onboard computers on SLS. So like, even if that were the case, we're not going at all to that point in the count. So, yeah.
So actually, during the shuttle era, back when the vehicle cleared the tower and began roll program, that call out was when Houston would take over the flight at that point in terms of comms. I believe there was a video recently released. I can't remember who posted it, but there was some video of both Victor and Reed on a simulated launch inside of Integrity in Orion, and there's a SLS will do a similar or will perform a similar maneuver just a bit higher up, but it's not roll program, it's roll pitch as per the audio there, and so I believe if that is anything to go off of, probably we assume at that point, hey, it's the moon. Probably at that point when Reed calls out Houston Integrity, good roll pitch, probably at that point they will hand over control and comms over to Houston. So that's just my prediction. I don't think we have any sort of official answer there, but that is, I guess, something to go off of. But that moon is dancing around a lot in the frame, and it is also very orange. Look at that. It's orange.
It's on the horizon, so it's orange because atmosphere or something.
Atmospheric distortion or something or other.
Yeah, the video that you talk about, it's part of a recent set of like pictures and videos and things like that NASA has released of the Artemis II crew, like training and things like that. Most of these are surprisingly old. Like some of them are even from like 2024, which I'm really surprised they're now releasing them. But it's super interesting because you look at it and like they've tested taking pictures of the moon, for example, once they go around on the other side and things like that. They've done a lot of really cool, interesting training that, I don't know, like I was the other day actually watching some of these videos, just pure curiosity. And I was like, yeah, that sounds, I don't know, exciting that we are in this era now that where, there are astronauts literally training for this kind of thing. It's crazy to think about that.
Yeah. I mean, even the fact that I'm saying on this stream we are preparing the rocket, which as soon as 7 days from now can launch humans to the moon, that's still, pinch me moment. Like we have talked about this mission for so long, and it's kind of relieving to actually finally be at a point where the rocket is on the pad, the systems are getting ready, and as soon as tomorrow afternoon, the crew could be at Kennedy. I mean, that doesn't feel real. Let's have a look through here for some more questions. JMACE Fire is saying, how else are they supposed to get to the moon if they don't launch at night? It's a great point.
It's kind of like going to the sun. Like you have to go out and see it when it's nighttime, right?
Yeah, Parker Solar Pro did that.
Very bad jokes here. It's something we are very good at. I wonder if we'll be able to see the closeout crew coming out of that the elevator on the left there when walking across the ML towards the big elevator and towards the rocket. I mean, they're wearing all white, so they might stick out a bit.
Yeah, and one of the benefits of this mobile launcher is that it's not clad in anything, so we can actually kind of see in from the outside. So, maybe it's a bit windy when you're up there, but, some benefits, some drawbacks. Anyways, let's have a look through more questions. We have Jayhawk asking, when does the crew's food get loaded onto Orion? I don't know. Does anyone know? If not, I can see if we can try and figure out an answer.
I'm kind of stumped on that one. That sounds like another Philip question. Maybe we could ping him, but I don't know, to be honest with you, because they're all prepackaged from the Johnson Space Center, and I wonder if because they're prepackaged, and I can't imagine that there's going to be anything or much in the way of being fresh, because that obviously spoils very quickly, and the last thing you want to do is have any sort of spoiled or moldy food aboard a spacecraft, because that then becomes a hazard with those moldy spores floating in the air around there. It has to be very, very close to launch, maybe within 1 or 2 days, because obviously the primary focus when it comes to launch day is, of course, getting the vehicle ready to receive the crew, and of course then to load the crew. So my guess is probably L-1 or L-2. I'm not entirely sure though. I am kind of stumped.
I wonder if there's like some kind of like freeze-dried stuff that is like long-term and can just be stored in there forever. But again, you kind of want that to be climate controlled, so I'm not sure. Anyways, we have another question from Lauren, who is asking, what are some of the tests they will do on Artemis II? And Alex, there are a few things that they're going to be doing on Artemis II. If you would like to just take us through some of the different events that are going to be happening after launch, potentially as soon as Sunday.
Yeah, so one of the important things, of course, is that, intrinsically this is carrying crew, right? And that is a very important part of the testing. Believe it or not, carrying crew actually makes you use the ECLS system, the environmental control and life support system on Orion, on the on the European service module, essentially. So that in itself is already a test. Now, more specifically, there are other kinds of tests. Primarily, for example, ahead of Artemis 3. Artemis 3 will be docking to unknown lander right now. We'll see if it's end up being Starship or not. But it'll be docking to a lander, right? So Orion, they need to be able to essentially test the ability of the crew to take over manual control of Orion and being able to dock by themselves, right? There are automated systems that can do that on their own, but if for whatever reason something happened that those automated systems were to fail, then the crew must need to be able to train those. So for Artemis II, there are actually, I think, 2 targets on the ICPS on the second stage of SLS for this flight. So after separation from ICPS, the Orion spacecraft will turn around. They're going to be trying out some movements, essentially, if you will, manual controls of Orion while practicing with that target on ICPS, trying to keep close distance and things like that, which sounds easy in KSP, in Canaveral Space Program, but it is not in real life, if you can imagine, right? They don't call it rocket science for a reason. So that's one of the main things, of course, in terms of handling. There'll be other tests as well out there in deep space. While the crew is out sort of behind the moon, they also have a few science tasks, mainly photographing certain locations on the moon, on the far side of the moon. The conditions of the light conditions, depending on when they launch, to be fair, it may lead to certain light conditions on the far side of the moon that are different from what we had back in the Apollo days because of the timing of when the launch is happening versus when this is happening. Back in the Apollo era, the launches needed to happen such that it was daylight in the near side of the moon, not the far side of the moon. If it was daylight on the far side of the moon, well, it was nighttime in the near side, and that will have meant the landing sites on the moon will have been in darkness. So this is going to be one of the changes as well, that they're going to be photographing sort of differences, and also like just using humans' actual eyes to look at these different aspects of the far side of the moon instead of just reconnaissance images and things like that. So those are some of the few things that are going to be testing. Again, one of the important things here is that there's crew on board. Otherwise, it's just a repeat of Artemis 1 by all means, right? With a crew on board, they can test a bunch of more things, and of course, all other procedures that are going to be used in the future with more and more Artemis missions as we continue, all of these missions going forward. But that's essentially some of the highlights, if you will, some of the major things that are happening here and that are going to be tested.
Certainly a mission to keep watching, which is what we will be doing, and we will be bringing you all of the Artemis 2 that is possible to bring you. So make sure to subscribe and like and do all the things. Follow us on all the socials. You know the drill. We've got so much coverage coming your way for this mission that you will not want to miss. I can assure you of that. So make sure you subscribe so you can see it live, because believe it or not, we are expecting at least some live feeds from around the moon. So stay tuned for that. Very quickly, we've got a bit more support in the queue. We have a high risk, high reward, saying there is a dent near Booster 19's chine on the left. I believe usually those things just kind of contract and expand, right, when they get filled with cryogenics. I'm not seeing any sizable issues.
Frankly, I wouldn't care about the chines on Booster 19 right now.
Yeah. Yeah.
Let's be honest. For once, like I'm a huge supporter of Starship and everything. For those that don't know me, I'm sure you know me. And I follow Falcon 9 and all that. Trust me, that's not the thing that I have in my mind right now, especially a chine, which can be replaced. That's one of those things that I really cannot care more, to be honest, at this point. They have plenty of time to change the chines once they go back to the Mega Bay. It's okay.
Moldy Space with a $5 super is saying, let's hope I'm not on this launch. Very funny. Also, hi, Alex.
Yeah, hi.
Doe John SO, sorry if I said that incorrectly, with a $10, saying, what are the chances of seeing Orion even as a speck of light from Earth as it goes around the moon? Max, I think maybe when it's at the lunar environment, that might be a bit difficult, but NASA is encouraging amateur astronomers to look out for Orion. I mean, they've even selected a specific group of people to, actually track Orion as it's in space.
Yeah, I think it's really difficult to put in perspective just how big the moon really is, and it seems close when you're looking up when you're looking up at it in the sky, or if you have it in, say, in a telescope or a big long telephoto lens. That is still that bit of terrestrial, I guess, mass is 250,000 miles away from Earth, and it's the scale is really difficult to comprehend, especially not only distance-wise from the Earth, but just how big it is in general. It's not like you can just look up and see a satellite orbiting the moon, for example. Like it's not that simple, and that's why we also have to employ these massive telescopes across the globe to get a better idea and get a better visual on past artifacts that we have left behind on the lunar surface from Apollo 11 through Apollo 17. Obviously not in work with Apollo 13, but also with our lunar orbiter as well. That is always taking images of the lunar surface. And by the grand scheme of things, Orion is tiny compared to the rest of the moon, and especially other satellites as well. So it may be a bit difficult to see, but if you have a powerful enough telescope and you time it just right with the sun's placement and the light, you may be able to get a few pixels of integrity as it swings around the moon. Andrew McCarthy, I'm talking to you right now. I want you to get this. This is a prime opportunity here. But it's regardless, it is going to be a tiny speck in the sky and only going to be getting smaller as it heads toward the moon and away from Earth. So it's not impossible, but honestly, I have no idea how it's going to look.
Yeah, it's going to be, regardless, no matter the size of telescope you use, it's going to be a small speck that you're going to have to look out very closely for. Something else you should be looking out for is, I don't know, maybe some cool new designs to wear, which are now available at shop.nasaspaceflight.com, such as our brand new vintage design, which you can get on a hoodie, you can get it on t-shirts, you can get it in stickers as well. You can get that at shop.nasaspaceflight.com. We've got the Artemis, and we've got the flight trajectory, which also kind of makes an A shape, which also kind of makes a 2 shape. And you can also see the SLS rocket there as well. So it's a pretty cool design if you want to celebrate Artemis's return of humanity to the moon. That is alongside our SLS construction design, kind of like a certain Swedish furniture shop, which I won't mention because they haven't sponsored us. You can see this really cool design with a lot of little Easter eggs on there, from suiting up to the VAB. You can see all of the different components of SLS that are constructed together to make a rocket. And we have our limited edition Blame Hydrogen merch as well, available if you want to blame the hydrogen for the delays earlier today, which is also available on the store, as well as our other SLSs, other SLS designs. There we go. SLS and plurals doesn't go together very well, but we've got multiple SLS designs available on the store for your wearing pleasure. And that Blame Hydrogen is also going to be on there for a limited time. So we've got some cool things on there for you to get if you so wish. Add that to your cart and do the checkout, do all the things. And if you are in the checkout right now and you want to send us a message, you can do so. Whenever we are live, there is a little box that shows up in the store, which allows you to put a message. So if you want to do that, you can do so. And it brings it into the queue and we can read them out on stream, and wonderful. You get a message on stream. Let's see here. That Kevin is asking, are they going to be laser communicating with this mission? Alex, as someone who knows a lot about SpaceX things and a certain Dragon spacecraft has flown with a laser before, is Orion going to be flying with a laser?
Believe it or not, there is an actual laser system that is going to be tested on this mission, and they're going to be trying using it as much as they can. Unfortunately, the problem is that the way that Orion's solar panels need to be positioned, facing the sun and whatnot, versus where the laser needs to point, because it's in a fixed position, right? So you actually need to move Orion and everything to be able to point to Earth. It's a bit complicated, but there is indeed a sort of test demonstration, if you will, of laser communications on Orion.
Very interesting. We'll have to stand by for the results of that. Hopefully not too long from now. Let's have a look through here for some more questions. Again, if you have any questions or comments, you don't have to do a super chat. You don't have to buy anything from the store. All you have to do is put at NASASpaceflight or at NSF in the YouTube chat, send your message, and it comes into the queue. And if it's a good question, we'll bring it on screen and we'll answer it, or we'll try to answer it, I should say. No guarantees at good or effective answers. NSF, not responsible. A few questions we've been getting recently is related to the flight profile of Artemis II. We have Joe, who is asking, why isn't Artemis II going into moon orbit? Artemis III certainly has to. If that'll go on the screen, there we go. And we also have Luke, who is asking, why will Artemis II not go into lunar orbit like Apollo 8? Surely NASA wants to ensure they can do orbital insertion and Earth return burns. Now, these are all great questions. I'm going to throw this into the ether and let anyone who wants to tackle this, because there's a few things you can talk about.
I think...
Very quickly, though, I will interrupt you because we have just gotten a new update from NASA on the blog, which is great to see, saying that crew, module, hatch preparations, and closure. That's the title. Let me read it out to you. NASA teams are performing final preparations and closure of the Orion crew module hatch inside the White Room at 39B. This step simulates launch day procedures, ensuring the spacecraft is sealed and ready for crew to enter Orion for launch. The closeout crew will inspect and clean the hatch seals to maintain airtight integrity, because that's the name of the capsule, verify environmental controls inside the crew module, confirm all mechanical and electrical connections are secure before closure. Closing the hatch is a critical milestone that demonstrates Orion's readiness for flight and validates procedures for the first crewed Artemis mission around the moon. Coming up next, teams will configure the launch abort system hatch for closure. So by that wording, it sounds like Orion's hatch is already closed, or they're in the process of closing it. And next up, they will be closing the launch abort system hatch because, of course, the abort system has a fairing that covers Orion. So there's two hatches they need to close for that. So exciting progress. Anyways, Max, I rudely interrupted you with this update, so please continue.
No, you're good. I can't really speak to a lot of this in detail because it is just not my knowledge base, but part of it has to do with the fact that this is a guaranteed trajectory to get Orion home, whether they have issues or not. So being on a free return trajectory, they don't need any additional burns once they enter through the TLI or translunar injection, and then Orion will use the moon's gravity to swing back around the far side and bring itself back towards Earth. But also, I believe the AJ-10 on the Orion service module does not have the delta V to enter and then exit lunar orbit with how it is currently configured. I know Alex can go into a lot more detail here than I can, but I think those are some of the two biggest reasons.
Yeah, I mean, there's definitely a long answer here, which is it all comes down to what are the actual sort of objectives of this mission, right? When we talk about Artemis II's trajectory, a lot of the times we always talk about comparing it to Apollo 8, right? But a lot of people forget that this is the first crewed flight of Orion. And yes, the trajectory is going to be closer actually to Apollo 13 minus the, explosion and whatnot on the service module. We don't want that at all. But the trajectory is going to be sort of like a loop. The thing is, the objectives are actually closer to what you saw, for example, on Apollo 7 plus Apollo 8. It's sort of like a mix of those two missions in one single mission. If you remember, Apollo 7 went into low Earth orbit. So they were able to test a lot of the Apollo systems when it was in low Earth orbit. It was essentially 90 minutes home, right? What happens on this mission? Well, in order to ensure that they still have an opportunity to be able to return quickly after, for whatever reason, something happens to Orion on the service module, the environmental control systems, right? If something were to happen, they will be able to come back quickly. And how do they do that? By launching Orion not directly to the moon. So SLS will not be launching Orion on Artemis II to the moon. And some people that might not know in detail why this is the case, well, that is the case. It is launching actually Orion into a high Earth orbit of approximately 24-hour period. So in about 24 hours, the capsule will be going back again to Earth if something were to happen. If nothing happens, instead, what do? Well, they fire the engine on the service module to do translunar injection. So the translunar injection will actually be done with Orion, with the service module, instead of the ICPS. The ICPS will give it enough performance, enough energy, enough oomph, so that then the service module can do the whole other way, can go the rest of the way with just its own propellant. In theory, Orion could go into lunar orbit and out of lunar orbit, but only like a high lunar orbit, right? Like I'm just barely around the moon, and something like that happened actually on Artemis 1, where they went into this sort of it was DRO. I don't remember exactly the retrograde orbit,
distant retrograde orbit.
Distant retrograde orbit. Thank you. So like
the one time I'm useful all of today.
So yeah, I couldn't remember exactly what the letters meant, but I knew it was DRO. And so you go into this sort of weird shaped orbit in between Earth and the moon and things like that. Orion can do that. NRHO, near rectilinear halo orbit, it's also technically an orbit around the moon as well. It just cannot go to low lunar orbit like Apollo did, because the service module is not big enough. The capsule itself is huge compared to the one from Apollo. Again, it can fit 4 people. It even has a toilet on board. Apollo didn't have that benefit, unfortunately. So it's a much bigger capsule. It can hold more people. It has more systems than Apollo. That means more mass, and you need a bigger service module to be able to hold that all the way down to low lunar orbit, close to the surface, and out of it. Unfortunately, it doesn't have that capability. But yeah, the reason they are not going into lunar orbit is precisely because the service module will be doing part of the effort to go around the moon, doing that translunar injection about a day after liftoff. So yeah, that's the whole reason why. And again, it's a mix of Apollo 7 and Apollo 8 in terms of, what are the objectives of the mission.
And we have some excellent questions queued up, so thank you for those. I'm going to make my way through the list. First up, we have, an interesting question for discussion from Joshua Gold asking, why does NASA have so little public attention to Artemis? And if you want to blame it on something else, why set the window opening to Super Bowl day?
Oh boy.
Max, as resident American, I'm going to default this one to you. Have fun.
Well, there are a lot of different angles that one could take with this question. I think from my side here, I mean, obviously here at NSF, we cover everything spaceflight. So spaceflight is literally in my foreground and my background, and in basically everything I do. So it's difficult for me to put my shoes in, or to put myself in the shoes of someone else who's not in the spaceflight sector and who may or may not have any awareness of the Artemis program and of course Artemis II coming up. There's a lot of other stuff happening both in the U.S. and in the world right now, and I don't think for a bunch of people that this just hasn't come across their radar because they're worried about so many other things. But this really feels like a parallel, if I may, to Apollo 8 in the fact that there is a lot happening in our country right now. There are a lot of people that are unhappy. I think I'll leave that vaguely. And we're just looking to find something to bring us all together and unite us all towards one common, towards one cause and one goal, and that could be the Artemis program, not just with SLS, but with SpaceX and Blue Origin as well, from Artemis 3 and beyond. I mean, I've seen it all over social media in the past like 3 or 4 days as well. People are beginning to talk about it, but also it has a lot to do with the fact that the average attention span of people these days is incredibly short. So if it's not immediate, it's a lot more difficult to capture the attention of some people because it's just too far out and people are too occupied elsewhere. They maybe just don't care that much, honestly. But what's happening now is an incredibly special event to cover, and it is remarkably it's so important. It is the mission. This is me talking just based off of my own opinions. This is the mission so far of the 21st century. It is by far the most important and the most impactful. I mean, until we get to Artemis 3. But to this point, this is the first time that humans are visiting the moon or being near the moon in over 50 years. And that is something incredibly important and literally has been decades in the making. It's been a very rough and rocky road to get here, but we are right on the footsteps now. Like, we are almost freaking there. And so the best thing that we can do is just keep up with the coverage, keep sending out all of our images, our videos, our live streams out into the void, hoping to catch the attention of someone who hadn't even heard of the program before, and then it just snowballs from there. That's the best approach that we could possibly have right now. So. I don't know if any of that really made sense. I know that was just a lot of rambling, but this is something that we all feel very, very passionate about here, especially being a resident here in the U.S. I'm very proud to live here and be in this position now. So I hope that it catches the eyes and ears of more people as we get closer, as we may be as little as 7 days away from the first launch attempt of Artemis II. So, but going towards the latter half of your question, towards why set the window opening to Super Bowl Sunday, I don't think that coincidence was on the minds of really anybody in the Artemis program, because of course people going to the moon takes a far greater precedent than just a football game. I'm sorry to say it like that. I really am, but I don't watch football. I don't find it that entertaining, maybe. But I find this far more important. But and I think everybody else in the LCC and also in Johnson, anywhere else in the world who is directly supporting the Artemis II mission, their priorities are going to be with Integrity's crew of 4 come game time, both here at the Kennedy Space Center and of course at the Johnson Space Center as well. So just hoping for a lot of good things.
Yeah, I agree with that part on the Super Bowl, because Yeah, as someone not from the United States, there's very little interest. Anyways, before I offend an entire nation, let's move swiftly on. We have Lynn Brown asking, what if Blue Origin and SpaceX's human landing systems are not ready to land humans? What would happen? We were talking about this a little bit earlier, but I think we can talk about it again. Alex, I think the most realistic scenario is Artemis 3 is just going to get delayed. What do you think? Because there was some talk in chat as well about potentially doing like an Apollo 10 with Artemis, but for that you kind of also need a lander. So what do you think?
Well, that's the thing, right? We've seen over the years that as the HLS schedules have been slipping to the right, so has the Artemis 3 launch, right? And that's essentially what I would expect. Like, if neither company is ready, then it just keeps sleeping until they are ready, right? Until somebody is ready, there's not going to be a lunar landing. That's for sure. So one of the problems of Artemis, or rather SLS, I should say, and Orion even, if I may say so, is, we were talking about this earlier, in fact, that they don't produce a lot of these, right? It's not like they have a dozen of them in a shed or something like that, just waiting to go. There are some parts of future Artemis missions of SLS and Orion that are technically complete, like the ICPS for Artemis 3, the boosters and things like that. But the core stage, it was just last month when they joined the tanks. For example, those two big tanks that you see there on the orange rocket there, those were joined just last month for Artemis 3, which means even if the lander, for some miracle, had been ready in 2024, which was the original goal, we will still be first waiting for Artemis 2 to launch, and then also for the Artemis 3 SLS to be fully completed. Like, that's one of the things that a lot of people don't understand, that yes, the HLS, the Human Landing System, is one of the drivers for these delays, but it is not the only thing that is not ready to go right now for 3. And it's one of those things that may be interesting and something to look for, not for Artemis 3, but for the following missions, because Artemis 4 is later, then 5, etc., etc. Once you have an HLS, once you have a human landing system, especially when you have two different companies preparing for that for Artemis 3, right? Think about this. Now you have pretty much two landers ready to go again. Or at least you have another one ready to go for another mission. Where do you have your SLS for Artemis 4? That's going to be Block 1B. So yeah, that's one of those things that are not out there, if you will. And I think it's worth thinking about.
Indeed.
Well,
are you going to talk about the thing that just got tweeted? I wasn't sure if we were going to talk about it or not.
yeah, I mean, if it's pertinent, if we want to talk about it.
Well, I suppose we've mentioned it now, so we should probably talk about it.
The elephant in the room.
The elephant in the room that has just suddenly appeared. SpaceX has just released a statement. Going slightly off topic for a moment, but this seems like big enough news to mention it. SpaceX has just released a statement on X. Alex, I will let you tackle it from here.
Yeah, so apparently during today's Falcon 9 launch of Starlink satellites, the second stage experienced an off-nominal condition during preparation for the orbit burn. The vehicle then performed as designed to successfully passivate the stage. The first two MVAC burns were nominal and safely deployed all 25 Starlink satellites to their intended orbit. Teams are reviewing data to determine root cause and corrective actions before returning to flight. So while the primary mission was successful, it seems like the orbit burn of the Falcon 9 second stage went not as planned, essentially. And that means we may see a little pause of Falcon 9 missions for a little bit while they figure that out. Last time it was about a week when they had also an issue during second stage of the orbit. So we'll see what happens.
Exactly, but it is curious that they've had this issue again with Falcon 9. Because that wasn't that long ago when they had that issue with deorbit. So I'm sure we'll be talking about it on the next episode of This Week in Spaceflight coming out on Friday.
Shameless plug.
Subscribe for that. Okay. Let's see if we have any more questions. We have Michaels, who's asking, Michael S, who's asking, will there be cameras by the hatch for the closeout crew on launch day, similar to SpaceX and shuttle launches? Thank you from the UK. Max, I believe we should have closer up engineering cameras on launch day. It's just for the wet dress, we're not really getting a lot, right? Like, we asked for cameras, but NASA isn't really providing them for today, unfortunately, right?
I mean, we always ask, right?
We always ask. Who doesn't?
Of course. If you don't ask, you don't receive. But we have seen footage released from the crew's rehearsal, countdown demonstration rehearsal back in December, from the White Room up in the crew access arm where the crew was about to board Integrity. So there obviously is a camera up there. Footage has been released from it. I can't pull it up right now because I'm not exactly sure where it is. It's probably on NASA's site somewhere, but I'll have to go dig it out. But that is presumably one of the feeds that they will be releasing for live coverage, because that is a feed and in a view that we have had many times before, back with Shuttle, and we've also seen it before. I believe we saw it with Apollo as well, although albeit I think in the later missions, because the tech didn't evolve to that point yet. But there should be a lot more feeds that we are not seeing tonight that should be available during launch. I know we have a very extensive list of fiber feeds from NASA for us to pipe into our live stream to spice things up. But we are short on a lot of angles, or a lot of those angles for tonight. So the primary focus is getting the vehicle tanked and fully tested, and not, of course, cameras, at least for us. There are numerous engineering cameras around the pad, both on the base of the mobile launcher and surely on the tower as well, looking at all of the umbilicals and all of the connection points, where there could be any sort of leakage, which we of course have already seen from the hydrogen TSM or tail service mount umbilical. So yes, we will get a lot more cameras closer to launch, but tonight is mostly focusing on the vehicle itself.
And let's see what else is in the queue. We have Joe, who is asking, what version of Starship will the human landing system be based on? Alex, I'll throw this one over to you, and I really hope you say Block 3, because if it's not Block 3, then we might be waiting even longer.
Well, yeah, for now, it seems like it's going to be Block 3 / version 3, whatever you want to call it, right? I would be very disappointed if it were version 4, because that needs well, I guess you could technically do HLS, like the actual ship itself, as version 4 in Megabay 2. The booster, though, they cannot do booster version 4 until they have the Gigabay built, because the current version of the booster is already tall enough that it just barely exits Megabay 1. It needs the Gigabay with a really big, tall building and interior and door and whatnot. So yeah, I guess you could, in theory, indeed, create some kind of version 4 ship in Megabay 2. It's tall enough for that. But yeah, right now, as far as we know, it's going to be version 3. It's not going to be version 4. Eventually, I guess it'll be, but way later down the line.
Let's have a look through here. We have Observer127 asking, can you explain the types of engine that this SLS version is using, and what are the future engines for Artemis? Max, I'll throw that one over to you.
So on the base of the big orange core stage you are seeing there are the RS-25D variants. So these are some of the last engines, or the latest versions, to have flown in the space shuttle program. The engines in particular being used on Artemis II are engine 2047, 2059, 2062, and 2061. 2047 is the most veteran of the engines on the mission, because it has flown 15 times. And 2059 has flown 5 times, 2061 only twice, and engine 2062 is the one rookie of the bunch, being this being its inaugural flight. It was built and ready during the latter half of the space shuttle program, but it has never flown to this point. regardless of how many times they have flown, this will be the last flight for all 4 of them, of course, because SLS is a completely expended launch vehicle. Which is a great shame because the RS-25 is a marvel of engineering. Designed in the late 70s, it is a staged combustion cycle engine fueled by hydrogen and oxygen. So one of the more complex variants of a rocket engine, with the preburner exhaust being fed back into the combustion chamber to provide as much efficiency in combustion as possible, but also using the most tricky fuel to use of any so far that we have seen, whether it be propane, kerosene, methane, hydrogen, or UDMH, which is a hypergolic propellant that we have seen primarily on older launch vehicles, but there are some launch vehicles that still use it today. Cough, proton, cough. But yes, so there were 16 engines in total, and they will be flying the first 4 Artemis missions before Artemis 5, which is of course the second mission, the second flight of the Block 1B variant of SLS, which is where they will move on to the RS-25E, which is a newer variant of the RS-25, to where Aerojet Rocketdyne, now L3 Harris, restarted engine production, and that is a version of the engine that was optimized from the beginning to be expended. Of course, the RS-25D was first engineered to be recoverable because, of course, it flew on the back of the orbiters, and all the orbiters, of course, were either brought back to the Kennedy Space Center or the Edwards Air Force Base in California. Of course, the RS-25E is not going to be coming back to Earth at all, except back through burning up in the atmosphere and then probably in the ocean somewhere. So they are using up all of the last flight-ready RS-25s they have left before moving on to the RS-25E.
Indeed. Very briefly, we've been getting a bit of support over the last half an hour, so I should probably thank some people. Telstar86 gifting a Red Team membership. Bob Fillmore gifting 10 Red Team memberships. Thank you for that, Bob. We have the Space Pope in chat, who says, bless this trench, with a $20 super. Space Pope is always in chat, so thank you for that, Space Pope. Ryan B, becoming a Capcom member. That means you now get access to our member Discord, which is a fun place to hang out. We have Daniel Rydell with a $5 super chat asking, why did the Kennedy Space Center lease 39A to SpaceX instead of 39B and keep the historic pad 39A for NASA? Alex, I'm going to throw this one over to you. Do you know if there's a specific reason why NASA decided to make 39B the kind of the clean pad and lease out 39A?
It goes a long way back. Even in the shuttle era, they stopped using 39B, and they at some point they sort of transitioned all the launches out of 39A. To be fair, also all of the launches at the beginning of the shuttle era were beginning with, they started out from 39A, and then they started using 39B much later into the program. But it's always been sort of, I guess, the B side, right, of those 2 launch pads. And the reason why they stopped using it for the shuttle was because at the time they were proposing doing constellation, right? With Ares 1, Ares 5, and all that. And so what happened is that they just wanted to transition one of the launch pads, essentially doing the same thing that they did with the transition from Apollo to the shuttle, where one of the launch pads was being sort of rebuilt into the new program, right? Excuse me. As they were still launching other missions from the other pad. So they removed the rotating service structure, the fixed service structure, they put up the landing towers, they built this mobile launcher where SLS is right now, that was built originally for Ares 1 and then was modified for SLS. But all of those things were done at the time in order to use 39B for that. So what happened is that the shuttle program, well, first of all, Constellation program was canceled, but then SLS came into play. So they still were going to use 39B. But then the shuttle program ended, and they thought, hang on, we actually only need one single launch pad for this new program that we just have, and it's only going to be used for launching SLS. So what should we do with 39A? And so for a few years, it was sort of sitting out there, mostly not doing much. And then in 2014, that's when they did the lease to SpaceX to be able to use 39A. But that's sort of the long answer. Like it's not just, oh no, we're not using 39A because we don't care about it. It's more like They just didn't see the use on that, and 39B was already converted into use for SLS, right? Not fully, but at least was in the way of getting converted for this rocket. So it didn't make sense to also do that with 39A, especially with the kind of launch cadences that they were targeting already at the time. Side note here, at the time they were targeting 3 launches per year for SLS. We've gone now down to 1 launch per year for SLS at the best. Just saying. Can we go back to when they were planning that, please?
Yeah, instead of 3 launches per year, we're getting 1 launch every 3 years.
Exactly. But yeah, that was one of the original requirements of the program.
We also have Woodworker Don gifting 10 Red Team memberships. Thank you for that support. And Space Pope gifting 10 Red Team memberships as well. So thank you to everybody gifting memberships and super chatting and tipping and storing and all of the things. It really goes a very long way into helping make these streams a reality. Without the support, we simply could not do what we do at such a scale. So, we're reinvesting everything, and we're going to bring you the best coverage of Artemis II possible, and we're going to bring you as close to the action as we physically can. So that's why we have God knows how many cameras set up in Florida right now, bringing you live views of the rocket. Anyways, we are now approaching L-1 hour in the count. It feels like we've been streaming all day. Oh wait, we have. And finally, we are getting to the... Well, it's probably been delayed. We're not exactly sure. But finally, we are getting to the exciting point of the countdown where many, many, many events are going to happen. This, Alex, is just a short selection, a highlights reel of countdown timeline events to come over the next hour or so.
Yeah, there's still quite a lot to go through, right? They still need to complete a bunch of things you can see there. Mostly just about completing a lot of the closeout tasks and things like that. I'm actually looking at our timeline here on the left rather than mine for once. But yeah, there's still a lot to go through. I don't think we're gonna get to all of those things there at the bottom after sort of the NASA test director briefing and whatnot. Don't think that's gonna happen that soon. Just to put it in perspective, when we saw the Closeout crew arriving at the mobile launcher, to sort of compare a little bit with the official timeline. So per NASA, on their press kit, the event called Closeout crew arrives at the White Room, so not even mobile launcher, like much more beyond just arriving the mobile launcher. That was supposed to happen between L-4 hours 40 minutes to L-4 hours and 25 minutes. It actually happened, or at least arriving at the mobile launcher. We don't know exactly how long it took them to reach the White Room, probably about 5 minutes if I were to guess. They reached the mobile launcher at L-1 hour and 55 minutes. That's about 2.5 hours of difference at best, right? So I will say if today were to be launch day, I will be very, very worried because launch day, we will have about a 2-hour window, right? So being 2.5 hours behind your timelines, or at least your planned timelines and whatnot, will worry me. I trust that some of these timelines are long on purpose, like they just have a lot of time allotted to these operations because they are sensible operations. Like you need to make sure that these hatches, for example, are tight and sealed and everything. Like I trust that is the case. For example, for Dragon, we see this multiple times that, sometimes they close the hatch and it's on the first try, and then they're just hanging around there because there's not a lot more to do, even though they have like 30 or 40 minutes allotted to those operations, and then they usually do it in like 5 or 10 minutes, right? So you still have like 20 or 30 left. So I trust that that's essentially what they're banking here with today's test. Again, the test window actually, so I was talking 2 hours for the launch window. For today's test, they actually go for 4 hours, not 2. So they will have plenty of time. But again, if we were to be on launch day, I will be worried at the very least.
I think they might have a dead pixel grid on that
It's just
clock.
panning.
Oh, that is driving me crazy now.
That's really annoying. Yeah,
That's a-
that moment of going underneath 1 hour has been completely ruined by the fact that the what is it? They have blue. They don't have any. Their green pixels have died in that one part of the countdown clock.
Yeah, as I told one of our ACL operators, I was like, "That's just tanning. It's tanning, just like the rocket."
That's
'Cause
really
it turned
annoying.
red.
Anyways, under an hour left to go now until the simulated window opens for the Artemis II Wet Dress Rehearsal. We're nearly there, everybody. We're nearly there. We have a couple questions here about the solid rocket, but well, a couple of the similar questions here. We have that one, WestJet Aviator, asking, why is there a black ring around the left SRB, but not around the right SRB? And Cyborg also asking a similar question, why one of them has a black ring near the nose cone. Max, I'll toss this one to you. Do you know why one booster has a black ring and the other one doesn't?
I believe it has something to do with the fact that each part of the vehicle needs some sort of marking to distinguish it at some point in flight to aid tracking assets further in flight, or if God forbid there was something to happen in flight, and they need something to identify what parts are I guess able to be seen and made out of. The vehicle has these like black and white markings placed all over it, and those are also for the engineering cameras on the launch pad itself, which are firing at hundreds, if not thousands, of frames per second using film. And they need those serve as like points of reference for those cameras to see how the vehicle is behaving, whether it is moving left or right, up and down, or twisting in a certain way. Those are just used as reference markers for any sort of motion for I guess later analysis. So I assume that black ring has something else to do with it, and also in flight, it makes it a lot easier to distinguish which side of the rocket you are looking at when you have a feature like a black ring on top of one of the SRBs to look at. Say if it's farther down range and you are looking through a telescope or just a big long lens anyway. So something to do with that. Although I don't have any sort of official answer. That's just what makes sense to me.
That's exactly the case, because it's like, why does one have a ring and the other doesn't? Well, that's the reason why, because it's like you can know which booster you're looking at because it either has the ring or it doesn't, right? It's similar to how, for example, during spacewalks, there's an astronaut. Usually, spacewalks are like 2 people. Very rarely, I think there's been like 1 or 2 that have had 3 people. But
yep,
what they do is one of them has red stripes or blue stripes, depending on which country. I think Russians use blue stripes instead. But one has like stripes or different colors than the other. So you know that if it doesn't, like if the person doesn't have those on their suit, then you know it's that person and not the other. Like it's a very easy way to distinguish between 2 things that look very similar.
Yeah, they have these black and white segmented squares like on the SRBs. You'll see them on the core stage as well, and they're also on the ICPS. They are all over the vehicle just to serve as points of reference for the actual engineering cameras for later analysis. But that is essentially what those are, and you can actually see 2 of them right there. So if you look towards the very top of the SRB nose cones, come down a little bit right above the American 250 logo, you'll see these like 2 black squares kind of diagonally against each other. Hey, a chopper's flying behind the ML. Nice. Those are those are a classic example of 2 of those. And then also if you come up towards the ICPS, towards the very top of the ICPS, there is one there as well. I believe I think it's the same scale as the 2 on the SRBs. Oh boy, tough to see on this camera because it is shaken with distortion. But yes, if you look towards the meatball, the NASA meatball, come down just a hair and off to the left, where those two black specks are kind of angled towards each other. If we had a clearer image of that, or a camera on the pad, that would be like a black and white segmented square, and that serves as one of those points of reference. So they're all over the vehicle, and that's what those essentially serve as.
Exactly. And speaking of the SRBs, we have Blind 1-40206 who's asking, with the cold Florida weather, which is expected, are they looking out for anything like what happened with the unfortunate Challenger disaster with the O-rings? And Alex, we were talking about this earlier, but if you would like to go through this again, because there has actually been, it's been a lot of time has passed since that unfortunate disaster. And a lot of work has been done on upgrading the solid rocket boosters since then.
Yeah, after the Challenger disaster, they didn't just say, "Oh, we'll not launch in cold weather," right? And we'll keep the SRBs the same. No, they actually went in and did a thorough redesign of the SRBs, not just the joints, but like many other systems were also upgraded as well. They took the opportunity to also upgrade a bunch of other systems. Remember that, after the Challenger disaster, the shuttle was essentially grounded for more than 2 years, right? So like all of that time was precisely to be able to introduce design changes, new procedures, and things like that. One of them was precisely upgrading the joints on the SRBs. One of the many different changes that they did was changing the geometry so that it is harder for things like that to happen. They included another O-ring as well, so there's 3 O-rings instead of 2. Instead of a primary and a secondary, you have a tertiary as well. And there were also heaters as well, so that the material can be at higher temperatures, essentially, even though outside it might be colder. Additionally, over the years, they also upgraded the SRBs. Even the joints themselves were upgraded over the years with new materials that could withstand even colder temperatures. There was a certain unknown, very rare place. I think it's called NASASpaceflight. That in 2009, for example, wrote an article about this ahead of the STS-125 mission. If you remember, that was the Hubble Space Telescope, the last of the shuttle missions to the Hubble Space Telescope, and it was flying with upgraded joints as well. Like those things happened many times after Challenger. They did not sit idle, essentially, when that happened. So, yep.
And we have Luke, who is asking, will Orion do a thermal control roll / barbecue roll? If it does, how does that work with respect to keeping the solar panels facing the sun? That is a great question. I don't know. Does anyone know what they're going to be doing with Orion in terms of not cooking the spacecraft and the crew inside?
It's actually going to have to be pointed all the time with the solar panels to the sun, so it will not be doing a barbecue roll.
I suppose that makes sense. Okay,
it's got a much better system. Sorry for butting in, but I will argue that it also has a much better system than Apollo. Like Apollo did that because they could save on thermal control systems and whatnot. During Apollo, they could save on that by doing the barbecue roll and whatnot. In fact, side note, if you look at the Apollos that went to low Earth orbit versus the one that went to deep space into to the moon and whatnot, you may see that there's differences in the outside precisely because of the different environmental constraints, like the illumination from the sun, etc., etc. And also another side note, the thermal control systems on the European Service Module. Yeah, that's made in Spain. So yeah, that's one of the things that we do for that. Please work. Please work.
And for those of you wondering what on earth a barbecue roll is, first of all, I apologize for making you hungry. I'm very hungry. Essentially, back in the Apollo program, the command module and the service module, it would essentially roll like a piece of meat would over a barbecue, in order to spread the thermal loads evenly across the entire vehicle. And that was to make it not basically be really, really hot on one side and really, really cold on the other side, and make expand one side of the spacecraft and shrink the other side of the spacecraft. So that's what we were referring to there. A bit of a more speculation question here from Tucker asking, as of right now, is the launch window still possible for Sunday night? Max, I'll go to you first. Considering the leaks, considering how NASA has kind of pushed back to get this vehicle fully fueled, and considering we're not actually complete with the testing yet, what do you think? Do you think Sunday is still on at this point?
I mean, we're easily, from what we can tell, we're roughly somewhere in the ballpark between 2 to 3 hours behind the nominal timeline, based on when the closeout crew was supposed to head off to Pad B compared to when they actually did. And not to mention the fact that they stopped and restarted hydrogen loading on both the core stage and the ICPS multiple times to this point. And their wording behind the releasing, or the phrasing in their blog updates around those issues, didn't so much sound like a solution, but a workaround, which wasn't very confidence inspiring. So in terms of timing, they essentially need the rest of the wet dress rehearsal to happen as it should. Otherwise, they risk violating the launch, I guess the in quotations launch window, and then of course failing the test at that point. And I think if wet dress tonight does not go well, depending on what the issues are, I don't believe they have the resources or the time to recycle for another test before they run out of time to prep the vehicle before the end of the launch window, which mind you is February 11th. The current net date is the 8th, and after that they have both the 10th and the 11th. So they're already right on the edge with both the launch window, and of course also with the launch window tonight. They have until 1 a.m. tonight, so it's going to be a long night for us, and I guess just a long day in general. But they're right on the edge. And I was talking with Philip. Well, I shouldn't say I was talking with. I was listening to him on stream earlier, and he said he was a bit less confident towards the latter half of his stint than he was, say, 4 or 5 hours prior. And I would have to agree with him on that front, because they're right on the margin now, where if they find another error that eats up an hour and a half of time, they might not have enough time before the end of the window to sort everything out and continue on with the countdown. TLDR, I know that was a very long-winded answer. I think TLDR, I'm like,
I don't think so.
no, I'm like
answer.
60-40 no right now. Yeah. So to answer the question, no, I don't, unfortunately.
I'll make this even harder for you then. Does anyone think that a launch in February is still on the table?
No.
What do you think, Alex?
I think there's still a chance that, if they're able to complete all of these tasks, I mean, they eventually got the propellant in, right? Like, they did have the issues like we saw on Artemis 1, but just like on Artemis 1, they eventually made it work, right? Whether this will work on an actual launch day or not, Artemis 1 had the sort of advantage that they didn't have to load crew, right? And they need the rocket to be fully loaded and in replenishment mode in order to go out there with the crew. I have no idea. As I said before, I would be very worried if today were a launch day, because we would be in oops, maybe they missed the window territory, right? So we'll see. I think we may see them still target a Sunday launch, but whether they actually launch on Sunday or not, we'll figure it out as we go along.
And we'll be live no matter what. So if you want to watch, press subscribe, follow the socials, stay tuned, because we're going to be live no matter what happens. But technically, we're going to be live 24/7, because we have 24/7 views of the SLS rocket on the pad all day, every day on Space Coast Live. So that's I don't know, if you have a spare monitor, you want to put that on the TV during the day, you want to open up Space Coast Live, I would highly recommend it. So I'll look through here for some more questions. If you're just joining us, you can tag us in chat at NASASpaceflight or at NSF, and that will bring the question, or filter the questions through and into a nice little queue here for us, and we can bring them on the screen. We have a question here from Skipper, who's asking, what happened to the crawler after the Artemis rollout? It surely seems to have moved away somehow after moving the rocket in place. And Max, it did depart 39B, didn't it? It has moved away from the pad at this time.
Yeah, but it did it in sort of two different stages. So at first, it was stationed just outside the pad gates for a few days, and then once I guess everything was deemed appropriate, it was moved back. It was moved back towards its parking area, kind of towards the LC-39 observation gantry, which is about in between LC-39A and 39B. You'll pass it actually if you go on a KSC Explorer Tour bus tour. It's right there, so it's maybe about a mile from the pad right now, maybe just a shade more. But it is currently parked up and waiting for its next opportunity, whether it be to go back and pick a SLS up for a rollback, or just to come back to the VAB or the crawl yard and get ready to support Artemis III at some point in the future. So that's where it is currently parked, and it has been there for at least a few days now. And hopefully it won't need to go back to the pad, because if it does, that will signify the presence of a much greater issue, and hopefully by that point we will know all about it.
Indeed. Oh, this is another great one to go around the room. We have Heck in Robin 811 asking, what would you require, or what would you consider rather, to be required reading for a space noob ahead of the Artemis II launch? Alex, I'll start with you. What do you think is required reading ahead of Artemis II?
Oh, for a space noob, I mean, it depends which level of noob, right? Uh, if you are truly like completely detached from anything technical, I will argue that less than reading, I would just tell you like try to hang around with other people that know about it. If you want to look up things, even just Wikipedia could work, or if you are more of like, ChatGPT, Grok, and all that, do it if you want to. There might be a few things wrong here and there. I'm gonna be honest, even Wikipedia, to be fair. But it serves as a base, and I think that's very important. Like if you don't start reading, like that's the first step, right? Like you actually have to go out there, Google things, and look out for information. If you are truly at that level. Now, if you're a little bit more like, yes, I know about space and whatnot, but I'm not too much into engineering and I want to learn more about that, then I will argue that, things like some of the more in-depth documentation from NASA and things like that, like the press kit, the reference guide and things like that, those things might be a little bit more for you. But again, there are different levels of new, right? That I would argue that if you are of the lowest ones, just look up for information, like just Google things and try to absorb whatever you can absorb as you go through.
Max, do you have any required reading?
I'm going through my Audible library right now, and the two that stick out to me the most, firstly, is Bringing Columbia Home, and it was written by a handful of people that were on the ground directly supporting the operations and recovery of Columbia and STS-107 and the fall of her crew. Definitely would recommend reading that, because that really puts in perspective the danger associated, the danger and risk associated with a spaceflight in general, but the power of persevering through it. Then also An Astronaut's Guide to Life on Earth by Commander Chris Hadfield. It is a wonderful light read, or I say light read. It's about maybe 8.5, 9-hour read, if depending on how fast you are. But he offers a wonderful perspective just on normal everyday life and the habits of the habits that he has developed in his career as a test pilot and an astronaut, and how that carries over into everyday life. So those are my top two. I would also recommend Endurance by Scott Kelly. It is a wonderful book. Actually, hang on here a second. Is SLS getting frosty? That looks like frost.
I think it might be the oxygen. that is being vented.
The oxygen and the hydrogen tank. That looks like frost. I know that is possible under certain atmospheric conditions when it's either very humid outside or the temperature is low enough, and it is very, very cold out here and has been for a few days. But it looks like we have some ice or some condensation beginning to form on the outside of the Sophie. Oh my God, I can't talk. That does not happen very often. I mean, we certainly were not expecting that tonight.
Yeah, I mean, it's certainly much more pale. And I will just say we have crossed L-40 minutes, which means we are now under T-10 minutes and holding. If they remain on schedule, this will be a 30-minute planned hold, which releases, as you would expect, at L-10 minutes. But we will stand by and see what actually happens, because as we have been talking, what have they even done to the countdown clock at this point? They've butchered this thing. What have they done? Like
oh my God, that first zero.
The first zero is huge, and the half the H is cut off in hour, and the blue bar is.
Look how you massacred my boy.
What have they done? Like, I genuinely could not make a clock look like that if I tried. We're a far cry away from the retro Apollo era countdown clock that was ticking away. Now we have whatever that was. Anyways, you can certainly see one side of the core stage seems to be kind of brown and the other seems to be orange. So definitely looks like there's a little bit of maybe it's just condensation or frost forming on that side of the stage there.
And I saw some comments, actually not in chat but elsewhere, and I would like to bring this up now because since we are now technically in the T-10 minutes and holding point in the countdown in the T- clock, right? Not the L- clock. Now, if there's any moment in the countdown that we will see any sort of shift to that simulated T0, will probably be now, right? Like, as they're still working at the White Room and closing out Orion and things like that, this will be probably around the time where Charlie, the launch director, she will be saying, okay, what sort of the timelines that we can work through, and which could be a new T0 and things like that. So those are probably things that they might be talking about in the background as, sort of their management team sort of looking through and seeing when might be a more realistic simulated T0 for this test. Talking while muted.
No, I just didn't have anything to say. I was just looking for another question to ask. Well, whilst I queue up some more questions, a little bit more support has come in over the last few minutes. So I will say thank you for the support to Rosebud53. I'm not 100% sure what you're asking here, but thank you for the support nonetheless. You can just do another normal message in chat to clarify if you want. Echo Deal saying the countdown clock has experienced some kind of spatial anomaly. We also had Greg purchasing the vintage Artemis design, the Blame Hydrogen design, and the Blame Hydrogen design on a shirt there at shop.nasaspaceflight.com. So thank you for your support there. On the store, those available. The Hydrogen, Blame Hydrogen available for a limited time. The other designs available throughout this Artemis II launch campaign. So we are now at 2 of 3 milestones on the store. We cleared the rollout milestone. We cleared the wet dress milestone. Next up is the launch day milestone. And there's a suspiciously diamond-shaped design on a t-shirt. That's all I'm going to say. That will be revealed on launch day. Questions. I have a question here. Oh, I've lost it. Where was it? There was a question about Crew 12, which was a really good question. Where's it gone? It was literally just in the queue, and now I can't find it. Forgive me for whoever asked this question, but someone was asking if... Oh, here we go. From Cleverly Twisted, asking if the launch is pushed back, will that affect the Crew Dragon launch? And I'm going to try and remember off the top of my head what the criteria is. I'm pretty sure if Crew 12 launches before SLS, I don't think there's going to be any conflict. However, if Artemis II launches before Crew 12, well, first of all, I think if Artemis II gets into a countdown, they have to wait 48 hours, I believe, before they can attempt Crew 12. If Artemis II launches, they have to wait 10 days before launching Crew 12. So Crew 12 will not launch while Artemis II is in space. So that is a constraint there with Artemis II going first. I'm not sure if a similar constraint exists the other way around if Crew 12 launches first. I'm pretty sure if Crew 12 goes first and then Artemis II, there isn't any constraints, considering it will only take them a couple days to get up to the International Space Station. So I don't think that is a concern as it stands. If I'm misremembering, I apologize, but I don't think it's that big of a concern. And there are plenty of places for suit up. For example, there is the usual location for NASA astronauts is the Operations and Checkout building, but SpaceX also has their own facility at Launch Complex 39A. Of course, Crew 12 is launching from Space Launch Complex 40, but I don't see any reason why they can't suit up at 39A, drive over to 40. So maybe NASA will be using that facility if Artemis II is utilizing the ONC building. So there's plenty of alternate strategies to getting two crew missions off the ground from the same spaceport. And also, how fantastic is it that we have this problem? That we have two crewed missions launching at a similar time. Like, what a problem to have.
Like, these are the problems you want to have. Like, if you rewind even 15 years ago, we could only even dream about these problems. At that point, we were still launching crew on Soyuz, like, and that was our only method of getting to and from the station. So this is a wonderful problem to have.
Yeah. We have a question here from ResistoJet, and they're asking, after a successful wet dress rehearsal, what are some of the key events happening between now and launch day? Alex, I will throw this one over to you, because there's a few things that have to happen. Mainly the payload has to arrive, but there's a couple of other things that has to happen as well.
Yeah, the self-loading payload, right? Yeah, well, one of the major ones I would argue is replenishment of consumables, right? On the pad. And that is one of the things that should happen in between this test and the next launch attempt, where they're going to go out there and replenish the liquid oxygen tank farm, the liquid hydrogen as well, to be able to try again during launch. Of course, I'm assuming that one of the things that they're also going to be doing is opening the hatch of the launch abort system and setting up all of the different tooling and whatnot to access Orion, opening the hatch of Orion itself. Remember, there are two hatches here, because you have the hatch on Orion itself, but then there's the launch abort system, which has this ogive that it's sort of covering the capsule. And so there's another hatch there as well that you have to open and close as well. So because it is being closed everything now, then it's got to be open, because otherwise, how is the crew getting into Orion otherwise on launch day, right? So many things like that. I will think probably like servicing some of the consumables probably on Orion as well. Those might be expended during this test today. But yeah, there are many things that have to be done. For the most part, though, in a very general sense, SLS and a lot of the ground systems are pretty much ready to launch. For example, things like setting up the SRBs so that they are loaded with hydrazine so that they can steer the nozzles on the SRBs, things like that, like servicing a lot of those systems. Those things have been done already ahead of this test, so there shouldn't be as many things between now and launch to be done precisely because of that. But some of the major ones, as I said, replenishing things that are being used on this test, that's number one probably on their list, and obviously opening Orion, because otherwise they cannot go into the capsule.
Exactly. we have another great one that we can throw around the room here because we have Ari who's asking, what are your predictions for Gateway? Everybody's favorite lunar space station. Max, let's start with you.
Ugh. I don't know. I've gone back and forth about Gateway in my head many, many times, and I still. It's a wonderful concept, but I'm still of the opinion that it's not going to fly and it's not going to work. So, TLDR, I don't think it's going to fly. I think that I'll just leave it at that.
What do you think, Alex?
There's obvious forces, right? Here, in between many different factions, if you want to call it, or groups, or things like that, where it's like, we want to cancel Gateway, right? But then you have Congress being like, no, I want to keep Gateway. And, for anybody that has watched, for example, the confirmation hearings with Jared Isaacman, we have seen Ted Cruz, for example, being super, on top of Jared, being like, you gotta follow the law, and the law says that Gateway must be a thing, and all, right? So it feels to me that it might still launch, at least the early elements. As to what kind of future it'll have after that, we'll see. Yeah, that's one of those things that, as Max said, I'm really not too sure what's going to happen. There's definitely going to be lots of debates, though. Another point to add to this is that recently there's this sort of bill that they're trying to pass in Congress now, that is the NASA reauthorization bill for 2026, and it also includes more support for SLS and Gateway and everything, which could go even beyond Artemis 5. We were talking before about how they have funded now Artemis 4 and 5 mostly on their entirety. So it's like, maybe we're gonna be stuck with SLS for a lot longer than we expected, even though it was something that they were trying to cancel earlier last year. So we'll see.
I have to say, I think the idea of a lunar space station is great after you've done the lunar base on the surface. Because my fear is that if we're going to fund a space station in lunar orbit, is that we're going to fall into the exact same trap that we fell into with the space shuttle program, and that we're going to be stuck in lunar orbit for 40 years. We won't actually be able to land on the surface. We won't have a lunar base. Now, thankfully, some people like Jared Isaacman and the current administration in the White House are saying, we need to build a lunar base. But the law doesn't say that at the moment. We need Congress to get on board with that, for that to actually become reality. So that makes me hopeful. But I do recall a while ago at this point seeing a kind of a render from Thales Alenia Space, who are building all, if not the majority, of the modules, the pressurized modules for the Lunar Gateway. I saw a render from them with a lunar base on the surface with a bunch of modules that look suspiciously like space station modules. So maybe Gateway components could be kind of retrofitted by Thales Alenia to be surface-based compatible, because, I mean, if they can survive 1G on Earth, surely they can survive a 6th G on the moon, right? Does that check out?
Yeah, that makes sense. One of the things that I will say is that I agree with you that I wouldn't mind to have a gateway. I just don't like the gateway that NASA is proposing, right?
Yeah.
An orbital station around the moon sounds cool, but it's cooler if you already have people on the ground. I want to see a future sort of For All Mankind style, where you've got, season 2 spoilers. If you haven't watched season 2, though, I'm sorry for you.
Hang on. Give it a good. Okay. Spoilers will be over when Jay cuts back and from cameras really, really fast.
Oh my gosh! I thought you had an update.
I thought you had one too, Ryan. Jeez.
Yeah.
No, I'm just making sure nobody gets spoiled. That's all. Spoiler alert. Okay, mute the stream now. Unmute when Jay cuts back and forth the cameras really, really fast.
Oh my god!
Alex,
my
go.
Goodness. But yeah, season 2, where there's Skylab in low Earth orbit, and then you've got shuttle going all the way out to the moon. That was crazy as well. and then you've got a base on the moon, and there's this whole thing of like there are multiple things going on at the same time. That's cool. That's actually something that I would love to have. It just feels to me like having Gateway can be an excuse to not having a base literally on the surface, like just a few 100 kilometers down there, right? Or 1,000, depending on where on the near rectilinear halo orbit you are. But that's one of those things that I would prefer over just tiny little station. It's worth reminding that Gateway is not supposed to be continuously crewed, for example, unlike the ISS. It's less than a third the size of the ISS. The modules are even narrower than those on the ISS. Like the ISS modules are wide and things like that, and you could have like 2 or 3 people even side to side to fit in that diameter. That's not going to be the case with Gateway. Like, people don't appreciate how small and how I don't want to say useless, okay? Because it does have an use. I just don't like that use, okay? It could be better. It could be made much better. How about that?
Jay, you can now go back and forth between cameras really fast so everyone knows that Alex is no longer going to be spoiling for all mankind.
Come on, if you haven't watched season 2, I'm really sorry, but you should have seen season 2 by now.
There we go. Okay, hopefully everybody's back with us. We've got a little bit more support in the last few minutes or so. Just another YouTuber 32. Thank you for your support there, saying shout out to all the technicians and quality assurance who have worked their tails off to get SLS rolled out on time. They are the unsung heroes. And yes, seriously, if you worked on this rocket, first of all, congratulations. Second of all, thank you for working so hard to get this rocket out to the pad, because finally, we have a rocket fully fueled, testing to launch 4 humans to the moon. That hasn't happened since 1972. That hasn't actually happened on this pad since 1969, because the only mission to the moon from this pad was Apollo 10.
That's
Fun
correct.
Fact. Jan Eccles with a $25 tip. Thank you so much for all of your support. And they are asking, would you entertain having an NSF meet and greet either in Florida or Texas leading up to or after a launch? I don't know if there's anything specifically on the cards, Max, but every so often maybe there's like a meetup at Hopper House or something.
Yeah, usually Hopper House is one of the places to go after a Starship launch campaign, because everyone just loves to go hang out, talk, and just catch up, because Starship launch campaigns are always busy and stressful. Regarding Florida, I mean, I can't even think ahead beyond like Wednesday right now, so it's difficult to really say that we're going to try for some kind of meetup here, but would love to. But when the time comes for it, then maybe we can tackle that. But I truthfully I cannot think beyond Wednesday. That's where my brain's at right now. So, but definitely Hopper House after Starship is always a go-to. Also,
100%. And if doing God knows how many super chats and gift memberships today wasn't enough, Space Pope has been on the store saying thanks NSF, love the design. That is of course the only SLS assembly design available at shop.nasaspaceflight.com. There you go. Thank you so much for your support, Space Pope. As always, it is very meaningful. And as it gets darker here, probably gets colder as well, you could definitely now start to see kind of the frost on the outside of the core stage there.
Yeah, so it is currently 42 degrees Fahrenheit here at the Kennedy Space Center, and the low tonight, oh golly, is 28 degrees Fahrenheit. So what is that? Like -2, -3 Celsius?
42 Fahrenheit is 5.5. What did you say the other one was?
28 Fahrenheit.
That is -2 degrees Celsius.
Good God. So below freezing. So either way, that is below the average temperature or minimum average temperature requirement for NASA. But granted, that's also over a 24-hour period. But regardless, that is still incredibly cold, especially for Central Florida, even in the wintertime, because normally our temps average anywhere from the 55 to 70 degree area for, I guess, a nominal winter time. I'm not sure what that translates to into Celsius, but regardless, this is unusually cold, and locals are not happy, myself included. This has been quite unpleasant. And this is not hyperbole. This is not meant to be a bit. I'm not even joking. This feels worse than Norway did back when we were there not too long ago, especially yesterday morning when we were out at the near the pad for a photo op at about 5 o'clock in the morning when the wind was howling and the wind chill was about negative 9 degrees Fahrenheit. Or I'm sorry, 9 degrees Fahrenheit. Awful. It was genuinely a miserable experience. Very, very cold. But the bright side is these colder temperatures are allowing us to see, I guess these temperatures and humidity levels are allowing us to see a rare glimpse into some frost coming through the spray-on foam insulation or the SOFI on the outside of SLS's core stage. I've seen this on maybe a handful of missions with the Space Shuttle program. And also with Delta IV, because that uses a very similar SOFI application. But it's not meant to do this, but there is no insulation that is perfect, and SOFI is certainly no exception. And that is why you still get boil off both on the LOX side and on the hydrogen side as well. So, but it's still very, very unique to see, and honestly kind of cool, because I wasn't really, I didn't think that we'd see this.
Yeah, it's pretty cool to see. And I've just been looking up on the internet. Kind of the average cold temperature for Florida in February is 10 degrees Celsius, not -2.
Exactly.
So that's a bit of a swing.
Just a little bit, yeah.
We're now at L-18 minutes and change, and we are, if everything was going to schedule, we would be 8 minutes away now from the count being picked back up at T-10 minutes to proceed with that terminal count. However, the last update from NASA was over an hour ago. We haven't heard anything since the Closeout crew was sent to the White Room. So I'm going to go out on a limb and say that might not happen.
Yeah.
I don't know if anyone disagrees with me, but it's not looking too great at this point.
I mean, having these big gaps in between updates is not necessarily the most confidence-inspiring thing to happen, especially when you're already 2.5 to 3 hours behind your nominal timeline in a field where you already only had a 4-hour window to operate in what you wanted to. So, not entirely confidence-inspiring, but again, they have until 1 a.m. tonight. So for all we know, they could turn things around and actually get the test done in that time. But there has been enough happening to this point to, I guess, reduce confidence levels in a launch attempt on February 8th or just this month in general, because they also have the 10th and 11th after that. So, but we'll have to wait and see, as we often say.
Let's look through some more questions here. Bob12843 is asking, what is that flame over there? Is it for leaked fuel? And we can't see it on this view, but on some of the views we can see what is known as the flare stack max. And it's not really for leaked fuel, but it's for intentionally boiled off fuel, right?
Yep, it's for any excess hydrogen, which of course is being used for both the core stage and the ICPS, which is the bit there below Orion, where the launch vehicle service or stage adapter, I guess, tapers down to the white part up top. So it is boiling off excess hydrogen because of course both the ICPS and the core stage are now in stable. Oh god, I can't say the word.
Replenish.
Yes, thank you, Ryan. Some words I just cannot say sometimes, but both vehicles are currently in that mode, being topped off, and that is where some of the excess H2 is heading off to right now, and that is why the flare stack is going to be going constantly. In a launch scenario, once they cut off the supply to both stages, that there will be a bit of a flash or a bigger flash coming from the flare or burn off stack right before launch, and it is quite the sight to see. We also see it with New Glenn at LC-36 as well, because it uses hydrogen on its upper stage, GS2. So that is just what that is. We also see it with Atlas V and Vulcan, because they also use it on their upper stages, being Centaur 3 and Centaur 5. So not unusual to see it. It is all part of nominal operations. I guess if you're new to this area, it might be a bit worrying to see fire around a rocket that is not currently launching, but that is just all part of the nominal process.
In fact, Max, the other rockets that you were mentioning, like Vulcan and New Glenn, they also use methane, and methane is also flared off.
Yes.
They have flare stacks both for hydrogen, but also for the methane itself. Blue Origin, they have 4 flare stacks at their pad, because they have You have the
Yes.
storage tanks on the ground, right?
Yep.
And those boil off because it's sitting there on ground tanks, and you have to boil that off, and therefore you have flare stacks for those. But then you also have flare stacks for the boil off of the rocket itself. So like they have 4 flare stacks. They have added a 5th one as well for when they're testing their lander out there. They have a dedicated location to test the lander once they come back and everything. So yeah, that is quite nuts if I were to say so. We
But
don't
you know
see
what,
that.
Alex?
What?
I was just gonna say, you know where you don't see it?
Uh-huh.
Starbase.
Yeah. Why
And
is that, Max?
No, you. I said why first.
Okay, I can say it then. Because instead of, so, we were talking about how these flare stack here, they recapture the gaseous hydrogen that is boiled off from the tanks on ICPS and the core stage, so the 2 stages of SLS. You capture that through dedicated umbilicals, and then those you essentially route it through pipes and everything to that flare stack. But if instead the flare stack, you just have a way to turn that gas into a liquid and pump it back to the storage tank, then you can reuse that hydrogen, right? It's a little bit difficult to do that with hydrogen. It's not impossible, but it's a bit difficult. So, they sort of save on that kind of hassle, and they actually just burn it off. But SpaceX does that with the methane on Starship. So it boils off. They have special ways to capture that on the tanks and whatnot, and then that gets captured by the tank systems, the tank farm systems. It is turned into a liquid and then returned to the main tanks on the ground. There is one place though related to Starship where there is a flare stack, and that is McGregor. So if you go to McGregor Live, you might actually be able to see the flare stack. There they do flare off the methane that they use there. They do not recapture it yet. They probably will in the future.
Keyword, yet.
Yeah, I bet they will. I don't think there's any sort of plans being released or anything, but my guess is that in the future they'll probably have to do that.
Soon, TM. Maybe. I don't know.
Let's have a look through here. 98 Central is asking, do they still use the automatic theodolite gyroscope guidance system that the Saturn V used back in the day for SLS? I would hope they've moved past that at that point, but I genuinely don't know.
I don't know either, but I do know that the structure where that used to be, kind of in a sort of bunker in the middle of the crawlerway heading up the ramp, is still there. So maybe they use that as maybe sort of like a backup or just for like data tracking. But the actual onboard guidance system is not dependent on that like the Saturn V was. So there is still a structure there, although I don't know what its actual purpose is, whether that's a backup or if that system just is not a thing anymore. I'll have to ask a PIO or an SME about that, but I'm not entirely sure. But I think it's safe to assume that it is not a requirement for SLS.
We have Aaron Bennett asking, how come the crew does not go out to the pad to practice getting in the capsule, but the Closeout crew does? And I'm pretty sure, Max, the answer to this is that they already did so last month. Or technically not last month anymore, but December.
They did, and so they performed what was called a countdown demonstration test. And even though SLS and the mobile launcher were still inside High Bay 3 in the vehicle assembly building here, they were still able to go up the elevator and simulate a launch countdown and ingressing the spacecraft, being Orion Integrity. So they already did, and there has been some footage released from the white room there. It's probably buried somewhere in NASA's website. I'll have to dig it up later. But they already have, and they are still currently in quarantine in Houston, Texas. And if all does go well tonight, they should be arriving tomorrow afternoon here to the Kennedy Space Center. But we had to see how tonight goes in the first place to see if that's even feasible anymore. So TLDR, they already did, and tonight is not necessarily required, and they are still in quarantine in Texas. Because there's really no need for it, because that's where the crew and most astronauts here in the U.S. are based at, and there is no reason to have them at KSC when there's I can't talk. Brain is not braining. There's no reason to have them here in Florida when they don't need to be, and most of their operations and their homes are in Houston. So it makes a lot more sense to keep them there unless they have a solid reason to come to Florida. And launching Artemis II is a pretty good reason, but the rocket has to be ready. Ooh. Whoever is watching cameras right now, there is actually a fairing coming back from the crawler transporter road. It is about to pass right in front of SLS. It is coming back right now. Anybody listening in Space Coast Live, it's about to pass in front of the cameras right now.
And
the clock has stopped.
Oh,
we are
boy.
in a hold. The T-10 hold is holding for longer than it was planned to hold. And I'll be honest, we all saw that coming, even if the clock is a bit deformed.
Fairing is passing by the rocket. Right
Okay, I don't. What on earth is happening here?
What the
heck? First of all, photobombed by a fairing.
An eclipse.
I think we've gotten to the point of the night where things are going a little bit crazy. Okay, number 1, photobombed by a fairing. Number 2, we reached T-minus 10 minutes and holding. Number 3, the clock has recycled to T-minus 99 hours, 99 minutes, 99 seconds in holding. I didn't even realize that we were able to count beyond 60, so this is news to me.
Yeah, that I'm gonna go out on a limb and say that fairing was coming back because of what we read earlier about the Falcon 9 issue.
Probably, yeah.
With Starlink this morning. So yeah.
I mean, we saw Starlink was already delayed to from Monday to Tuesday, and then from Tuesday to Thursday, and that probably was the payload that was slated to fly on it. So not entirely promising to see coming back from that time, but also not promising to see the countdown clock stop and then be reset to whatever that was. So yeah, things do not seem to be trending in the right direction right now. But we are still waiting on further word from NASA, and at this point, it has been almost an hour and a half since our last update on operations. So we are a little bit in the dark in terms of what's actually happening, but from what we can surmise based on timelines and from what we have seen so far, it looks like things are not entirely peachy keen.
Yeah, just for context, the last official update we have from NASA is at 19:27 Eastern Time, or in other words, about an hour and a half ago, saying that the Closeout crew, Closeout crew were in the White Room at 39B, and we have not heard a peep from them since. And now the clock says 99 hours left to go, so...
Yeah,
just saying it would be really great for some kind of update right now.
Yeah, and a lot of people are saying there's a built-in hole, blah, blah, blah. No, this is not a planned hole. So, yes, there are 3 different built-in holes. There was one at L minus 40 minutes that will have run for 30 minutes to L minus 10 minutes. But L minus 10 minutes, if you do the math, that was 2 minutes ago. And that was actually when the countdown clock there at the press site stopped. The press site clock was the L minus clock. It is not the T minus clock, which is the one that does have the built-in holds. The L minus clock is just a clock that counts down to 9 p.m. And the reason why it held is because they are for sure not going to go into terminal count with people on the pad. We are definitely not anymore targeting 9 p.m. for the simulated T0 because of that. When are they targeting? We have no idea because NASA has not provided any updates since the last 90 minutes. So we'll see what happens.
In the meantime, on the left, we have that SpaceX Falcon fairing rolling back from the launch pad with the closest fairing track you've ever seen in your life there, courtesy of DYs on the telescope, getting some wonderful close-up views of the scorch marks that these fairings have seen. Previously flown fairings, if it wasn't clear already, but there you go.
Hey, can we read the numbers since we have the telescope?
Well, here we go. We're going down.
Let's see.
See if we can go down far enough.
Let's take a look. Come on. No way. It's going to be dark.
I
can
see
kind
plus
of see
Z,
something. Yeah. Oh, yeah.
Yeah, that's the coordinates.
orientation. Oh, no.
Well,
In this
That's
good
game,
for trying though. Thank you, D.
in today's round of fairing spotting,
There we go, making its way past the Launch Control Center and the VAB. This is a very common occurrence on Space Coast Live, by the way. So if you have a spare monitor and you don't have Space Coast Live open, you should totally have Space Coast Live open, just saying.
So yeah, we are still in that
Yeah.
hold, awaiting to see when NASA is targeting on UT0. So to recap very quickly, SLS is fully loaded. There's people out there at the crew access arm at the white room, and they are the last update that we had though was that they were preparing essentially to close out Orion and close the hatches and whatnot. Ooh, there we go. One of the numbers, 172. Thank you. And yeah, and in the meantime, we're sort of here looking at a Falcon 9 fairing rolling back from the launch site back to the integration hangar, probably hangar X2 at Roberts Road. But it's passing by the VAB, and that's where we have our cameras. So, photobombing, yes.
You know what a hold means?
More time to take questions from people?
Exactly. Well done, Alex. You win nothing for that correct answer. We have Lauren, who is asking, if the crew doesn't launch in February, would they have to re-quarantine again for their actual launch, which isn't for sure guaranteed for right now? So make of that what you will, Alex.
Well, yeah, they have to quarantine again for the launch, but it will be when they actually launch, right? They will obviously go out of the quarantine if they don't launch in February. If they jump to March, then that means they're just
They fixed the clock. They fixed the clock. Breaking news. They fixed the clock. It's now at T minus 10 minutes.
Partially fixed, I will argue, because there's still
Apart from
zero.
ignore the zero at the front. Pretend that doesn't exist. We don't need the hour mark anymore. We're under an hour. Continue, Alex.
But yeah, if for whatever reason this jumps to March, they only need to be quarantined for 2 weeks before the launch. So that means they can essentially come out of the quarantine and just do it again 2 weeks ahead of the launch, whenever that next opportunity might be. But let's not invoke that sort of thing. Let's launch this next week.
I agree. The Mondo family is asking, will we have good communication with the capsule when it's on the other side of the moon? Max, unfortunately, the moon is not exactly the best thing to try and transmit radio frequencies through, is it?
Unfortunately not. So that is when the crew and the spacecraft will enter a blackout period.
I'm going to interrupt you again because we have an update. The countdown has... I'm saying this slowly because it's rolling across my screen. The countdown has entered a T minus 10 minute hold, semicolon. Rehearsal will extend beyond simulated 9 p.m. launch window open.
Closeout crew
Semicolon.
work continues in White Room. Sorry, you were taking too long. And I was already reading the end of that.
Okay, so that is the update, which isn't really an update because we kind of knew that already. We are going beyond the original time, and they're still working at the launch pad. I mean, tell me something I don't know. Hopefully we get a little bit more of a juicy update on the blog shortly, because usually those ticker updates precede a bigger blog update, but it might take a couple minutes for those to come in there. Okay. Anyways, Max, back to you.
Yeah, so the crew and the spacecraft will enter a brief blackout period just for a few minutes there as they pass behind the dark side of the moon. Well, I should say a few minutes. I'm not sure. I'm not exactly sure how long that's going to be, based on their speed and their trajectory. But when they are behind the moon, there is going to be no data coming back from the spacecraft. There's going to be a complete comms blackout, which is kind of scary. But that's just the nature of traveling to the moon and going behind it, unfortunately. So. Although that might be one of the only times on board where the crew might be able to enjoy some actual peace and quiet and just take in the sights of the moon, even though they are on the dark side. It'll just be the four of them and Integrity and nobody else, and they'll be the farthest humans to have traveled from Earth, I believe, ever.
Yeah, it depends on the exact launch date and the exact trajectory, but there is a good chance they will beat Apollo 13's record by a considerable margin, which is going to be pretty cool.
Can I make one thing here before we proceed with the next thing? Because in the NASA wording, they said simulated 9 p.m. launch window open, right? That's the point. When we were reading this, a lot of people were like, wait, launch window, right? Simulated 9 p.m. launch window open. Like, this is a simulation, folks. It is not the real thing, okay? Just to make sure, like, to reemphasize that it is simulated launch window, not the real one. There you go.
Okay. A couple more questions here. We have Michaela, who's asking, my 5-year-old Cal is watching and wants to know if the wet dress gets loud or is it relatively quiet in comparison to the real lead up to launch. Max, this is a question for you, considering you are sitting there watching this with your Mark 1 eardrums. I suppose listening with your Mark 1 eardrums.
Yes. Well, I mean, I'm currently inside. I can't hear anything that's happening on the outside. But if we're lucky, sometimes we can hear venting and stuff coming from a launch pad if we're not too far away. From here at the press site, we're about 4.5 miles or so from Slick 40, just about too far away to hear anything from there. Same with Slick 41. We're about 4-ish there, and we're about 3.5 from both 39A and 39B. Still a bit. Excuse me, I was still a bit too far to hear any venting or purging or anything until the engines ignite. But if we're at if we're viewing somewhere on the Cape Canaveral Space Force Station side and we're watching a launch from Pad 40, for example, we are just about close enough there to hear venting and purging from the rocket, should the wind and the atmosphere deem it so, because the way the sound travels is heavily dictated by the wind direction, humidity, temperature, a whole bunch of other factors. So it's rather, in terms of an audio experience for wet dress, we do not really we don't really hear anything from the rocket itself. The only things that we do hear are either PA announcements here at the press site for the Kennedy Space Center, or the voices from the many media personnel here and public affairs officers here working very hard in the press office for everybody. So there's not going to be much to hear until all 6 engines for SLS light. So not much to hear tonight, though.
And with that, I've been talking for too long, so we're going to let you listen to someone else's voice. Returning from earlier on is Sawyer Rosenstein, who is in the studio but is in Florida, so he's a little bit closer to the rocket than I am. But nonetheless, I'm going to have a wonderful vocal rest until we have to do this all again in 48 hours. Just joking, hopefully not. Anyways, that's it. I'm very tired. I'm very hungry. I'll see you later, everybody. Thank you for watching. I'll see you soon. Bye-bye.
Go enjoy your barbecue roll, as we were talking earlier.
You're not making it any better, Sawyer.
Well, now you can go eat. I've had my dinner, so it's my turn to take the reins here, and I am Sawyer Rosenstein. So I will resume hosting duties for the Artemis II Wet Dress Rehearsal here with NSF. And let me give a quick recap then for people who might just be joining, especially here at the top of the hour. So they began fueling the Artemis II rocket here, SLS, earlier in the day. They did encounter a couple of hydrogen leaks at the base of the rocket with the tail umbilical service mast that they have down there. They were able to resolve most of those and to get the rocket fully fueled, which it has been now for a few hours. However, that delay in trying to get the leak resolved and get the rocket fully fueled did push their timeline back by a matter of 2 to 3 hours or so. So as a result, the simulated 9 p.m. T0 is now on hold, and they will hopefully let us know when they have a new simulated T0. The last update is that there are still people out at the pad working on the White Room, but again, there are no crew on board. However, the rocket is fully fueled and waiting for this test, of which there will be no engines igniting tonight, but hopefully they will be able to take this into the terminal count and get close to the point where the onboard computers would take over control before ending the test. And if they have time, given that this window will go until about 1 a.m., the original plan was to then recycle back to the T-minus 10-minute hold and then try for a second simulated countdown. So we'll see how far they're able to get tonight. So that is the recap of where we are at. And again, if you have questions, you can tag us at NASASpaceflight or at NSF. We'll continue to try to answer them as much as we can. And again, we'll provide you any updates that we get from NASA as soon as we get them. Let's see here. Let me get into the question queue now. Turbo asking, what are the black squares on the top of the SRBs? Alex, do you want to take that one? Because obviously there's a lot of black squares and lines and checkerboards all over.
Yeah, that is so the black squares on top of the SRBs, that is part of their own way of being able to track with precision sort of like distances and things like that as the rocket goes into flight. And also even while it is on the ground, like as it is sitting right now on the pad, in the last many hours, first of all, it got loaded with cold cryogenics, which means they can measure the shrinkage of the rocket thanks to some of those. And also they can even measure as well the weight difference. Because one of the things that happens is because you're loading the core stage, the SRBs are loaded, right? They come already loaded when they stack the rocket. But this is the first time this SLS core stage and the ICPS are being loaded. That also puts pressure and weight on the structure, right? They can measure those things with these targets, which are, let me see if I can actually pronounce this, photogrammetry targets. So essentially a fancy way of saying we put like little squares and things like that and patterns in such a way we know exactly the distances and things like that. And if you were to actually record those with a camera by sort of doing a bit of backwards mathematics, if you will, right? Like going backwards, if you see it moving in such a way and you already know the differences in distances and locations of these different patterns, because you were the one that installed those, then, and you know also the properties of the camera, the distances and things like that, because you have telemetry from the rocket and things like that, you eventually can figure out things like, you know, where exactly some of these loads were applied and follow things like the trajectory, etc., etc. Like there's a bunch of those things where you can closely see some of these differences in the positions and whatnot of these different pieces of hardware. Fun fact: the Starbase launch towers and the one at 39A for Starship, those also have these patterns. They also do that same thing for the towers. Because you may think this is only just for this rocket and it's an old thing. This is only something that NASA does. SpaceX also does that for their towers, and it's very important for the same reasons. You want to see things like swaying in the wind or things like that, right? Like that sort of thing is very important, and having those targets really helps you doing that.
Yep, it really helps. The cameras like to see things in black and white and have these nice fixed markers on the vehicle to track it, and the teams, of course, that use that to analyze data afterwards are very grateful for it. Let me clear out some of the support here. And by clear out, I mean thank people, because we could not do this without you. Here we are, an independent organization that absolutely loves spaceflight, and our goal is to convey it to the public, share it with all of you, and we can only do it because of your support. So Ron Smith saying, remember to bring your gators in. If you're cold, they're cold. I appreciate that. William Case saying, thanks for the coverage with a $20 super chat. The new lights on the tower look promising. Hopefully we'll get cool slow-mo Saturn V style footage this time for Artemis II that we didn't get for Artemis I. Oh, I hope so. I know our team is going to be at least aiming for the slow-mo that we're able to provide from our press viewing options. So it'll be exciting. And I know, Max, you're going to be out there setting up remote cameras for us out at the launch pad. I'm sure you have some wild camera plans.
I'm doing what I can. We're still waiting on word in terms of where we are going to be allowed to put cameras. I think there's going to be 4 or 5 spots around the pad in general, but there has not been a formal plan sent to send out to media yet. Of course, there was a lot to get through first before we get to that point. But yes, I have a lot of stuff that I want to do, and hopefully I can deliver. But it would be nice to photograph SLS launching in the daytime. I know I'm being completely selfish there. But yes, I have plans, but it's just a matter of how things work out in the next few days, actually, with the last few hours that we have tonight, and those will dictate the timeline going forward, either for the rest of the week or for the next month ahead.
Exactly. And a reminder, in this current launch period, they have the 8th, the 10th, and the 11th remaining in February. If they do not have that, then it would push to no earlier than March 6th for the next attempt. Let's see here. Rosebud saying, let me try that again. If there are advances made to components, why do they continue to test the older versions? That's what they were trying to say earlier. I guess that's an interesting point, because obviously they're using all of the older shuttle technology still with the engines and the boosters, which they'll be upgrading all of them, including to the new Bowl boosters. You've got the ICPS, the interim cryogenic propulsion system for the upper stage, which will eventually be the EUS. Why would they do that? Alex, I'll throw that one to you.
Oh, well, yeah, because this is what they have right now for launching, right? Like, yes, they are developing all of the new advances, like the new RS-25s, the Bowl boosters, right? But those are not in production right now, or at least not fully ready to be put on a rocket. Because I would argue that technically RS-25Es, yes, they are in production. They have already 2 of them ready to go, more or less. But it is one of those things that it's like, well, they're doing this now because this is what they have right now. And this test is not about, testing this version or testing this hardware in particular. It's just that it's the second time that they have an SLS out there on the pad, right? It's the second flight of SLS, and they still need to gather extra. Like, this is the very first time this particular core stage gets loaded with propellants, right? Because they did a green run test with SLS on the first core stage, on that first Artemis mission, before coming to Kennedy Space Center. This core stage has not done that. So this was the very first time they actually loaded propellants in this vehicle. So yes, even though, although technically core stages are new, not old stuff, but yes, while they're using some older stuff, it still matters because you want to do it in this configuration, right? It's just like cars and planes and everything. Yeah, we've done planes and cars and many other things many times, but the first time you make one of these new ones, you want to do trials and test runs and things like that, right? Like, and in the case, for example, of cars, they do crash testing and things like that. Like, we've also seen them blowing up a core stage hydrogen tank on purpose to also do that kind of thing. So it's not just, oh well, it's old, we just put it together and fly it. No, you kind of need to actually go through testing.
And that is why they test these components. And the nice thing about these components is that most of them are at least flight proven. And again, like you said, while they will eventually do the upgraded, I've been corrected. Bolay is the correct pronunciation of it. I was corrected courtesy of a football chant. But anyway, you could see there that the shuttle segments are basically, the different booster segments are broken up into these past flights. And many of these, by the way, are just showing their most recent flights. There are some that don't even fit on this list because it is so extensive. And then even the engines there, again, you see STS-134, 135, and that one engine that had to be swapped around a bit, so you've got the rookie down there. But most of this is that flight-proven hardware, and it's flight-proven for a reason, and it's a good way to get most of the systems down pat while you wait for the upgraded engines, the European upper, or the EUS, the extended upper stage, and so on. John Marquez saying, is it true when you mix hydrogen gas and rocket oxidizer on fire, it will create a bigger boom? Let's not find out.
I mean, or let's, because that's how you ignite the RS-25s.
Yeah, but we don't want it to be bigger. We want it to be controlled.
Fair.
Yeah, that's what I meant.
Fair.
Jeffrey Stewart, thank you for becoming a Red Team member. Echo deal with the clock saying, oh, great, now it's some kind of temporal anomaly, too. If anyone happens to see a blue police box landing nearby, run. I don't. Did you watch Doctor Who or no?
Negative.
Yeah, I did.
Okay, yeah, I know you do, Alex. Rosebud 53. Why did this disappear from the queue? Not sure. It was there. We got to it. It just took a minute to get to it. Let's see. Ada Astra. White Room had a hydrogen leak as well. Always blame hydrogen! ! Blame.
To be fair, not hydrogen, but I will be concerned about nitrogen, right? Because one of the things that they do is the volume around the capsule in between the launch abort system fairing, right? The ogive and the capsule, it is purged with nitrogen. They do have a seal that sort of keeps that away from them. But it was a concern during the shuttle era. If you remember, Sawyer, ahead of STS-1, unfortunately, some people were killed precisely because of high concentrations of nitrogen in some of the volumes of the rocket. And so it is nothing to sneeze at when it comes to people being close to a rocket, to be fair. Sort of going to more the serious side of things. But yeah, we were blaming hydrogen for everything. So I do see the joke about that.
Exactly. Yeah, but there are plenty of dangerous gases, and it is dangerous to be out there, especially with this fully fueled rocket, which is why the closeout teams that are out there are very specially trained to do this. That is why when we talk about Red Team memberships here, of which first let me thank Bob Fillmore for gifting 10 Red Team memberships, we didn't just come up with that name out of nowhere. That is a real thing, is a Red Team. These are people that are willing and trained and ready to go out to a fully fueled rocket and make any changes, adjustments, tweaks, any fixes that they can make out at the pad prior to a launch once you get into these kind of more dangerous conditions. We actually saw the Red Team roll out on the Artemis I third launch attempt, the one that actually ended up launching, to go out and work on something out at the pad. So that is, we talk about the Red Team memberships, that's because it's based off of the real people that risk their lives and go out there. And then Everlast saying, love all your coverage, been watching for a few years. Thank you for all you do, first time donor. Well, thank you. And again, you don't have to donate to support us. Watching is a huge help. So thank you everyone who's here and for being here and hitting the like button and subscribing. All of that lets other people know that this is fun. And hopefully we're all having fun here too. Let's see. Here is an interesting question. And Max, I'll throw this to you. Luke is saying, why does a wet dress rehearsal need to have a window?
So essentially, they are simulating as much of the launch as they possibly can without actually launching the vehicle. And in that case, it helps to have a targeted window of operations to, of course, be operating in. But also, if you are launching, especially in the case of Artemis II and going to the moon, you will have a launch window. And even though the launch window tonight is a bit longer than what I guess is available for a lot of the windows, it is still a lifelike scenario in that your launch window could be a matter of hours. So being able to also be able to bring your vehicle down to a point in the countdown as close as you possibly can before terminal count, before being able to recycle and go through that process over and over and over again to make sure that not only your personnel, ground and vehicle systems can handle it, but that's literally as much of you are performing as much. How can I say this? Brain is not braining. It is essentially as much of a simulation as you can possibly get without launching the rocket in the most realistic scenario possible. So that is why you have a window. And tonight, even though the window was about 4 operating hours from 9 p.m. local time here on the east coast of Florida to 1 a.m. technically tomorrow, they have already been behind in the countdown for a number of hours due to having to stop and restart hydrogen loading on both the core stage and the ICPS. So that is where having a window to work with there maybe helped a little bit, because if the window was instantaneous, for example, they would have called this off hours ago. So those are some of the benefits of having a window to operate in that this is how launch day can actually go, and of course that's what you want to simulate.
Right, and the fact that they are doubling the normal window that they will have for launch. The launch window itself is 2 hours. Given that they are doing a test here, they're actually extending that to 4 hours. So that's part of it, is giving themselves that extra wiggle room in the event that, say, I don't know, you have 2 hydrogen leaks from the tail service mast umbilical down at the base of the rocket. Theoretical, of course, hydrogen. But, it's getting that extra margin in there. And plus, all these people are on the clock the whole time, too. They also want to go home after this test. So all of that has to be taken into account, and they need the time to then go over the data they acquired and see, are we still okay to launch on February 8th? Do we need to push to the 10th or 11th or to March? Let's see. Amanda, I believe that's Amanda, asking, are the rocket parts tested, Alex, for quality and structural integrity? How were they tested? Because we didn't have a green run this time, which is what they did for Artemis I, where they basically tested the core stage over at another NASA facility.
Yeah, there are definitely multiple different kinds of tests that they have done, and not just even the structural integrity, but also the all of the other properties like leak checks and things like that, right? Like checking for leaks is not really something that is related to the structure, just that it actually holds integrity and that there's no, well, oh my god, the many puns that you can do with that phrase right now.
Don't tease me.
Well, I was saying, of course, it holds integrity. It's up there on the top of the rocket.
Yes, the capsule is named Integrity for those who don't know.
But yeah, it's just that you're trying to find leaks and things like that. But yeah, they do those sorts of things in the development phase of the rocket. So as you were mentioning, and as we were talking before, there was one time where they on purpose blew up an entire SLS core stage hydrogen tank, the big orange part, sort of the bottom half of the rocket, essentially. That's where they blew up, sort of pressurizing it and making sure that, like, okay, when does it blow up and things like that. I think it was like 300% of the margins. That's when it blew up. I cannot remember the exact number. But yeah, they do those sorts of tests. They have even earlier in development, they have things like weld confidence tests and things like that, where they sort of try to see if even the welding itself is correct and things like that, with just test pieces of the rocket. Like they go to that extent early on. Around this time of the flight and development and whatnot, you would not see that kind of testing. But yeah, there's usually structural test articles and things like that for that purpose. Fun fact, right now they're doing that with the exploration upper stage for SLS Block 1B, right? There's also a structural test article that is being put together right now for whenever that is complete. Then it'll go to standings for testing. But yeah.
Exactly. And also, for those wondering why it's called the ICPS, the Interim Cryogenic Propulsion Stage.
That is the reason why.
Yep, because there will be a new design once they get to Block 1B. Again, Block 1B has not launched yet, and we're still not expecting that for a couple of years. In fact, the mobile launcher that will be needed to launch Block 1B is still under construction. So right now, everything, though, for SLS Block 1, which is what you see on your screen, of course, continuing as planned here, minus the hold in the count. And I've seen some people asking, with the hold, why hold now? They've been counting down this whole time. Why is it all of a sudden at 10 minutes that we stop the hold? That's because of the way that the countdown works. Once you hit under T-minus 10 minutes in the count, that is when the ground launch sequencer begins the terminal count. So there is basically a set of computers that will take control of that portion of the count. The people in mission control are the launch control center, are still monitoring. and keeping track of everything and can stop things if needed. But basically, at that point, it is a set of sequences that are executed at different time commands, and that starts at the T-minus 10-minute mark. So that's when we see them start to retract the crew access arm after that, pressurize the tanks to flight levels, stop topping off all of the propellant tanks, everything needed, arming the flight termination system, getting the auxiliary power unit started. All of that happens in just that 10-minute window. And the test tonight, the plan was to take it down to right before the auto sequence start were to begin. That begins at T-minus 33 seconds. So the plan was to stop right before the automated launch sequencer takes control. Waiting, of course, to see when that targeted, simulated T0 will be, knowing that they are scheduled to stop the test 33 seconds before that actual T0. While we're talking about the different stages here on Orion, as a shuttle fan myself, Ginkgo obviously understanding that too, asking, why is it orange? Shuttle derived, question mark? And yes, the spray-on foam insulation, Sophie, is very shuttle derived, right, Max?
Very much so. We have also seen it on other vehicles as well, i.e. Delta 4. And also H2 and H3 also over in Japan as well. But yes, it is one of the most efficient ways to insulate both the LOX and the hydrogen tanks on both the ET on the space shuttle or the external tank, and of course the core stage that we are currently seeing on the SLS Block 1 vehicle. It is not a perfect insulation, and that is why we are currently seeing some condensation on the outside of both the LOX and LH2 tanks. But it is one of the best solutions they have in terms of performance and also weight, because on rockets, weight is quite literally everything. It's not perfect because obviously you still have some temperature rising and boil off of both propellants, but it is about as good as they can get for the application that they need. Because of its actual, I almost said recipe, but because of its actual chemical composition, if it is out in the sun for a while, it will actually, I guess, quote unquote, tan and actually turn a darker orange over time. And we can actually primarily see that on the LVSA, or the Launch Vehicle Stage Adapter, which is that conical shaped orange piece coming from the top of the LOX tank there, which is where that venting is, towards the bottom of the ICPS, or the beginning of where that white is on the vehicle, towards the top. That will actually darken pretty rapidly over a period of just weeks of being out in the sun, which of course to this point it has been. And it is noticeably darker than when it rolled out, but that is just the nature of the spray-on foam insulation on these vehicles. So very cool to see, and also kind of retro to see an orange and white vehicle out at one of the launch pads here at the Kennedy Space Center, because of course that is how the space shuttle looked from STS-3 towards STS-135. And the reason why 1 and 2 did not look like that is because those were the only two missions where the ET, or the external tank, was painted white. And of course they stopped doing that because it just weighs too much. And again, on rockets, weight is just about everything.
Yeah, taking part of it also, aerodynamics and heating issues a concern, and also who's going to like the orange color. And now it's iconic. It has been iconic now for about 40 years or so. And it's even, again, like you said, still being used. The early Vulcan rockets as well, those cool swooshes and paint techniques that you saw for Vulcan on ULA was also Sophie that they had painted. So about that whole painting thing. Let's see. Grebo with an interesting question, and this has got Alex written all over it. What is a green run, and compared to a static fire, and is that just a NASA-ism, or could Starship do a green run?
I mean, in a way, Starship has done a pseudo green run with ships, or the later version 2 ships over at Massey's on the static fire stand, when they're firing for about a 60-second duration over there with all 6 engines. That is the closest they really get to a quote unquote green run. But in terms of what this means for the SLS core stage, a green run is a full duration firing, which is about 8.5 minutes in duration. We first saw that with the Artemis I core stage a few years ago at Stennis when they fired all 4 engines for about that period of time. And I think it actually took them 2 attempts to reach full duration. I believe on the first attempt they shut down a bit early, which called for the second run. But a static fire, for example, say on like a super heavy booster or on like a Starship or ship, for example, those can last anywhere from 5 to 10 seconds, sometimes upwards of 30. It depends on where they are at. But usually a static fire implies that the actual ignition will take place over a short period of time, and a green run is more in the case of an MDC or a mission duty cycle or a long-term firing, which of course we saw with Artemis I's core stage many years ago. So I guess that's kind of a long-winded answer of explaining the differences between a static fire and a green run. But we have actually not seen a green run on the core stage. We are currently seeing on camera now, which was one of the biggest question marks, in that this core stage up to this point had not been filled with either LOX or LH2 in any regard. Which is why there was a cause of concern whether the TSM or the tail service mass would behave themselves in terms of the way they were mated to the bottom there, and also just in terms of their internal plumbing as well. Just a whole bunch of factors, but all things considered, it really has not performed awfully tonight. It really hasn't. The fact that they were able to get the vehicle fully topped off on the first attempt, despite having to stop and restart a couple of times, I would say is definitely a win, especially in comparison to the Artemis I campaign.
I mean, they were able to get through the leaks so far tonight, of which they have had a few, as we pointed out. So as a result, that pushed their timeline back a couple of hours. And as of right now, NASA remains in a T-minus 10-minute hold. They were aiming for a simulated T0 of 9 p.m., but have yet to set a new T0 and have not given us an update in the last 40 minutes.
Can I add one thing as well to the green run conversation? Is that the green run was actually more than just the hot firing, because that was the last of the tests. The core stage stayed out there. I think it was like a 6 to 7 month stay. Might have been. It also happened during COVID, so there was a bit of a lull there as they were trying to figure out how to do the operations while still keeping safe and whatnot. But I have here in front of me actually the list of all of the different tests, like apply forces simulated launch to the empowered suspended core stage, turn on and check out core stage avionics, simulate potential issues to test systems that shut down other systems if there's a problem, test main propulsion system components that connect to the engines, thrust vector controls and check out all the related hydraulic systems, simulate launch countdown to validate timeline and sequences of events, then load and drain more than 700,000 gallons of cryogenic propellants, and the final one, fire all of the RS-25 engines for up to 8 minutes. So like, it was a step-by-step approach to get to the point of actually firing the engines. Like, they didn't put the stage there at Stennis and just fire it up, right? Like, they built up to that point. And in fact, we had a first hot firing that was aborted due to a red line sensor, if I'm not mistaken. That was the cause of that abort, sort of like 1 minute into the burn. Then they reset everything essentially, and then they were able to retest those engines for the full 8 minute duration. But like, the reason why it is different, it is not just NASAism, if you will. That was the expression used in the question. It is also that, you know, it's a different thing than just putting it out there, fuel it up, and static fire the engines, right? It's there were more things that were done building up to that.
And chat went wild when you gave your timeline estimation there of how many weeks. I won't say anything further. But what I will say further at the moment then is, at least we're talking about all these holds and everything. Of course, this is just for the test for tonight. In regards to their plan is to hold at T-minus 10 minutes, take it down, like I was saying earlier, to that T-minus 33 second mark. which is right before the automated launch sequence would begin. But if it comes launch day, Alex, and they get to a similar situation, what is kind of the timeline of when and how long and where they would hold?
Yeah, so actually for today's test, so this is like with a big if, they may try this today. It is not something that they need to do, but they want to do one thing, which is, the first time they sort of release the clock, right? Release the hold, not release the clock. Release the hold, restart the clock, right? We are currently at T-minus 10 minutes and holding in the countdown. So if once they lift that hold, they want to go until T-minus 1 minute and 30 seconds and holding. So they're going to hold at T-minus 1 minute and 30 seconds for 3 minutes, and then they're going to come out of that hold and continue all the way to T-minus 30 seconds. Now at T-minus 30 seconds, that'll be a hold, right? Actually, for the first run, it's T-minus 33. So T-minus 33 seconds, they're going to be holding and then recycling back to T-minus 10 minutes and then doing again the whole run through the terminal count. Again, this is like a possible thing they may try. It was one of the things that they wanted to try for Artemis 1 with today's issues and whatnot with the fueling. We don't know if they're going to be trying it again. We don't even know if certain systems, for example, are up to what they need to be in order to get that far down. Because we have little to no information other than, we top off the rocket and whatnot, but we don't get some of the other information. They want to try to actually test this possibility where you are on a launch day, right? You're trying to go through terminal count, and now you have a hold. Well, if it's between T-minus 10 and T-minus 6 minutes, then you can hold at that point. Like say it's like T-minus 7 minutes. Then you can hold there pretty much unlimited for as long as the window runs, right? If you go past T-minus 6 minutes, as you can see here in this graphic that Ryan made, then you only have 3 minutes of holding potential. So if you do anything in that period of time and you hold there, then you only have 3 minutes. If you hold between T-minus 1 minute and 30 seconds and T-minus 33 seconds, you have to recycle back to T-minus 10 minutes in the count. And if you hold after T-minus 33 seconds, then it's an S word for the day. It's conveniently sort of censored, if you will, because it's only SCR asterisk B. But you can imagine what it means. We will not say it today. We will not invoke that. But yeah, so they're going to be trying and test that as if you were actually needing to do that sort of thing. In reality, it's very unlikely. During Artemis 1, thankfully, we didn't have any holds during terminal count. But there are a lot of things that happen during terminal count. If we get to that today, we'll probably highlight some of the major things that are going to be happening, right? But there are a lot of things related to systems and hardware. And it's very important to be able to not just go through the terminal count, but also once you stop, go back to a previous state, right? Because when you recycle, you have to go back to the previous state and undo a lot of those things that you have to do during terminal count. So it's not easy.
Exactly. And again, NASA holding at the T-minus 10 minute mark. The reason holding at T-minus 10 is because at T-minus 9 minutes and 59 seconds is when the ground launch sequencer would take control of the count. And that would go all the way until the T-minus 33 second mark, which is when the automated launch sequencer takes control of the countdown. And you can kind of see the delineation there of, GLS versus ALS, so to speak. So apparently Das has been working on something all day. For those who don't know, he is one of the heads here at NSF. He's a great streamer, great person, and apparently has some fun gadgets in his house and garage. Chat, would you take a look at this? Oh my gosh. Chat, would you want one of these? Apparently Das is working on this in his home, and if there's enough demand, maybe, just maybe, it could go into the shop. Oh my gosh, that is awesome. Although, if we did, it might take a minute to get into the shop because it would be delayed from hydrogen. Always hydrogen. Blame hydrogen. And if you, like us, are so annoyed at what hydrogen has done delaying this again and again and again, you can at least get some merch from it at shop.nasaspaceflight.com. This is very limited edition just because of the hydrogen fun that we've had here on the Static Fire. It's limited edition merch where you too can blame hydrogen for all of these delays. If you're planning on coming to the launch and you're not sure if it's going to launch, grab one of these because you never know. Again, you got shirts, you got sweatshirts, you got mugs, all the different options there at shop.nasaspaceflight.com. And of course, if you want to just represent the Artemis II mission itself, we have that, including our brand new vintage design that just released today. You can also see it there on the t-shirt. You've got the little crew at the bottom there of SLS. You've got the path to and from the moon, which is both the flight path and an A and a 2. So it's awesome. And there you go. And it's all available at shop.nasaspaceflight.com. And check out the entire Artemis II merch page, including the assembly shirts. We also have the traditional SLS worm merch that we did from Artemis I. And of course, prints, posters, and other items you can hang up in your house from all of our amazing photography team. Shop.nasaspaceflight.com. Hey, there's a bunch of SLS ones too. I believe those are from Jerry Pike and myself. Max, we got to get more of yours up there too.
Well, I wasn't there for rollout, unfortunately, so I otherwise I would have some up there, but hoping that the time to shine with that will either be at some other photo op before launch or launch itself.
Absolutely. You know what? The reason you weren't there, we'll blame hydrogen.
Sure.
Like the person in chat who said, "Poor Mrs. Das." That is so perfect. Anyway, let me also take a moment, thank some people here. Heather, thank you for becoming a Pad Rat member. Josh saying Starship is famous for being made of stainless steel. What are SLS tanks made of? What are the tanks made up of on SLS? Alex,
Aluminum lithium. Aluminum lithium. Very similar alloy, in fact. Not the same, but very similar alloy that the one that is used on Falcon 9. So yeah, I mean, in fact, even the procedures, it's friction stir welding, also like Falcon 9. So yeah, the most flown rocket these days also uses very similar technologies as the SLS rocket. The SRBs, so this we're talking here about the core stage and the upper stage, the ICPS. Those are aluminum. The SRB casings, in that case, that's steel. So there's still steel.
There's steel there in the.
There's still.
Oh my god.
We're in a hold, folks. That's why having a little fun with it as well. But yeah, you could see there the different tanks and where they're located inside the core stage. And you see the liquid oxygen, the liquid hydrogen, and then the solid ammonium perchlorate composite that is used in the SRBs there. So that is the makeup there. And in fact, I believe we have a video somewhere on the NSF channel where we got a tour of one of the facilities where they actually make the core stages and the boosters. Philip Sloss, who was on earlier, took that tour at Michoud, yes, which is down near New Orleans. Definitely can check that out here on the channel and find some other fun videos. But in terms
New
of
Orleans
size,
or New Orleans?
Knowledge is the correct way. And no, do not be afraid. Shuttle is not on fire. It is just that metal. It is just that awesome that Shuttle has the flames coming out. But yes, just for comparison of sizes here, SLS is quite massive. And this is Block 1. Look at that compared to the original Mercury Redstone all the way up. Saturn V still giving it a run for its money height-wise. But Block 1B, excuse me, will have that taken care of. And it's quite the comparison to Space Shuttle. At only 56 meters there, poor Shuttle. But if we want to compare it to some of the other rockets of the world here, including Block 1B, you could see Block 1B definitely getting a little bit larger there. My favorite is tiny little Electron, the small sat launcher, at 18 meters, just barely on the screen. It's so tiny.
That's like what, 2 segments of the SRVs? It's barely above the tail service mass on the mobile launcher.
If that, yeah. The tail service mast, I think, is bigger than Electron. And yeah, New Glenn 7x2, the current variation, and SLS about the same size. And then, oh yeah, their Starship, which is off the screen because it's
Yeah.
that large.
Whenever Blue Origin gets the 9x4 flying, that's gonna be cool because it's also gonna be pretty much like Starship on the right.
Exactly. And talking about the lunar program going forward, we were mentioning this earlier about the Gateway and things like that. In terms of vehicles that will help get crew and vehicles and segments of Gateway out towards the moon, we got Falcon Heavy there, of course, New Glenn, and then Block 1B, and the HLS Starship, which also, of course, goes off the screen. And a reminder, Starship is the lunar lander for Artemis 3 and 4.
And if you're wondering where the lunar lander from Blue Origin, it's inside New Glenn.
There you go.
See what I did there?
Yeah, and that will be used for Artemis 5 at the, I guess at the latest, we'll say now, because the whole debacle with that.
It could be used maybe earlier than that. We'll see.
Exactly. But there's so many people that compare SLS to NASA, and it's like, oh, well, one's going to beat the other, and people, I don't think, realize the fact that they are intertwined. NASA and Starship are very intertwined as they will be launching the lander for Artemis 3, the first return of humans to the moon since the 1970s, to the lunar surface, I should say, since the 1970s. That is a SpaceX Starship vehicle, a special human landing services HLS variant of it. The crew will rendezvous and dock with it aboard the Orion capsule on SLS. So as much as people say, oh, it's a fight between both of them, it is actually a marriage made in, well, I guess, low Earth orbit and eventually lunar orbit. Let's see here. Here's a good one from KSP Kid saying, why does NASA test rockets more than SpaceX? While we're talking about NASA and SpaceX, I'll throw this one to you, Max. Why a full 8 minutes for a green run as opposed to a more shorter fire?
I mean, I wouldn't say NASA tests their rockets more than SpaceX does. They just go about testing differently. Like with Falcon 9, for example, they only do one cryo run and one static fire of Falcon 9 boosters before they are shipped out, assuming all goes well in both tests, whether it be to Vandenberg or to the Space Coast of Florida here. With Starship, they go through a few pressure tests at Massey's, followed by cryo testing, and then, of course, they do their own static fires there as well. It's just that testing is very different, and kind of like what we were talking about a few minutes ago between the differences between a green run and a static fire. SpaceX doesn't really have the infrastructure to support a multi-minute static fire of a super heavy booster because it produces so much thrust that honestly it would shear the actual hold down pins off of the launch mount. At least that was the case for the original orbital launch mount. Not sure that's so much the case for Pad 2, but it's not good for it either way, holding down that much thrust for that period of time. The stand-in Stennis that held the core stage is a bit different because it's engineered to hold it in place, whereas the launch mount is just designed to hold the rocket fully fueled, and then just for a couple of seconds before the vehicle departs. So, and with the ship, they are able to support up to a 60-second static fire over at Massey's with all 6 engines running on the ship. But that's about it before they either run out of water for the deluge system or propellant on board the ship itself. So, They just do what they have to do, and NASA obviously takes a lot more cautious route and long-term route for their launch vehicles because they aren't launching every 2 to 4 days or even 2 to 4 months in this case with SLS, and that certainly wasn't the case with Shuttle for most of its life. It's just they have a lot of different philosophies between building their rockets and testing their rockets and also flying their rockets, and their rockets also serve much different purposes. Falcon 9 has been a workhorse to get to low Earth orbit, but also has the capability of reaching beyond low Earth orbit, whether it be to the moon, geosynchronous, geostationary, sun synchronous, sometimes polar. Falcon 9 can do it all. SLS is specifically designed to go to the moon with a number of contracted suppliers for a number of its components, so there is a lot more room for error there, with there being that many contractors supplying one launch vehicle, where SpaceX does everything in-house. There's a whole bunch of variables there. So I think that's really as brief of an explanation as I can really put it. Just, but what? What are you laughing at?
I was like thinking about Alex's answers. Sorry.
Oh
When you
God, we'd be
mentioned
here all
briefly.
night with that question.
Oh, I have something to say about that question. Don't worry.
Oh, do you? Go for it.
Continue.
The floor is yours.
Well, I was gonna say finish your thoughts. But boy, when I saw that I feel like the statement that NASA tests rockets more than SpaceX is just a feeling rather than actuality, like something that is really a thing. Mostly because if you go to McGregor Live, you will see that SpaceX tests rockets a lot. Pretty much every day or two, we have a Falcon 9 second stage being tested, full run of the stage. Back in the day, they actually fired them for the entirety of the firing that they were that the stage will see for like the 6 or 7 minutes that it will. And yes, I said the thing. Uh, but yeah, and so um, I don't know, like it feels to me that that's just more like a vibe, as they say nowadays, right? Rather than an actual thing, because remember this core stage, as I just said before, it has not done a green run, right? This is the very first time they have actually done a fueling on this core stage, and so if this were to be, for example, say this were to be SpaceX, you will have seen, for example, some kind of other testing before with this core stage where they will have loaded it with liquid nitrogen, for example, in what is called a cryogenic proof test. They will have probably simulated the force of the RS-25s underneath of the rocket and things like that with a thrust simulator stand. Like, there are so many things that they do sometimes, SpaceX themselves, to the rockets to test them ahead of launch in comparison with what you see here, that it is pretty much just a vibe rather than a real thing that, somehow NASA tests more than SpaceX. If anything, I would say SpaceX tests a lot more. And the philosophy is that the way that NASA does it is they do a lot of the design and development very early on. They take a long time with that, right? So that they only test the first couple of times thoroughly. And then after that, you don't really need to do that all the time. Just like, for example, Atlas V doesn't need to do a wet dress rehearsal on every single flight. They don't do a static fire of the engines every single time. They don't do that sort of thing. If you look at out there to other traditional ways of developing rockets and whatnot, that is the case. They don't test as many times as you see, for example, with Starship, with Falcon 9. Falcon 9 boosters also get a full duration firing at McGregor before their first flight. So that's why I was like, I feel like I really need to debunk this sort of myth that I just saw there in that comment. But yeah, no problem to be honest, because that gave me a way of sort of comparing the different ways of testing different rockets.
Fair enough. And one thing that we can't blame hydrogen for is the fact that they have fixed the countdown clock at the press site. The zeros are now in the correct spot at the correct size, as originally designed, and as they've been using it for the last 12 years that this clock has been out there. And the word hour is now once again legible. So that is the first major update that we have had in an hour here from anything related to this mission. And in fact, the second I say that, we get an actual update from NASA on their Artemis II blog, just this very second, of which they say closeout work in the White Room continues. The Artemis II wet dress rehearsal entered the T-minus 10-minute hold in the simulated countdown at 8:50 p.m. Eastern Standard Time. Though it had been counting down to the opening of a simulated launch window at 9 p.m. Eastern Time Monday, February 2nd, the test will proceed as teams continue to work through countdown milestones. The closeout crew remains in the White Room and has closed the Orion spacecraft's crew module hatch, while performing seal pressurization checks on the counterbalance assembly, which could be used to help open the hatch. A valve associated with Orion's hatch pressurization was inadvertently vented. The counterbalance assembly then needed to be repressurized to allow work to continue. Approximately an hour of work remains in the White Room, with the launch abort system hatch remaining to be closed. That is not the update we wanted to hear.
Youch.
Boy.
Yeah, that's
Yeah.
not good.
And it was the exact 1 hour mark of when they gave us the last update. Yeah, blame hydrogen. There you go. You see
That's
it.
it.
Blame hydrogen. But that is that's quite rough. So first off, well, let's break this down a little bit here. The performance seal pressurization checks on the counterbalance assembly, which could be used to help open the hatch. A valve associated with Orion's hatch pressurization was inadvertently vented. Alex, can you kind of break down what that area actually does? How that works with the hatch pressurization?
Yeah, that's the tooling that they use in order to be able to go and bridge the gap in between where you have the so you have the launch abort system, right? The fairing outside the hatch, and you open it, and now you have an empty space in between that fairing on the launch abort system and the capsule itself. So this is sort of the counterbalance assembly, is that sort of assembly that they use in order to be able to traverse that little gap. And so it seems like what happened is that a valve associated with Orion's hatch pressurization was inadvertently vented, so they had to repressurize that area to be able to work, to allow work to continue. So they had an issue. I guess, can you blame Orion now? Now you have to blame Orion. I would say though, if they say approximately an hour of work remains in the White Room, we are not close at all to resuming the count, because the time when they are supposed to get out of the White Room, I think, hang on, so they depart the 39B area at L minus 45 minutes. So say probably 2 hours from now, that will be the simulated T0, essentially. So what, midnight already?
About, and again, a reminder, they were planning to do 2 tests if they could tonight, where they would take it down to the 33-second mark, hold, recycle to the T-minus 10-minute mark again, and then try and take it down one more time before then recycling a second time and ending the test. And it was supposed to be that when the closeout crew departs, the original timeline and what they will do on launch day is when the original 30-minute hold was set to begin at the L minus 40-minute mark, whereas the T minus 10-minute hold there. So just take that into consideration. And the other part of that people might not fully kind of get, because we're so used to, Dragon, where you can see the windows in the capsule. And you can get the whole idea of, like, even Shuttle, you could see out the windows and stuff. Max, when they talk about the second hatch that needs to be closed, what do they mean by that? Because I don't think people realize there is another hatch, not just the crew capsule hatch.
Yeah. Yeah, so Orion itself does have windows. I think both Reed Wiseman, who's the commander, and Victor Glover, who's the pilot, can look directly out the windows. The problem is, at liftoff, and at least for the first few minutes, those windows are blocked by that white ogive fairing, or the aero cover there, which is what is mated to the launch escape system. And the purpose of these fairings and covers is that in the event of the launch escape system being needed and pulling Orion away from the rest of the rocket, that is what attaches to the Orion spacecraft to pull it away. And so after a while, once they are past the point of that being needed, the launch escape system will be activated, but it will decouple from Orion and pull itself away from the stack. So in essence, those windows are covered by this white aero cover, or ogive fairings, or whatever they're actually called officially. I have no idea. But yeah, they have no view outside until those are gone, and when those are gone, when that is pulled away or jettisoned, they are already well above Earth's atmosphere and into the blackness of, in essence, at that point, space. So yeah, views off the ground are non-existent for Orion, unfortunately.
Yeah, it's, again, not the best for the crew view-wise, but you'd rather have things work aerodynamically, and in the event something goes wrong, be able to use the launch abort system, that little pointy bit at the top of the rocket. So, you give and take there. Also, the fact that they'll be flying around the moon just a couple days after launch. Let me thank some people here. Scott coming in with a $20 tip at tips.nasaspaceflight.com, saying you reported the last Falcon 9 second stage had a failure. That means Crew 12 cannot launch even if Artemis II does not launch this month, correct? And I think it's important to note, first off, in case you didn't hear earlier, SpaceX noted that on their most recent Starlink launch out of Vandenberg Space Force Base in California, the second stage experienced what they called an off-nominal condition during preparation for deorbit. It seems like right now all of the Falcon 9 launches are on hold. That would include Crew 12, right, Alex?
Yeah, that would be the case. The last time something like this happened, where sort of the orbit burn did not work, or like it wasn't completed, and the second stage was not able to do that. It is true that they were able to resume launches rather quickly, right? Like they understood the issue rather quickly. We don't know. I'm gonna say this: we don't know how long this will take, right? I will even argue that it's very premature to say that this will impact Crew 12, given that Crew 12 is still like a good more than a week away, right? And for all that we know, they could, in theory, resolve this well ahead of that. So, but I do consider at the very least potentially impacted. That's potentially, see that word that works for me. Potential impact, yes. I will say straight away that saying, oh, it's going to be impacted, maybe not, right? We don't know the nature of the failure. We have very little information from them, right? We have no idea how long it's going to take. But I will say potentially, probably, maybe, yes.
And when we talk about, and when we talk about Crew 12, by the way, you could see there is the post from SpaceX about the anomaly that happened. Crew 12 is different from Artemis. Artemis II will be sending the 4 humans around the moon. Crew 12 is the next crew resupply, or the next crew exchange, I should say, up at the International Space Station. Crew 11 came home early due to a medical issue on board the ISS, so they tried to move up the Crew 12 launch as much as possible, also to not conflict with Artemis. So that will send 4 people for an approximately 6-month stay aboard the International Space Station on a Falcon 9 from Space Launch Complex 40 at the Cape Canaveral Space Force Station. And that could be as early as, prior to today's events, February 11th. But that was assuming that NASA does not have any attempts to launch SLS during the February launch window, which would end on the 11th. If they do try and go within this window and they don't actually launch, they could go as soon as the 13th of February. And if they manage to get SLS off during this launch window, that means that Crew 12 would launch no earlier than the 19th of February per a NASA press conference a little less than a week ago. Guthmang asking, what's the chance of my tickets I got for this Sunday's launch being a go? Again, it's still too early to say. Obviously, they're dealing with these issues during the count, but you'd rather deal with them during the wet dress rehearsal than the actual launch itself. I think a lot of it is going to come down to analyzing data. But Max, what's your vibe on that, at least? Not official results, but what are your thoughts?
I'm on board with you, Sawyer. I think it is too early to tell at this time. I mean, unfortunately, I don't think we're going to have any real better idea until midnight or 1 o'clock or tomorrow morning. Technically, still tonight in my mind. It has been a very eventful and bit of a roller coaster countdown so far. So the overall vibe right now is not the most confidence inspiring, but again, we don't know. And we have to emphasize that a lot. But we actually went over in the previous stream, I believe it was the cancellation or refund policy for the Feel the Heat tickets for the Saturn V viewing opportunity for those who managed to get tickets for it, because those sold out in less than an hour, which is remarkable. I think if they end up postponing the launch more than 3 days out in advance, I believe your ticket will carry over to whenever the next launch opportunity will be. I could have read that wrong or heard that wrong from Ryan. Please, I implore you to go to the Visitor Complex's website and read the actual policy for yourself. I implore you to please do that. But if they move the launch far enough out, they should honor your ticket at a later launch opportunity. But hopefully, we should hopefully hear about that sooner rather than later. That is, I guess, currently what we are all hoping for, and not to have this whole thing drawn out for a while. But yes, the current vibe is hesitant and cautious. I think those are the two words that I can best describe it. Not the most confidence inspiring, but again, we still have just under 3 hours left to work before they have to call off the test for the night. So still time on the board, even though there are still operations out there to conduct, with the closeout team still in the white room with about maybe 50 minutes of work left to go or so at least. But we will have to wait and find out.
That is true. And in the past, I believe it's the case for this one as well, they're usually valid for 2 launch attempts.
Yes.
When that attempt actually begins is, again, read through all of the ticketing information if you did receive it from the Kennedy Space Center Visitor Complex, which is different from NASA, by the way. They are not the same. One is NASA, the federal government. The other is a company called Delaware North. But read through all of the documentation in there, but it's usually good for 2 attempts. Kenneth Cannon saying, blame hydrogen space shuttle version, please. Well, this is a limited run, by the way, of the blame hydrogen merch right now. So we'll see. Hopefully we don't need the merch again, because hopefully that doesn't happen again on any future tests or launch attempts, but we'll see. Stacy Mill, thank you for the support, saying, supporting you from Honduras. You all rock. Much appreciated.
Hey.
And Taylor DeCastro saying, just flew past the pad on a flight from Charlotte to Miami. She is a beautiful
that is so
ship.
cool.
She was a beautiful ship and bathes in light. Go SLS.
Awesome.
Yeah. That's one of those things where just getting to see a rocket from the air doesn't even have to be launching. Just if you happen to fly anywhere near Florida and you can get a window seat that faces the Cape Canaveral side of things, it is such a cool view. Let's get back to more questions here. Here's one from Joshua asking, how old is Artemis II? So I guess this particular set of hardware, Alex, excuse me, not hold. They're in a hold. How old? Can you tell we've been holding for a while? How old is this hardware?
Well, we were sort of mentioning before, right? Some of the heritage flying in this mission. Some of the SRBs, some of the parts of the solar rocket boosters, they go back all the way to like STS-5. That's how early in the shuttle era some of these pieces of hardware were flown. Now, ironically, the newest thing on this thing is both the actual sort of iconic part of the vehicle, which is the core stage, and the ICPS, like the orange thing and the thing that sends these astronauts up into orbit, right? The engines on the core stage, of course, they are not new. One of them, it is technically, it's old, but it hasn't flown before. Let's put it that way, right? It's like 10 years or so old, if I'm not mistaken, from what Philip said earlier in the stream. But yeah, so like the orange core stage, for example, it is new, even though we reminisce and we talk about the shuttle, and the shuttle external tank was orange as well. Don't let the color fool you. It is not the same thing. but yeah, some parts.
You know what else is old?
Oh, what is old?
The
Kevin?
moon?
The moon is old.
Yeah, 4.5 billion or something like that.
Like, it took you forever to acknowledge the moon. That's where we're going.
I know
Kevin,
we're going to
Kevin,
the moon.
Are we
It's
going?
Alex's answer.
We're going. Like, I'm gonna sneak on and like hide in like some cabinet somewhere.
You said it wrong. It's not we're going. It's we are going. That's the official
are.
NASA slogan. We are going.
Oh, I'm sorry.
Unfortunately, we're not going anywhere around there. You have to tilt that a little bit down.
No, it's
Actually, not further down, more to the left. I forgot. This is Florida.
It's coming. It's coming. It will be there soon. There we go. Do eyes move the telescope.
Yeah, the moon is on its side. For me, it's a little bit rotated.
But yeah, there is this the area of which NASA is hoping to land on the Artemis III mission. That's where all of the landers that have been going uncrewed so far have been focused. Is the southern pole of the moon. The hopes of finding usable water ice in some of those dark areas that have been cold and frozen for a while, and a place to eventually set up a permanent human presence on the surface of the moon. And that all begins with Artemis. Absolutely beautiful. And the crowd chanted, "Moon, moon, moon." Also, can I just say that someone, when you said, "You know what's old?" someone said Kevin Michael Reed.
I wasn't going to say it because I was trying to be nice, but I was severely tempted to just be an absolute meanie there. But, Sawyer went there first.
Excuse me? I had to come back for that. What?
That was a comment from chat, sir.
Wow. Chat, I thought you loved me.
Love you, Kevin.
Love you too, Max. I'm going away. Bye.
Kevin Michael Reed, everybody. We jokingly call him the voice of God here. He's one of the producers at NSF, him along with Jay Keegan helping to produce the stream tonight for all of you throughout this wet dress rehearsal. And again, for those just joining and wondering what is actually going on here, they are in a hold right now at the T-minus 10-minute mark. They encountered some issues earlier in the count with hydrogen leaking, ! Blame for hydrogen there. They've had 2 different leaks, which set them behind. The pad closeout team went to the pad to work on closing up the hatches on Orion and on that outer fairing. And while doing so, according to their most recent update, at about 9:50 p.m. Eastern Time, they accidentally opened a valve or vented a valve in Orion's hatch pressurization area. So they are working to resolve that. They're expected to still be out at the White Room, which is that access arm that goes out to the rocket, for at least another 50 minutes or so. And then hopefully we will proceed with today's test from there. So as of right now, we do not have a new T0. Teams remain out at the launch pad working to close up Orion. And you can see there at the top, that white square to the right, that is the White Room. That is where the closeout crew is actively working to close up Orion. And a reminder, this is a wet dress rehearsal, a tanking test. That means there are no people that will be strapped inside the actual rocket. The astronauts are currently inside quarantine near the Johnson Space Center in Houston, Texas. Or just outside Houston, Texas, I should say. Speaking of those astronauts, Lauren's asking here, Max, what are the quarantine astronauts eating while being stuck in quarantine? What kind of food are they given? I mean,
I guess just like normal food, like normal healthy food. Like I don't think they have to eat or drink anything super special while they're just in quarantine, so long as the food is treated and obviously in a very clean environment, because that's obviously the point of being in quarantine. And even when they arrive here at KSC, I don't think there's going to be anything super special about the food they eat. The special food they eat is going to be aboard Orion for their multi-day journey around the moon. Probably a bunch of freeze-dried stuff that it has been prepared over at the Johnson Space Center. But also, to be fair, space food has gotten a lot better over the years and actually has become pretty good. So I hear. It is not like it used to be during Apollo and early shuttle. You don't have to sneak on corned beef sandwiches into your spacesuit anymore. I'll put it to you like that. But I think I'm interested to see what kind of breakfast they're going to have morning of the first launch attempt, whether it's going to be steak and eggs or something super simple. But usually something super high protein like that is a go-to for crew members. I know that was Doug Hurley's go-to on the few launch attempts of DM2 back in June of 2020, and has been a staple for test pilots and astronauts throughout the years. So it is also one of my personal favorite meals as well, steak and eggs. In case you were wondering.
We were absolutely wondering. But yes, that is a NASA tradition. It's the whole steak and eggs breakfast, that's been going on for quite a while. One of the main things, and I hate to say it, especially as we get closer to launch, is a low residue diet.
Yes.
To make things easier on the waste system that they have aboard Orion. which they do actually have a bathroom with a door that closes. Orion is a lot larger than most people think. You think just like a tiny, small capsule. It's pretty big for 4 people in there. I believe at one point they were considering being able to have up to 7. So it's and they get their choice of foods. There is an entire laboratory down at the Johnson Space Center in Houston where all they do is work on food in space. And from the astronauts that I've spoken to, one of the things that they specify is they really like spicy food or food with extra seasoning on it. Because once you go into space, the gravity is keeping the blood pumping through your system. With less gravity or microgravity environment, a lot of that blood tends to float up to your head. And that's why astronauts get these larger looking heads in space, and also why they sometimes get stuffy noses. And if you've ever had a stuffy nose and tried to eat food, you know it really doesn't taste as much. So as a result, they tend to put hot sauce. I believe one of them, shrimp cocktail, is a favorite amongst them up in space. So a lot of that goes into the engineering of how they actually design the food that they are going to eat in space, which is freeze-dried typically, and then they have a water system on board that they can use to inject warm water into it to kind of heat it up, rehydrate it as well, and that's how they eat their meals. In case you ever wanted to know. Let's see. Another question coming in here. What are we going to see during the rehearsal? Max, we're already seeing, obviously, a frosty rocket, thanks to the fact that for Florida conditions, it is indeed quite cold at about -2, -3 Celsius, or just below like 30, 29 degrees Fahrenheit here. What do we hope to see as we go through this test?
Well, I hate to be the bearer of bad news, but there really isn't going to be much to see in terms of at least this far away and visually wise. Good Lord, I can't English. It's getting late. It's been a long day. I think at most we'll see the venting from the RS-25s there at the bottom of the mobile launcher stop at some point before in the last few minutes of the count. And we should also see the crew access arm swing away once we get closer as well. And of course, once the closeout team is finished with their work. That is about the most that we will see visually. They will not get to the point in the countdown where we will see the sound suppression water system being activated, or the ROFIs, or the radially outward firing igniters, which are very important for the RS-25s to light properly and in a safe environment. And of course, obviously, it's not launching tonight, so we are not going to be seeing the rocket leaving the pad. The most that we are going to be seeing is just more of what we're seeing now, plus the crew access arm being retracted, and the hopefully many more updates to come from NASA's official blog on how progress is happening over at the pad right now, because right at the moment they are about 2, maybe closer to 3 hours behind schedule now, and there's still a bit of work left to do for the closeout crew in the white room in the crew access arm, because Orion, it hasn't gone necessarily according to plan tonight, but also considering this is the first attempt for Artemis II's wet dress rehearsal, the fact that they've gotten this far and are proceeding this far into the window, especially compared to how the Artemis I campaign went, I would say the night overall, despite things maybe not going so perfectly, has already been miles better than what happened with Artemis I, because Artemis I took 4 rollouts, 3 separate launch attempts, and I believe 3 or 4 attempts just for the freaking wet dress rehearsal as well. So, by comparison, things have gone remarkably well. That being said, though, maybe they haven't gone well enough to actually stand up to and actually hold supporting a launch attempt in February. But that I could be completely proven wrong on that, and I hope I am. Artemis II is better off getting off the ground as fast as they possibly can, but obviously in a safe manner, in a way where the personnel responsible for the vehicle are satisfied in its preparation and its performance so far. But yeah, there's not going to be a ton left to see tonight other than what you're seeing now. We are just standing by for updates from NASA as they come.
Exactly. And again, the last update that we got from NASA was 30 minutes ago about that unexpected venting as they were working to close out the Orion capsule. So we continue to wait for that to be cleared and then to close everything up. Once that's all done, then the closeout crew will depart the pad to a safe distance away, and that is when the testing will hopefully resume again. Let me thank some people here because everyone's all in. As Shazbert put here, when do we get to see the space lunch system? As Jared Isaacman accidentally put it, or it was put in an official document of which Jared Isaacman acknowledged and had some fun with that. All the NASA centers will be getting donuts provided to them as a result of Jared Isaacman, current NASA administrator, per his social media. 321 at Astra saying double-decker cheeseburger. I mean,
that sounds so nice right now. I'm not going to lie.
No. You don't want that. Nope.
Why?
Haven't you two seen For All Mankind?
Oh, God.
Fair
enough. Wait, no, that's a
that?
double bacon cheeseburger, I think it was.
No, double-decker cheeseburger.
It's double-decker.
Oh, well.
Now I get the reference. But yeah, fun fact, by the way, in space, they don't get to have bread. They only get tortillas because, as you pointed out with the smuggled in corned beef sandwich from the early days with Gus Grissom, crumbs in space are very bad. So they try and have foods that create the least amount of crumbs and pieces that can fly away in orbit because you don't want those getting stuck in and around everything, which can happen. So most of the time, bread is replaced by tortillas. And then Doug J with a $50 tip at tips.nasaspaceflight.com. We appreciate you going through the extra effort to use that and to help support what we do here, because that money does go directly into the cameras and people and views and things that we use to bring all of this to you. Saying money for steak and eggs, which we appreciate. Then saying, will the crew bring a zero-G indicator like Dragon crews do, or are there other traditions to look for? Ooh.
I feel dumb. Is there actually an actual zero-G indicator that has been released yet, or no?
I believe Snoopy is returning to space, if I recall. I don't remember the exact ones, but Snoopy did fly on Artemis I along with Shaun the Sheep. They were the two zero-G indicators for Artemis I. I don't know if we've heard anything specifically for Artemis II. I don't know if, Alex, you've heard anything.
I have not, but I will be glad if they do actually fly a zero-G indicator.
Yes.
Yeah,
For those who don't
that
know,
would be cool.
this is a tradition that goes back to the Soyuz days and that the commercial crew program has started using since Demo 2, in which they will have a stuffed animal, a toy, a character, something from a family member, a loved one, something sentimental to the mission that is used as a zero-gravity indicator. So once they hit zero-G, the object will start floating around on camera all around the vehicle, and that's when you know they've reached space. So we'll have to see what they use for this particular mission.
It will be cool if... Because I was thinking, like, okay, zero-G indicators are cool, but what about 1.6G indicator? Right? A way to figure out that you're actually on the surface of the moon. That will be cool.
Well, like a yo-yo, like a pogo, something going up and down. Because again, for those who don't know, it's 1/6 gravity on the moon. It's not 0, not 1. It's 1/6.
I guess it will be with something that, you know, like a stretched sort of like a cord that stretches, right? And so when you are in 1G, it is a certain length. When you are in 0G, it's sort of like fluffy and just floating around. And then you land on the moon, and yeah, it's under gravity, but it's not entirely the full gravity of the Earth, right? So it stretches, but it doesn't stretch as much. I don't know. I have no idea, to be honest, but it would be cool to be able to figure out a way of keeping the tradition even though you are on the moon.
You could also, once you're on the EVA, try dropping a rock and a feather at the same time and watch them fall to the surface at exactly the same speed, because, of course, you're in a vacuum.
Almost like they actually did that on one of the Apollo missions. Hint, hint, wink, wink, nudge, nudge. But yes, Sir Isaac Newton is right. And yes, Snoopy, by the way, has been a staple in the human spaceflight program at NASA for quite a while, going all the way back to the Apollo days. One of the highest awards that NASA gives out is the Silver Snoopy. So Snoopy's always been a part of the space program. I did see someone say that they should have a cow, so that way the cow jumps over the moon.
Didn't Snoopy fly already on Artemis 1?
Yeah, that's what I was saying. Snoopy and Shaun the Sheep.
Yeah. Ah, yeah, that's true.
Yes. One from the United States, obviously with the American-made vehicle, and then you have the European service module. So Europe sent Shaun the Sheep, since he's more synonymous overseas than he is here in the States. Although I still do find it entertaining that as NASA celebrates the 250th birthday of the United States of America this year, since the signing of the Declaration of Independence, the Canadian astronaut on board, Jeremy Hansen, does still have to wear the America 250 patch as well. Continuing along here, here's an interesting question from Stephen Lewis, and I'll throw this one to you, Alex. SLS was qualified by NASA to carry humans after one successful flight. Will Starship get the same treatment?
Well, I think it's safe to say that the development paths and design philosophies are really, really different between the two rockets, right? So no. I guess. Okay, so hang on, because there's a but here, which is unless you're talking about Starship HLS, because technically under Starship HLS's contract, once Starship HLS does one uncrewed test down to the moon, and I think it's like doing sort of like a hop. It's not going back to lunar orbit, but it's sort of simulating the takeoff part and then landing again afterwards. After that, without crew, right? Like we're talking, this is uncrewed. Then they will be approved. Of course, if everything goes well on that mission, then they will be approved to do the same thing, but with crew. Of course, the crew will be going on Orion to the moon. It's just that to go down to the surface, they will be going on Starship, right? But the whole thing of like launching on Starship from the ground on Earth and then re-entering as well, that is definitely not going to be one single launch. I can already tell you that because we've seen already 11 of them.
Yeah, that is true. I guess it's different when you consider HLS Starship versus just regular Starship. But yeah. And Philip Sloss confirming in the back channel as well, SLS wasn't completely certified on Artemis 1. This is their crew demo too.
Yeah, there's a few things that were not on Artemis 1, and they are essentially now here for the crew. Mainly some of the environmental control systems on the European service module. And one other thing that I just saw somewhere else, and I completely had forgotten about this, the abort system, the launch abort system on this mission, it's actually live. Like it's an actual thing. On Artemis 1, it just had the separation motors, but it was not functional. Like the motors that are in charge of pulling away the capsule were not there on the first Artemis mission.
I forgot about that part too. Yes, of course, there is what's known as ECLS, the Environmental Control and Life Support Systems, which they didn't need because there was no people. It was 2 Moonikins that they had on board.
Yep.
For Artemis 1. Now the actual people here. But yeah, it adds mass, it adds weight, it adds new things that they need to try out. I guess it's in a way similar to, I hate to bring it up, but Starliner in a way. They had theirs. Same with SpaceX too, with Crew Dragon. The first flight that had people on it was called Demo 2 because it was still a demonstration flight. Demo 1 was uncrewed. It just had a different mannequin on board as well. I believe that was Ripley. So they like their mannequins. And then the second flight, they like their people.
Yep, you're correct.
Here's a question from Brett LeMay, who also sent stars over on Facebook. Thank you very much for that. I'll throw this one to you, Max. They're asking, what's that fire to the right for?
So that is a burn stack or flare stack for the hydrogen aboard SLS tonight. So the vehicle has been in replenish and has been fully fueled for a number of hours now, and it is being continuously topped off, which means you're going to have an excess of hydrogen in the flow. And so what that flame is excess hydrogen being burned off. That's why we call it a burn stack or a flare stack. And of course, hydrogen is being used on both the core stage and the ICPS, obviously in much different quantities, but the same rule still applies. So No, it's nothing to worry about. It is perfectly normal. We see it on most rockets that use H2 nowadays. Being, let's see if I can name them all off the top of my head. SLS, Atlas V, Vulcan, and New Glenn. Because of course those last three use it on their upper stages, being New Glenn's GS2 and Centaur 3 and Centaur 5 on Atlas V and Vulcan respectively. So flare stacks are not uncommon at all. We see them all the time, and there are multiple actually over at Slick 41 because Vulcan, of course, uses methane as well. And actually, there's also multiple over at Slick or Launch Complex 36 where New Glenn flies from because that also uses methane on the first stage. So flare stacks are nothing uncommon. We see them all the time, and that is their purpose. So they are just burning off excess methane or hydrogen, and in this case, it's hydrogen.
So you're saying for the fire we can blame hydrogen?
Yes.
There you go, Chad. You heard it. Blame hydrogen.
Again.
Always blame hydrogen.
Always be hydrogen.
No, we don't want it to be hydrogen, I guess. But yeah. Speaking of, yeah, we have merch about that too. It's always hydrogen. Brand new, exclusive, limited edition run of this because of the fun that we've already had today with hydrogen during the wet dress rehearsal. So yeah, check that out. Shirts, sweatshirts, mugs, limited edition while hydrogen decides to continue to be a pain in NASA's aft end. Let's continue on here. FBWA asking, what's the lowest temperature SLS can launch in? And the interesting thing about the launch weather criteria for this vehicle is that it's not so much the time at liftoff, but it all has to do with the conditions over a set amount of time. Alex, do you have those numbers in front of you, or you need me to pull them up?
Yeah, I actually have them here. So, for example, there's a constraint saying here, do not initiate tanking if the 24-hour average temperature at both the 132.5 feet and 257.5 feet, I don't know why it's 0.5, I'm going to be honest, is less than 41.4 degrees Fahrenheit. I'm going to guess that some of these are like stones, like it's converted into even more mysterious some kind of units or something like that. Like I bet instead of Fahrenheit they're working with Rankine or something like that, or Rankine. What's the pronunciation of that?
For
what?
The temperature. So 40. So there's Kelvin, right?
Yep.
Which has a relationship with Celsius. There's the same, but for Fahrenheit, which is Rankine. I don't know how to pronounce.
I have no idea. I've never heard that before.
Yeah. Yeah,
Like
so
that's it's from Chernobyl, so I have no help there.
Yeah, they use that apparently on the SLS program. Hang on. Ranking. Okay. Sure, thanks, Anonymous. There was somebody correcting me. Do not launch if the temperature at those levels also exceeds 94.5 degrees Fahrenheit. So I saw, and also for 30 consecutive minutes, I saw somebody saying, why don't they launch in the summer, right? And I'm like, well, maybe in the summer it's actually going to be hotter than 94.5 Fahrenheit, to be fair. So maybe it's not that good to also consider not launching in the cold, because then if it's too hot, there's also a constraint for that. And then do not launch if the temperature at those two levels drops below a defined temperature constraint for 30 consecutive minutes. And I'm like, I don't know what defined temperature constraints, because it says that the constraints range from 38 degrees Fahrenheit to 49 degrees Fahrenheit, depending upon the wind and relative humidity. Higher wind and relative humidity result in a colder temperature constraint. So as you can see, there are constraints for the lowest temperatures. Depending on the conditions, as it says here, you could see potentially maybe 38 degrees Fahrenheit as some of the lowest temperatures allowed for a liftoff. So yeah, but in this case, it will be like for 30 consecutive minutes. So like it will have to be very, very cold for a very short amount of time.
There are some very unique requirements with this vehicle, yes. Of course, obviously, there's the regular ones in terms of liftoff winds cannot exceed 29 through 39 knots between the 132 and 457.5 foot respective marks. Obviously, don't launch through upper level winds that are bad. Don't launch through precipitation. Don't initiate tanking if lightning forecast is greater than 20% within 5 nautical miles. Don't launch for 30 minutes after lightning is observed within 10 nautical miles. Yeah, Apollo 12 may or may not have something to say about that. So that is part of the reason why. In case you're unaware, Apollo 12 flew into a storm that caused lightning that struck the vehicle, caused problems with the batteries and the systems on board, and almost resulted in an abort. However, John Aaron, who is the ECOM down in Mission Control, was able to basically tell them switch SCE to AUX. So if you've ever heard that reference, that's where that's from. And they were able to regain power and everything with their spacecraft and made it all the way to the moon and back. And after that, they don't fly into clouds that can create lightning or active lightning storms anymore, except Russia. Here's one from Michael E. S. And as someone who's photographed them many times, this is perfect for you, Max. Why are Orion spacesuits orange?
So they are easier to see. I think that's basically the easiest answer to put to it. I think it's the universal emergency color orange, and I know there's a better there is 100% better phrasing for that, but I can't think of it off the top of my head. But that's in the event that they have to bail out or that they end up in an area that requires emergency recovery. The orange suits make it a lot easier to spot them, especially in the water, where the water more often than not is blue. And of course, obviously, it's black at night, but most of the time it is blue. And the orange contrasts that very, very easily. Makes them much easier to see over a long distance. Where perhaps if you are searching a very large if you're searching over a large area, your eyes are pretty much glancing as quickly as they can to cover as much ground as possible, and it is a lot easier to see little orange specks than perhaps if they even if they were like white or any other darker color. So that is why orange has been the preferred color for these pressure suits, and it has been that way actually. I think these suits. I don't know if recovery was in mind when these pressure suits were made, because obviously the pilots for the SR-71 and the U-2 also required pressure suits, which NASA borrowed for the first handful of missions with the space shuttle, and then they didn't use those for a while. Then after Challenger in 1986, the orange suits were a requirement for every single flight, and that color was chosen for that reason in particular. So just makes them easier to find in any emergency where the crew has to bail out or is in some area where that is not, I guess, wasn't their planned splashdown area.
Yep, they used them for STS-1 through 4, then went to the regular blue flight suits until 51L, and then STS-26 onward had what have affectionately been known as the pumpkin suits, again, as you said, because of color. And in fact, many of them even had glow sticks in their arms of their suits so that they would be easier to find at night.
So question.
Okay.
What color would you choose then if you're not landing on the ocean? Say you're landing at a desert for whatever reason with your capsule.
So if you're Starliner.
Yeah, there you got it. What color do you choose? Do you choose orange? Turns out,
I
orange
think
is also the color of the sand.
Boeing already chose, and their suits are blue.
Yeah,
kind of a default answer there.
It's the opposite, right? Because you really wouldn't use blue to be able to see better in the ocean, right? But in the desert, where everything is pretty much orange yellowish, what do? You do the opposite. You choose blue. There you go. Some people say neon pink. I will agree with that. I would love to see a suit like that. Please, somebody make that.
DY's, I know, would be very happy. That's one of their favorite colors. But yes, for those who don't know, Starliner, which is Boeing's crew capsule, which has had its fair share of issues, has not returned crew back yet. But when they do return back, they do land in the deserts. I believe it's near, is it Utah or New Mexico? In the southwest of the U.S., and they do wear blue suits, whereas, yes, these crews wear orange. And then the SpaceX suits are basically just pure white with some gray and black accents. Here's one from Hop Hayes with a $5 super chat asking, probably a dumb question, but would there ever be a way to integrate flight-proven Raptor engines in a future SLS block to save money/weight, or nah?
Nah. I mean, well, let's break this down for a second. So the RS-25s were chosen, one, because they had them laying around and they were already very familiar with them, but two, they use hydrogen, and that is also what they've been using since STS-1 with the space shuttle, and that is what the RS-25s were designed to handle. So if you want to re-engineer the whole thing to include Raptors, you are, one, including a much different kind of propellant, but you also have to redesign the core stage entirely, because methane has a much different propellant density than hydrogen, and so the actual tank sizes in proportion to each other have to be different, and you also have to figure out how many RVACs you want on your stage to produce the same amount, if not more, thrust over a long period of time. And mind you, you have to use the RVAC, because the way that the core stage is currently designed, the RS-25s go from sea level to low Earth orbit. And that is why the nozzles are so big, and that is why they produce so little thrust on the ground. 80% of liftoff thrust comes from the SRBs. It's 8.8 million pounds at liftoff, all told, and 80% of that is from the solid rocket boosters. So the RS-25s only really come good when those solid rocket boosters separate. The overall weight of the vehicle is far down from what it used to be, and they are in an environment that better suits their much larger nozzle profile. And so obviously that is why we have those very beautiful but very inefficient mock diamonds at sea level. And of course, the RVAC is really the only other choice if you want to get from sea level all the way into orbit. Mind you, there is a caveat there, because the RVACs cannot gimbal and the RS-25s can, but also ship uses three sea level Raptors that do gimbal and 3 RVACs that don't gimbal. So you'd have to re-engineer the RVACs to gimbal. It's kind of a mess. Kind of a mess. So basically, it would just be more efficient to re-engineer a brand new core stage in general, or just fly Orion on a Starship derived vehicle. I think that's probably the easiest way to put that.
You remember the times when Raptor was supposed to be Hydrolux?
Yes.
It was a long, long time ago, but it was supposed to be Hydrolux well back in the day.
Well before the BFR days, even.
Yeah, when it was MCT, the Mars Colonial Transporter, that was that was definitely a long time ago. The obvious answer is no, right? But there's also a part of this where you mentioned, for example, like the thrust of the core stage versus what the SRBs produce and everything. There is one thing that a lot of people don't understand, that the core stage, as big as it is, the thrust with those 4 RS-25 engines is very much the same as a Falcon 9 booster.
If not less at sea level.
Yeah, at sea level is less than the Falcon 9. Yeah, that's true. Once it goes up into the atmosphere, because the nozzles are a little bit wider and whatnot, when you do the math, it's a little bit more powerful once it is up in a vacuum and whatnot. But yeah, like that big core stage, 8.4 meter diameter, is basically as powerful on its own as a Falcon 9 booster. And that's the reason why it needs the solid rocket boosters. It doesn't have enough thrust to lift off on its own, right? So you add those 2 solid rocket boosters, and then it pushes up the core stage into a much higher altitude, into a much higher velocity. And on top of that, in those 2 minutes and 8 seconds that those SRBs are burning, you have already burned through like a quarter of those tanks on the core stage. So now it's also lighter, and those 4 RS-25 engines are enough to then complete the burn to get this ICPS and Orion into that preliminary orbit, right? So, rocket science, it's how it is.
I think Philip actually put it best in the back channel. Rockets are not Legos.
Exactly. To be fair, though...
Oh, we have an update?
Woo! Update.
Appears we do.
Jake Eakin says update. Breaking news.
Yeah. Always love to see the breaking news stinger. There we go.
Ooh! Wow.
There we go.
Launch abort system hatch is closed. We've been waiting for that for quite a while. The text of the post saying NASA teams completed closing the launch abort system hatch during the Artemis II wet dress rehearsal, simulating final launch day procedures. The launch abort system hatch provides access to the Orion crew module through the outer aeroshell of the launch abort system. It must be securely sealed to ensure crew safety during ascent. Closing the launch abort system hatch is a critical milestone that confirms the spacecraft is fully configured for flight. The launch abort system is designed to protect astronauts in the event of an emergency during launch, and proper hatch integrity ensures the system can perform as intended. With the hatch secured, the closeout crew validates mechanical seals, verifies environmental conditions, performs leak checks, and confirms readiness for the next steps in the countdown sequence. Next up, the closeout crew will depart the launch pad once its work is completed. The rehearsal entered the T-minus 10-minute hold, as we've been talking about, at 8:50 p.m. Eastern Time. The team continues to work through countdown milestones in the hold, though the test has been counting down to the opening of a simulated launch window at 9 p.m. Eastern. The test has continued into the window. While the launch control team initially planned to pause when the countdown reached 33 seconds to launch and recycle the countdown clock back to T-minus 10 minutes to conduct a second terminal count, Artemis launch director Charlie Blackwell Thompson has made the decision to limit the rehearsal to one terminal count.
Oof. That might be a bit problematic because at that point they can't check off a lot of the objectives that they wanted to tonight. That may be a deal breaker for this being a successful wet dress rehearsal. I could be completely off on that front, but it might be.
Ooh.
It does not preclude the fact that they may still go ahead with launch. If you remember from Artemis 1, this whole thing of like doing a few runs and recycling and whatnot, it was something that they wanted to have and do with Artemis 1, but they were not able to do that. This is why they were sort of trying it again on this wet dress rehearsal, but it's just an optional thing, right? At the end of the day, they have decided to not take that option. I don't think that will preclude any sort of like launch attempt on Sunday if everything else went well. Of course, there's still more preparations left on that crew access arm, right? As the update was talking about. There's also the fact that they need to go through the terminal count in the first place. So we'll see what happens, but I would not say straight away that, well, just because they're not doing that sort of holding and recycling thing, that we're not going to have a launch on Sunday, right? It's just that they have decided to not do the extra testing that they originally sort of wanted to have.
But it might be nice to have, especially if they're this close to the middle and end of the launch window at this point. Especially with crew on board, you want to make sure everything is certified and good to go. Should they have to use what they've tested so far? Granted, that isn't an immediate safety issue. That's more of an issue of being able to recycle and try again sooner, and not have to push to a different month and wait for a launch window to reappear.
Now the question is, because I put that in the back channel as well. Since they have decided to not do the recycling of the count, right? Will they go to the T-minus 30 second mark or T-minus 33 seconds? And the reason why that is important, those 3 seconds, is when the ground launch sequencer takes over control of the not the ground, excuse me, no, the other way around, hands off the control of the count to the automated launch sequencer, right, on SLS. Like the ground computers sort of do this handshake, if you will, and it's like, okay, now it's yours in those 3 seconds, and then as soon as they reach T-minus 30 seconds, that is when SLS has the control of the count, and that is when it stops the count, right? Because it is not in a launch ready configuration. So I do wonder if they're gonna go to the T-minus 33 second mark as they originally were gonna be doing, essentially not doing that handoff to the rocket, or if they're actually going to do those extra 3 seconds. It feels like it's very silly. Oh, well, it's just 3 seconds, but it's actually quite an important thing. It's like Falcon 9 in startup, right? When we talk about that for Falcon 9 at T-minus 1 minute, ground computers hand over control of the count to the onboard computers on the rocket. That is a very important procedure to be able to go through that switching. And we've had in the past, just, I've mentioned Falcon 9, we've had that in the past where as soon as they handed over the control, the computers on the rocket said, "Nope, I'm not going." Right. So that handoff is actually quite important from a software standpoint, even.
Very true. So there is some benefit to actually going into the terminal portion of the count. Again, like you said, there's a difference between the ground launch sequencer, which is when they enter the terminal count, and then there's the automated launch sequencer, which is the one that will take it down, if all goes well, to T0 on launch day. But we'll see if they end up getting into that at any point at all. But all this to keep in mind that they have not said anything about whether this will impact the launch date or not. They haven't said if this is something that is an absolute requirement for a successful wet dress rehearsal, if it's a nice to have but not required, or if it is an actual we must get through this. So lots of questions still regarding this. And again, we'll see how the rest of the test goes, because they still have to enter the terminal portion of the count, and who knows what will happen once they enter that portion. Let's see. Let's go back to your questions. Again, you can tag us at NASASpaceflight or at NSF if you have any questions that appear in our software. It makes it easier to find what you're asking us. Here's one from Brianna asking, why is there a communication blackout on the far side of the moon? Is there a reason that a satellite or two can't be put in lunar orbit to provide continuous comms? I don't know, Max, what do you think?
There certainly could be, but it's just the fact of the matter is we don't have that right now. Like if there was a Starlink type network around the moon, then we wouldn't have that problem. But the way things are currently set up right now, and just the size of the moon in comparison to where Orion is going, it's going to be blocking off any sort of direct communication with any antenna on the ground here on Earth. So the way things are set up right now, that is why we have a blackout. But that's not to say at some point in the future that we won't have some sort of satellite network around the moon that would enable communication once the crew is on the opposite side of the moon. Should they even be in that orbit in the first place? But one of the benefits of a near oh god, can I say this?
Near rectilinear halo orbit?
Yes, thank you, Sawyer. One of the benefits of being in that orbit is that you don't have a blackout period. You are always facing the Earth, and you will always have direct communication with them. Now, there are obvious downsides to going into that orbit, but those are not applicable to the Artemis II mission because they are going on a free return trajectory around the far side of the moon before coming back. So we can dive into that on the Artemis III stream at some point in the future. But the way things are currently set up right now, that is why we currently have the blackout. But that is not to say that oh my gosh. That it'll be that way forever. Good Lord, it's getting late.
Yes, it is. It is 10 minutes before 11 p.m. Eastern Standard Time as we look live again still at Launch Complex 39B at the Kennedy Space Center in Florida, which is where Max is currently located. I am also a couple hours south of where he's located, and we'll be with you up there for the launch campaign, of course. Here's a good question. And Alex, if you could help kind of run us through the timeline with obviously waiting to get into that terminal count now that we know they're only doing one run at it. Grayson Decker is asking, what happens in the countdown for the wet dress rehearsal from now onwards? So what will happen once we get past the T-minus 10 minute mark?
Yeah, so during terminal count, there are a number of things that happen. With the vehicle itself, you have things such as, which are very important, by the way, getting the tanks up to flight pressure, for example, on both ICPS and the core stage. The rocket and the Orion spacecraft all are both sent into internal power, for example. You have things like the Ascent Pyrus, the things that are going to be essentially firing for things to separate during flight and whatnot. Those are also armed and things like that. You've got, most importantly, the crew access arm retracts as well. I'm not going through the actual sort of line by line in chronological order, mostly because, you know, there's many things, but sort of grouping some of these things together. There are purges as well, like purge sequence for part of the cavities as well. There's launch abort system becomes available. You've got, of course, as well, towards the end, you've got when that handoff happens in between the ground launch sequencer and the ALS, the automated launch sequencer. Then the hydrogen burn-offs ignite and everything, but we are not going to see that, of course, on this countdown, but it will happen on launch day. We will not see, of course, some of these items, unfortunately, because some of those happen in the background. We will not see, for example, the core stage or the SLS in general and Orion going into internal power, because that's not something that you see. But I do wonder if we will see, for example, the tanks getting up to pressure, because if they go up to pressure, then they probably will close off those vents that we see there on the liquid oxygen tank of both core stage and ICPS, for example, just to put one of these things into place. I do wonder if we're going to see, for example, part of the purges as well for the engines. Maybe if we're going to see perhaps, I do wonder if they're going to be testing like the engines as well, the gimbaling system and things like that, the TVC as it is called technically. We might see, let's see, I'm trying to run through mentally what things we may see. Well, of course, the crew access arm will retract. That will be visible as well. And I cannot think of anything else that we might see visually. But we'll hope to have at least some kind of updates from NASA.
We will hopefully get updates on that. And yes, we'll see how much we are able to see. And of course, we'll watch it all with you through the entirety of the test. Which, a reminder, if you're just checking in, they are now down to a single terminal countdown tonight rather than the original plan, which was to get through a terminal countdown, reset to the T-minus 10-minute mark, and then do it again. Fathoms Enterprise, thank you for the super chat earlier. Want to make sure that I appreciate that. No message, but still, thank you very much. So in regards to that, Brian Sell asking, what is your speculation as to why the launch director limited it to one terminal count? And I think it has to do with the fact that they still technically have a window tonight, and that window goes until 1 a.m. Eastern. And I feel like if they reset, I believe, Max, we said, what, it was an hour they had said at one point to reset between attempts?
Yeah, minimum. And they are about to approach the 2-hour mark left in the window, as it is currently 10:55 p.m. local time here on the east coast of Florida, which is also in the eastern time zone here in the U.S. So a little over 2 hours left in the window to work with. So time is certainly running short on their end for the issues that they have currently run into, and the solution that they have put forward to this point will work with the time allotted. But if they do run into any sort of issue beyond that point, because of how long it would take to recycle, then at that point the test would be called off. So either way, whether or not they actually make the current target, it'll be interesting to hear what NASA has to say about it regarding results and whether or not they are satisfied with how the vehicle performed, as well as the ground systems as well. Because it is certainly not as straightforward as some might think. Like, it's not just a simple yes, it worked, no, it didn't. There are things that did and didn't work well. I mean, obviously at this point, the most obvious thing I believe is the fact that they had to stop and restart hydrogen load both on the core stage and on the ICPS today twice already, and that there was already a substantial leak on the tail service mast, which is what fuels hydrogen into the core stage as well. If you follow the core stage all the way down to the bottom, you'll see these two sort of gray fingers poking up, and the one on the right, I believe, is the one for hydrogen, and that is where both hydrogen. So there's two there, one for oxygen, one for hydrogen, and it is fueled from the bottom going up. So that is what caused somewhat of an issue earlier, and that's also what caused LH2 flow to stop twice, at least for the core stage and the ICPS as well. But the ICPS is fueled from an umbilical farther up the rocket. So it has not been a super straightforward countdown this evening. There have been issues, but as I was saying earlier, in comparison to how Artemis 1 went and the three wet dress rehearsal attempts, the 4 launch attempts, the 4 rollouts. I'm sorry, the 3 launch attempts and 4 rollouts. The fact that they have gotten this far on the very first wet dress attempt is marvelous. But that is not to say that it is a perfect test, nor that it will certify SLS as good to go for a launch attempt this weekend, and we likely will not know more on that front until tomorrow.
Exactly. The original plan was for a press conference tomorrow afternoon following the wet dress rehearsal to give an update. We'll see if we hear anything prior to that. Of course, NSF will be covering that press conference as well, and we'll have people in there to ask questions about today's test. I see a lot of people asking what's preventing, when SpaceX does it with Starship or NASA from just getting to zero during a test and saying, YOLO, let's launch it. There's a couple of things that go into that, and I think one of the biggest ones is the fact that there are a lot of things that need to be closed off, protected, so that the public stays safe, so that aircraft stays safe, so that boaters stay safe, and things that would be really bad if you ignored a T0, which I believe SpaceX did at one point launch without a license and got in a lot of trouble for it. That was, which one was that, Alex? Is that SN8?
Yeah, that was back with SN8. But yeah, there's a lot of things in place. Mainly the computer systems, right? The software systems that are running the multiple things, not only on the vehicle itself, but also on the ground itself as well. As we're mentioning, once they go and hand over control to the computers on SLS, it's like, well, now SLS says, wait, hang on, I am not ready to launch, and it stops the count. Like, I believe Philip said before that it will be T minus 29.98 seconds. Like it's like 2 centiseconds, I guess, 200ths of a second after taking over. It's like, right, and it stops. So yeah, there's that, which is very important. I know a lot of people remember, for example, the Tianlong 3 accidental static fire, accidental launch, static fire turned into accidental launch. In that case, it was not about the software. It was not that, oops, it launched. It was just because the hold down clamps, it was the hardware that actually failed, right? the clamps were not rated for that thrust. And I will argue, I will trust the software first over the hardware.
Yeah, that was an oops, to say the least. China's restrictions and laws are a little bit different over there as well compared to what we have in the United States.
You would say that, but actually that company got quite a reprimand from the local government. So yeah, because
I can only imagine why.
Yeah, right. Even there, they were like, dude, no, don't do that again. The next time they actually went to do a static fire test of that rocket, obviously not the same one, but like same Tianlong rocket, which is what I mean. They did it out there at sea on a barge. It was like, well, if it flies off, it's on a barge. It's gonna land in the water. They were super smart doing that because they were like, yep, let's make sure if it flies off again, it's out there in the water.
When in doubt, improvise.
Exactly. But yeah, they were actually reprimanded by the local government. It was that severe.
That is true, yes. But yeah, the FAA takes extreme cautions with all U.S. launches. That is why they require launch licenses, why there needs to be restrictions in place for airspace, sea space. There's whole security details that go into place. Airlines need to be rerouted and diverted. So it's a lot that goes into it. That's why they don't just go when they want to, because that could be a very bad day for a lot of people, and there's a good chance they would not be flying again anytime soon.
Some astronaut, go ahead. Sorry, I just can't imagine a Chinese official walking in saying, dude, no.
Fair enough. Here's a good thought question while we have some time, continuing to wait for more updates of when they will go for a simulated T0, when that will be. The last update is that teams are still working out at the pad to finish closing things up. Do you think, realistically, that we will see Starship ready for the Artemis III lunar landing by 2028, which is the current timeline designated by the current administration to land people on the moon by the end of 2028? Max, I'll start with you and then over to Alex.
It is certainly far more realistic than the actual 2027 timeline that was put forth for a while. If I had to put numbers on it, I'm probably in the neighborhood of maybe 70-30 yes. Because if there was ever a company to be able to deliver when the odds are stacked against their favor, it has been SpaceX, historically speaking. Now, granted, that is not to downplay the scale that HLS really is in terms of project size and importance, not only just for SpaceX as a company, but also for the U.S. as a nation and our goal of getting back to the moon with our international partners. So I think if I had to put numbers on it, it would be 70% yes, 30% no. But we will hopefully find out more later on this year as it progresses on just how that is going, because Starship has to meet a lot of testing criteria this year in flight and on the ground in order to keep that realistic. As we have seen, this is a classic example. Back in 2022, 2024 and 2025 and 2020 seem so far away. And believe it or not, it's been just over 3 years now since Artemis 1. And it feels like we just blinked and Artemis 1 was yesterday. And here we are on the pad 3 years later with Artemis 2 in the next SLS launch vehicle. So, yeah, 70-30 yes.
Alex, what do you think?
I think it's going to be complicated to meet that goal. There's a good chance that it is not met. I'm going to be honest here. I'm in the camp that I don't really care too much, if I'm going to be honest, about whether it's 2028, 2029, or 2030. And I say this as somebody that actually wants Starship to be first, to be honest, right? But there's also the matter that Starship is very complex. There's a lot of things going on, and just a reminder, its contract was signed in 2021, right? The rocket that you see there on your screen, it's got a lot more history than just 2021. Believe me, it goes a long way, right? It's had many years, more than a decade. In fact, some of the parts on that rocket have decades and decades of history behind them, whereas Starship hasn't, right? And when we compare about HLS late and whatnot, it feels like that's lost in some people's minds, that the lander was sort of like an afterthought to this program, right? And so trying to develop such a complex system in a very short amount of time, it's not easy, put it that way. Then there's Blue Origin as well, doing their own lunar landers as well. They are also behind their own schedules. But I will say, if they do it faster, sure, do it. Like, go with them, right? I just don't think even they are going to be ready for a 2028 landing. I think it's going to be really complicated for either companies to have a lander ready basically in 2 years' time. 2 years is a long time, though, so we'll see what happens.
That is true. There's still plenty of time, and there has been the initiative put forward to see by the previous acting administrator if either Blue Origin or SpaceX or another company would be able to accelerate their timeline to get a lunar lander ready in that time. But of course, there's one key milestone that has to come first, and that is proving that Orion can work with a crew on board on a slingshot around the moon, and that is exactly what Artemis II is for. So that is obviously somewhat important to get through at this point.
Indeed.
Here's one. I don't know if anyone has the numbers for this, because obviously we talked about the fact that they've been fueling for a while. So we're talking about preparation starting at the T-minus 10 hour mark for what was supposed to be the T0 of the test, or the L-minus 10 hour mark, I should say. Of course, they reach their top, things burn off. We've seen the flare stack. Do we know how much fuel or propellants they lose during a wet dress rehearsal? Chevy Boy is asking.
Ooh. Well, between the ICPS and the core stage itself on both the LOX and the LH2 sides, all in, SLS has about an overall capacity of about 700,000 gallons all in. So, excuse me. I don't know the boil off rates for either propellant. I'm going to be honest, but I know it is substantial because of how cold they are. And as efficient as Sophie is as an installation, of course, it is not perfect, and that is why we are currently seeing condensation on the outside of it. It is one of the better options, and it is very good at what it does. I mean, that's obviously why NASA chose it to work on SLS, but also on the external tanks for shuttle. So I don't that is a Phillips loss question if there ever was one. To be completely honest, I don't know, but I know it is pretty substantial.
I'm almost scared to say the numbers, but again, that's part of the test is they expect this. They've upgraded all of the systems out at LC-39B to be able to hold more of the liquid hydrogen. So they improved their abilities from Artemis I, where if something were to happen during an actual launch attempt and they needed to try another day, it was at least a minimum of 48 hours just because of the amount of commodities they had. That has been improved to the point where they can do back-to-back attempts. So if something were to happen during an actual launch attempt, if the time allowed, they could do a 24-hour turnaround because of the upgrades that they've made since then. You get companies as well like SpaceX that are working on ways to reclaim said propellants. That's not something that NASA appears to be doing at the moment, but they seem to be doing just fine. And again, hydrogen, quite abundant given element number 1. So blame hydrogen. Let's see. This is an interesting thought question as well, because we talked about the Sophie and how during shuttle they used to paint it. Sarwa was asking, I wonder how many pounds of paint they used painting the NASA Worm and America 250 logos on the solid rocket boosters. I feel like it's almost less significant weight-wise on the SRBs than the orange Sophie. Or am I mistaken on that?
No, I think you're spot on with that, Sawyer. I mean, obviously, the weight loss for the paint for both logos on the SRBs is not sufficient enough to not warrant their presence on the SRBs, and weight is less of an important factor at sea level than what it is when you're in the later portions of flight or stage 2. In which of case, in this case, the core stage goes all the way from sea level to orbit. So it's more of a weight issue there, but on the SRBs, I don't think the margin there really matters. I think obviously they're there, so I think a few pounds of paint here and there on the SRBs is just fine. Now, if you wanted to put logos that big on like the ICPS, for example, like obviously you won't, but hypothetically speaking, just the weight of the weight of paint on the ICPS is a lot bigger deal, because I think it's about at that point at that point in flight with the upper stage, it's about 1 pound for every 1 pound you add to your stage or payload is 1 pound. Actually, hang on, I have this backwards in my head. Every 1 pound you add to your stage is 1 pound of payload you lose the ability to carry. So it's a lot bigger deal for upper stages than it is for first stages. So on the boosters, I mean, obviously it's fine because they're there. So don't have the exact numbers on it, but obviously I don't think it's a lot.
And the other thing to keep in mind is that the boosters are only on for approximately 2 to 2.5 minutes, whereas the orange tank that you see there is on for closer to 8-9 minutes plus. So it's a lot more of a weight constraint when it's on there for as long, and the majority of the thrust at liftoff of SLS is from those solid rocket boosters. So once those solid rocket boosters are gone, any extra weight that you have on the orange foam or the ICPS, like you were talking about the upper stage, actually becomes more significant. So those are quick burners. They move fast, they get out of Dodge fast, and then let the RS-25s do their job. Which, along those lines, Dino Nuggy, thank you for making me hungry, asking, why did Apollo missions not have boosters, but Artemis does? And Alex, I could think of 2 answers to that. One of them is F1, and the other is, one of them is the F1, and the other is the J2.
Yeah, I will also argue that, first of all, they're very different rockets, right? Like, that's out of the gate, they're very different rockets. But yeah, the SRBs are essentially doing the work of what you will see on Saturn V's first stage, right? With those 5 F1 engines. There was, however, proposals to add SRBs, not these SRBs, but like, solar rocket motors or boosters on the sides of the Saturn V, and sort of augment the capability of the rocket just by adding more thrust to the first stage. If you watched any sort of video of Saturn V lifting off, it crawls off the pad, right?
Very slow.
So if it has a little bit more help with SRBs, for example, then that gives it a lot more performance. And that was one of the sort of more easier upgrades that they were thinking at one point for the future of the Saturn V. Is that the Closeout crew?
I think it is. Oh, and the van's moving.
Yep, the van is on the way
There
out.
we go.
So
Fantastic.
Closeout crew is leaving the pad as we speak. Oh, that is such a cool shot. Look at that. Oh no!
It's audio only. There we go.
Turns out now it's video only. But yeah, to sort of to channel my own inner Ryan Caden.
Where's the van?
Where's the van? There's the van.
Where's the Closeout crew?
Yeah, exactly.
Yes. The Closeout crew
yeah.
has been stationed, by the way, down near the press site over at Launch Complex 39, where we're located. That was where they were waiting to get the go to suit up and roll out. It's multiple crew members on board, each of them with their unique roles, and it does include the 2 backup crew members for the Artemis II mission as well. So that will now leave the pad. They will get away to a safe distance, and hopefully that will allow them to continue with the singular terminal countdown test.
So this step in the L- clock, because we are at T-10 minutes and holding right now, but remember the L- clock is the one that counts to the simulated launch, right? And the T- is the one that counts along with the events, right, of the countdown, which is different. So it can actually stop and resume and everything. This, for the L- clock, this step in the countdown would have been at L- 45 minutes. So imagine a simulated T0 perhaps, or around midnight, essentially, because it's currently 11:15 p.m. So 45 minutes from now, that will be around midnight. That's perhaps where we're heading to with this test today.
And we have an update as well from NASA on their blog, basically saying what we were able to see with our Mark 1 eyeballs. NASA's Artemis II closeout crew has completed its critical tasks and departed NASA's Kennedy Space Center Launch Complex 39B during the Artemis II Wet Dress Rehearsal. The departure of the closeout crew marks the transition to the final countdown phase, ensuring the launch pad is clear and safe for simulated liftoff procedures. Although the Artemis II astronauts did not participate in today's rehearsal, the closeout crew's work validates launch day protocols and confirms Orion and the Space Launch System rocket are configured for flight readiness. With the pad secured, teams will continue monitoring fuel operations and prepare for wet dress rehearsal terminal count, the final 10 minutes of the countdown. The team will be conducting a single terminal countdown for this test. There it is. There's the official update. And we'll see what ends up happening with the timeline here. Because again, this is a little bit of a tighter schedule as they are now only going for the singular countdown test rather than going all the way down to the 33-second mark, recycling to the T-10 minute mark, and then trying again potentially into the actual automated launch sequence portion under the T-30-second mark. We'll see if they actually go and hold at T-33 seconds, or if they allow the automated launch sequence to call the abort on it, and once they pass the T-30-second mark. That will be interesting to see. So, Alex, can you kind of run us through what's still left for them to do before the simulated T0, aka when they plan to abort?
Well, on launch day, there are a few more things that they will be doing. I wonder if these are already completed by now, because some of these can be probably run in parallel with some of the work that was going on at the crew access arm. But for example, there's an item about the launch director, Charlie, briefing about the condition of the vehicle and like looking at the TPS, the thermal protection system, and things like that. There's also things like transition team to Orion to Earth comms loop and things like that. Maybe that's not happening today because it's a wet dress. They're not actually launching or anything like that. So probably not a thing that I will see. But very soon, as we hit potentially into that terminal count, Charlie Blackwell Thompson, the launch director, will be polling launch control team for go for or no go for terminal count. And obviously, we will not be able to hear that. We are not having that sort of access for the wet dress rehearsal, but we should hear that hopefully for launch attempt, if we get to that point, knock on wood, hopefully on Sunday. So we'll see. There are a few other things as well regarding just basic preparations for launch, of course. Just making sure that things in the rocket are ready to go into the terminal count, and that's probably something that they're going to be debating ahead of the poll, or maybe during the poll that may come up. So it's not guaranteed that we're going to go into a terminal count, right? But they're going to be trying to get there. We have no information as well in that sense. So we'll see. I am hopeful that we will, though. So let's summon the terminal count, please. Let it happen.
Yeah. And you make a good point there, Alex, is of course they are going to try to make it through the terminal count, but it is a test and things could happen. So we will see how far they're able to make it. Hopefully they're able to make it down to the point where they were originally planning to call the abort or the hold, but we'll see. Also wondering, Philip making a good point in the background, we were joking earlier about how long it was taking the closeout crew to actually get out to 39B, and they were going about 10 miles an hour, I think we calculated. Wondering how much faster they're going on the way back to where they started, which is right near the press site here. I know our team's going to be keeping a close eye out for those cameras.
Yep. So yeah, we were talking about many hours ago about how if today was a launch day, I would be worried. Thankfully, if this was launch day right now, I wouldn't be worried because it will have probably already S-word by now. Mostly because we will have already gone through the entire window. The window for today's test runs until 1 a.m. But on launch day, instead of being 4 hours long, it is 2 hours long. And if you look at your clocks, it's already 2 hours and 20 minutes into the window. So on a launch day, we will probably not have gone to space today if this were an actual launch. But that's why they test. See, I said the thing.
You did say the thing. That is why we test. Also, I need to give this haiku before we move on, or poem here, from your sim enthusiast saying, "Roses are red, Mars is cold, NASA will never stop the hold." I kind of love it. I'm just saying. And there they are, by the way. There is the closeout crew making a beeline out of there.
The lights make it very easy to spot.
That is true. And they are definitely moving faster than they were previously. That is for sure. They are getting out of Dodge and making their way back to the safety area. They tend to be stationed out near one of the kind of office main buildings that they have in the area, known as OSB 2. They were kind of hanging out in that parking lot previously and stationed there waiting for their turn to go in. And of course, on launch day, they also stay ready just in case they would need to remove the crew from the vehicle in the event of an abort of some kind, or if they were to decide not to launch, we'll say, then they would be able to go back out, retrieve the crew, and get them out of their harnesses. Of course, for today's test, there is no crew inside the capsule. The crew currently remains in quarantine at the Johnson Space Center near Houston, Texas, with the hope that they will, if all goes well with this test, start heading towards Cape Canaveral for their launch date, leaving and arriving here tomorrow, which would be the 3rd of February, for a hopeful launch attempt on the 8th of February. That date, of course, all dependent on today's tests and the results that they were able to get from it. And if needed, they also have attempts in February on the 10th and the 11th. If they do not go on the 8th, 10th, or 11th, their next available opportunity would be no earlier than March 6th. And I know we've kind of talked about that a little bit, but it's been a while since we've mentioned why are they so tight on those launch windows? Why is it they can't go, say middle of February? Why does it have to be March 6th if they don't go by the 11th? Who wants to take that one?
I
Alex, you
can take that one. Yeah.
There you go.
So there we go. That's the mission availability, the potential dates. Of course, originally we had February 6th and 7th for those first two attempts. Unfortunately, because of the 48-hour delay of this wet dress rehearsal from the 31st to the 2nd of February, then we are sort of out from those. So the earliest will be February 8th. But if we were to go to March, you can see it's the same dates, more or less, with a few changes here and there. The main reason you can see there on the times is because here in February, in this month, when it goes from the 8th to the 10th, you can see the times sort of go forward a little bit from one day to the other, right? When it goes forward, it crosses midnight. So instead of being on the 9th, it is on the 10th of February. But when it happens on March, the one on the 6th, it's a little bit earlier, and then it moves forward on the 7th, and then it moves forward on the 8th, moves forward on the 9th, but by the time it moves forward for the 10th, it's actually not 10 anymore. It's the 11th. And in fact, I think by then it's even a change in time zones as well. That will be a very fun time to have a launch, right? Especially with SLS, where you have, Eastern Standard Time, and then it goes to Eastern Daylight Time. But yeah, the reasoning behind all of this is just the many constraints that they have and how to square that with where the moon is, where the sun, where the Earth is in its orbit around the sun, right? And so you've got different times because that's how orbital mechanics works. Once you try to sort of find the constraints, or sort of like fit a mission within the constraints, and then you're like, well, this is how it is, right? And I believe at one point Philip mentioned that the windows technically are probably longer. They just have like a limit of how long the crew can stay, for example, on their bags, waiting for the launch, for example. So they also limit sometimes the length. Like maybe they can just put a number out of my bag here. Maybe it's like 2.5 hours that they can actually do with this rocket and the constraints that they have and the overall mechanics and everything. But because they have that constraint with the crew, then you have to limit to a certain amount of time, right? Which is in this case 2 hours. But that is very much all of the things that you have to take into account. Like that, even after overall mechanics, after the vehicle, you still have the crew as well as one of the constraints. You don't want to have that crew, poor people, spending so much time on their bags. So yeah.
Exactly. So you don't want them staying out there too long. And then again, you have the concerns of Orion out in space. You need the moon in the right spot, especially to be able to preferably get the lighting that you desire. And it's not so much for the photography getting the lighting. A large portion of it is the fact that they can only have parts of Orion with those solar panels in darkness for so long. So typically they try and prevent it so that the Orion capsule and the crew is not in darkness for longer than 90 minutes. And that also goes into their launch time. And unfortunately, that ends up meaning a lot of night launch attempts here. And as you pointed out, once we get into April, things start to change. But at the same time, as nice as it would be to have a day launch, I also hope that we're not still here in April trying to get this rocket off the ground.
Yeah. I also forgot one thing. There's also constraints on the other side of the launch window. So I mentioned that there's a maximum length for the window, right? 2 hours because of these constraints and whatnot. But they also chose not to launch on too short of a window. So technically SLS, and we saw this on Artemis 1 as well, SLS should be able to launch in certain windows are shorter. right? That are maybe like 30 minutes or 40 something minutes or something like it's just a few minutes instead of just an hour or 2 hours. But they decided to not do that precisely because of the crew. And apparently, I think at the at one of the recent press conferences, they mentioned that coincidentally, or not so coincidentally, one of the constraints of this mission, if you remember, is that heat shield reentry, right? It's a shorter reentry path, and apparently that also constrains the shorter windows because when you work it backwards, it's sort of a weird thing. And I don't know how that works, to be honest, but it just so happened that it also cut off some of those shorter windows, which is rather interesting, to be honest. I really would love to be able to know a little bit more about this. Unfortunately, it's not like we have insight into the engineering of this. But as a person that likes physics and whatnot, I really would love to know exactly what are the things that made that possible.
It's something I think we can ask at some point during the mission. But yeah, so again, hopefully it gets to the point where it gets off the ground. So at this point now, we are keeping an eye on the clock. You can see they're still at T-minus 10 minutes and holding, but we did see the closeout crew leaving the launch pad and getting to their safety area away from the rocket. We don't know if they are constraining their times here, if they're going to shorten their checklist as they go through, if there's things they've already conducted, because they are about 2.5 hours behind where they were originally hoping to be at this point, so much so that they've decided to go for a single countdown tonight rather than the 2 that were originally planned. A lot of that goes back to the hydrogen leaks of the early parts of the count. There were 2 different times where they had to stop loading hydrogen onto the vehicle, with the tail service mast umbilical at the base there leaking and causing problems, something we've seen previously on the Artemis I mission. So after they resolved that, they've continued on. They were finally able to get the crew out to start closing up the hatch, and then a valve was accidentally released. So as a result, they had to repressurize and then finally get to close up the capsule and close up the outside protective fairing that they have. And now the crew has left. All that is left, hopefully, is to see that clock begin and get into the terminal portion of the count. And I know, Alex, you went over it again, but for the people that are tuning in as we get to the exciting parts here, what will happen once we go beyond T-minus 10 minutes, once they restart the clock and the ground launch sequencer takes control?
Yeah, now this time around, I'm going to go in order. Chronological order. So at T-minus 8 minutes, the crew access arm will retract. T-minus 6 minutes, they're going to be hitting the go for tank press on the core stage. The Orion ascent pyres are armed. Orion is set to internal power. T-minus 5 minutes and 57 seconds, the core stage liquid hydrogen terminates replenishment, aka it stops replenishing sort of the hydrogen that is boiling off. Then T-minus 5 minutes 20 seconds, launch abort system becomes available, and the test director, NASA test director, notifies the crew of that. Of course, that's not going to happen here, because there's no crew on board, right? T-minus 4 minutes and 40 seconds, the ground launch sequencer will be go for LH2 high flow bleed check. I believe that's part of the engines that they are doing there. T-minus 4 minutes 30 seconds, GLS go for flight termination system arm. T-minus 4 minutes, the APU start on the core stage, and then also liquid oxygen on the core stage ends replenishment. And then we go down the list here to the ICPS liquid oxygen terminate replenishment at T-minus 3 minutes and 30 seconds. T-minus 3 minutes and 10 seconds, GLS is go for purge sequence 4, that is the purge of the cavities, goes from nitrogen to helium. And then T-minus 2 minutes, 20 seconds, ICPS switches to internal power. T-minus 2 minutes, the SRBs switch to internal power. T-minus 1 minute, 30 seconds, core stage switches to internal power. And then T-minus 1 minute and 20 seconds, ICPS enters terminal count mode. T-minus 50 seconds, ICPS liquid hydrogen terminate replenish. And then T minus 33 seconds, that is when the start of the handoff to the onboard computers from the ground computers of that control the count happens. Of course, after that, we will not see that here today, but there'll be all of the other things preparing for ignition and whatnot, and of course, liftoff. But lots of things that happen, right? That was a more thorough in-depth rundown, I guess, than last time. But I also wanted to highlight how many things happen in those 10 minutes.
It is a lot that happens in a short amount of time, and all of it has to go exactly right for the test tonight, and especially exactly right on launch day. And I do want to bring this up while we wait for this clock to start. On the actual launch day itself, these final 10 minutes are ridiculously fast feeling. It's an absolute blur. For Artemis 1, Max, you and I were next to each other for this launch before we even worked together. You can attest just how quickly that final 10 minutes just whizzes by and how much has to happen in then.
It isn't even the last 10 minutes. It's like the last maybe hour and a half is when time starts passing almost exponentially faster. I know that wait. So we were at that T minus 10 minute hold for a while during Artemis 1, and that felt like it both felt like some kind of eternity, or and also like 2 minutes. Like it's really, really wild how time seems to pass quick, fast, and slow at some points in the countdown. But yeah, at T minus 10 minutes, it feels more like 10 seconds just played out in over a very long period of time. It's like 10 seconds in slow motion, really. But yeah, time does pass very, very quickly, especially the closer you get to T0, and Artemis certainly is no exception.
That is for sure. I can only imagine how fast it's going to go for Artemis 2. It's the same with any crew mission for that matter. As soon as you involve people in spaceflight, it goes from extremely slow leading up to it because you're, nervous and concerned that there's humans on board, but then it moves so fast and it gets right to the launch, and it's always a pleasure to see 4 people get a chance to fly into space and hopefully do some amazing science, get some spectacular views, and bring back what we like to call the overview effect of bringing the perspective of space back down here to Earth.
Can I shout out Philip Sloss here for a second?
Please
Because I was rewatching the other day the Artemis 1 coverage, our coverage of Artemis 1. And, once we went into terminal count, he was calling out the events that were going to be happening before they were actually happening. And I remember sitting here in this very same chat. Of course, I was muted because I was not in comms that day, but I was listening in to our chat live as he was sort of, saying all the things. And every single time I rewatch that coverage, I'm like, he's a pro for this, right? Like, it's quite cool. I try to do the same with Falcon 9 sometimes. I sometimes do get it wrong, to be fair. But I do feel that sort of thing of like, these are too many things that are happening in 10 minutes. I wouldn't be able to remember every single thing here from this. And he does know that, so shout out to him. It's interesting when you go back and watch that.
I will say, back in the shuttle days, I used to have it memorized. I definitely do not for Artemis. And yes, shout out to Philip Sloss, who is our resident expert here on all things Artemis, as well as going back to the days of Shuttle 2. Steve Daly with a good question, which I don't know if we know the answer to. Max, are they actively performing verbal checks that we will be able to hear and that would be broadcast on stream during this last 10 minutes?
I think, I can't remember where I heard this, but I think we should have about the last maybe 15 minutes or so in the countdown. We should have audio from the LCC in that. And that was where, at the T-minus 10-minute hold marker, was where we got that wonderful call out from Launch Director Charlie Blackwell Thompson for Artemis 1, praising everybody on the ground who has helped get SLS to the point where it had gotten to that point before giving them the green light to pass through this checkpoint and then onto T0 and launching it. So I want to say it's 15 minutes in the count onwards. I could be wrong on that. I cannot remember where I saw that. Maybe it was an email, maybe it was a document somewhere. I'm not sure. But we should at least have audio for the last 10 minutes, at least upon releasing the T-minus 10-minute hold somewhere.
Hopefully. Again, we will keep our ears out and our eyes out as well on the clock, which at this point still remains holding at the T-minus 10-minute mark as it has since 9 p.m. Eastern Time, 2 hours and 37 minutes ago.
I do wonder how we'll figure out whether they're going into terminal count or not. Because for all we know, they may just, like, Charlie may go her go, right? To proceed into terminal count, and then the clock sort of continues counting and the hold is clear. And then we see that clock, which is partially why we're keeping it there, by the way. We're keeping a close eye to that clock, precisely because it could just, pick up the count anytime before we actually get any updates from either the ticker on NASA's thing, right? Or the blog post or whatever. As Max was saying, it could really be quite a quick thing, and so just keep a close eye to that countdown clock at the press site.
Exactly. If you've been wondering when to watch all day as this testing is going on, we are getting to that point now where keep a close eye on your screens as we wait for them to start that countdown clock. And a reminder, as they mentioned, the plan originally was to take it down to T-minus 33 seconds right before the automated launch sequencer would take over, recycle the count to T-minus 10 minutes, and then try again. They have decided to forego that second attempt. So this will only be a single countdown, and we'll see if they stop it at T-minus 33 seconds or if they let it activate the automated launch sequencer, of which the way that the vehicle is configured and set up right now, the computer will very quickly realize we are not ready for launch, and at that point would then end the attempt. We'll have to see what they do. So if we see the clock get to T-minus 29 seconds, then we'll know that the automated ground sequence called the abort. Otherwise, we will know that it was the ground launch sequencer or a manual abort that was called. Before we get into this deep part, then let me thank some people here really quick. Ninja Decimator, a favorite name here. Thank you. Saying, oh gosh, can SLS launch in the rain, Max?
No. Next question.
You know that was a reference to our stream that we were on from Ship 36. Because the question was, can Starship static fire in the rain?
Yeah, probably.
There you go. Thank you.
Whoa!
Oh my god.
My god. So about those launch shades. It's funny because you two were on that stream. I was supposed to be on that stream, but I was like, can somebody substitute me, please? Because I'm too
Little
sleepy.
did you know.
I was very sleepy. I woke up, and within 10 minutes of me waking up, that thing blew off, and I was like, wow, okay. So yeah.
Yes, it was Jack Beyer, Max, and myself on commentary. D-Wise, I believe, was also out there. And Jerry Pike, I think, as well. Anyway, yeah. But yes, in terms of actually launching in the rain for the legitimate side of the question, no. That is one of the weather constraints that they have, is to not launch into any precipitation. Of course, there's the concerns of lightning both above the pad and in the area around the pad. There are concerns for thunderstorms in the area that they have to worry about at that point. Winds, solar activity, upper level winds, all of that is taken into consideration in the weather, and temperature, which the original countdown test that they were planning to do with the wet dress rehearsal was supposed to be a couple of days ago. However, NASA said due to the weather, the cold and the winds that were happening here in Florida, they decided to forego that and move it to today's date. And as a result, that eliminated February 6th and 7th as potential launch opportunities, which, Max, I know people are going to, again, yell at us for this, but for Florida standards, it is indeed cold tonight.
It's not even just for Florida standards. It's genuinely cold in general. The low tonight is -2 Celsius, or 28 degrees Fahrenheit. And the other day, it was down to, I believe, at least here at the Space Center, it was like 25 degrees or like maybe 23, 24 degrees. That's not just cold for Florida. That's cold for anywhere. That's below freezing. I think once you're below freezing, that's cold for anywhere. I actually came back to Norway, had one day of weather, or one evening of weather where it was above 70 degrees Fahrenheit, and then the temperature has just plummeted from there. I forgot what warmth even feels like outside now, genuinely. But thankfully, the temperatures should be warming up by about Wednesday or Thursday at this point, with the highs hopefully getting back into the 60s or 70s. And Lord knows we need that around here. We're all freezing cold. We're all just walking ice cubes now at this point. But yes, temperature has been playing a major role in terms of how NASA has been handling the wet dress rehearsal so far. Obviously, the first and foremost reason or effect from that was it delaying 2 days to obviously tonight. It's yeah, as I oh my god, as I already mentioned a few minutes ago, the low tonight is -2 Celsius or 28 degrees Fahrenheit, which is below the average temperature of 41.4 degrees Fahrenheit or 5.2 degrees Celsius. Granted, yes, that's the average over a 24-hour period, but that is still well below that. So, going to be very interesting to see how NASA plays this one out. Obviously, assuming all goes well enough to where NASA is still going to push for a launch attempt this weekend, the temperatures by that point will be well above that and back to, I guess, more normal levels compared to what we're used to here in Florida at this time of year. So, a very rare and very unique circumstance that we find ourselves in where temperatures even get below 50 degrees Fahrenheit. So it's not just cold for Florida; it's cold for everywhere. That's just cold in general.
And as you pointed out, in terms of the temperatures, that does factor into the propellant load. They are not allowed to initiate tanking for a launch if the 24-hour average temperature at two different points on the launch tower over there is less than 41.4 degrees Fahrenheit, as you pointed out. So that is why it is so significant. The temperature, they did continue to tank anyway, despite the cold temperatures recently for this. This is not a launch attempt. This is just the wet dress rehearsal. And the numbers either must have been just within acceptable limits or they are proceeding regardless, since this is not a launch attempt. But we shall see. And the actual launch itself should not drop below between 49 and 38 degrees Fahrenheit for more than 30 consecutive minutes at those same two defined levels of the launch tower. And that all depends on wind and relative humidity. So there's about an 11 degree temperature range that they just won't launch in regardless. So those are things that we'll all have to keep an eye out. But as you pointed out, as it goes later into the week, those temperatures warm up. The averages will likely be above those 49.1 degree Fahrenheit numbers. And we'll see how the temperature remains for these evening launch attempts, because it does obviously get cooler in the evening here. 321 at Astra, also with a super chat here with the £2, asking how many people will be on the surface for Artemis 3? Is it 2? Alex, do you know?
Yeah, it's gonna be 2 people. 2 of the 4 crew members will be heading down to the surface. The other 2 will be staying in Orion, in orbit around the moon. Eventually, all 4 will go down, but in later missions.
Right now, yes, it will just be the 2. You can see NASA's security helicopter passing behind Artemis in that shot there. I almost said Falcon 9. Behind SLS in that
Yeah, so
frame.
this is quite obviously not a Falcon 9, in case you weren't aware.
This is not your ordinary Starlink, that is for sure.
Oh my goodness!
I mean, we're starting to get into these silly hours of the night, so it may as well be at this point.
That is true. For those who don't know or are just joining us for the first time during this, we are NSF. We are a group of spaceflight enthusiasts and journalists who are passionate about spaceflight and love being able to share it with everyone. We do have our own cameras set up at here at the Kennedy Space Center, as well as down at Starbase in Texas and at the McGregor SpaceX test site in Texas as well. And we are very passionate about this, and we do go out and cover as many launches as we can that we are out and about. So, of course, these are our views in addition to NASA's views that you are seeing on your screen right now. Our commentary team, in addition to being scattered across the globe, does have team members, boots on the ground, at the Kennedy Space Center for this launch. Max, you included. We also have D-Wise and Jerry Pike and Philip Sloss, who were out there earlier. I will be joining them as well for launch day, along with Julia Bergeron, whole team will be out there providing all of the Artemis coverage. And we also cover all the SpaceX launches as well here from Cape Canaveral, including Falcon 9s, Starlinks, Falcon Heavies, Vulcan, New Glenn, all of those. So if that's something you're interested in, consider maybe subscribing or at least, thumbs up to let other people know that they might find this cool. And RC Detmer upgrading to Launch Director, one of the highest levels of support that we have here at NSF. Thank you so much for that. We really appreciate it. And you'll get your name, of course, at the end of the Flame Trench and our NSF live shows. We only are able to do this because of support from viewers, so thank you so much. Even just by watching, you are supporting us here, so it is very much appreciated. Let's see. We are still waiting for an update at this point of when they are going to start the final 10 minutes of the countdown here. They remain at T-minus 10 minutes and holding and have been so since 9 p.m. Eastern Time, which is about 2 hours and 48 minutes ago. Things delaying thanks to hydrogen leaks, as always. Exclamation point, blame, if you want to blame hydrogen. And that includes our limited edition Blame merch, by the way, for hydrogen.
You know what, Sawyer? We're just over about a half hour from when, excuse me, that they have to be in the actual countdown to a simulated T0. Because I don't know if we have that graphic on handy that showed the timelines of regarding the holds and the milestones to reach. But the last built-in hold was at T-minus 40 minutes. And right now we are currently at 1 hour and 10 minutes. So we have about a half hour left before they have to commit to either a T0 at 1 a.m. local time or before they have to call off the attempt for the night. So time is running thin, but the good Lord, I cannot talk tonight. The countdown clock should or could pick up at any moment now, but it's been that way for the better part of a half hour, if not a bit longer now, ever since the closeout team departed the pad. So, yeah, there's lots to watch out for, but they really only have about a half hour left before we start throwing up major question marks, and there's already a few out there already.
I do have a correction there, Max, because they have already done that hold.
Oh, have they? Oh,
yeah,
okay.
L minus 40 to L minus 10 minutes.
Got it. Okay,
we are at T minus 10 minutes and holding. Technically, this is that hold.
Yes, fair.
Yeah, it just extended well beyond 30 minutes. 30 minutes is the planned duration, right? We're just extended well beyond that. So in theory, like they could in theory just pick up the count again at like what will be 12:50, right? 12:50 a.m. and say, okay, end of the window, right? But we'll see. Definitely keeping a close eye on that countdown clock at the press side. Also refreshing the Artemis blog. I don't know how many times I've done that. I think I've already broken the website for me with the refreshing. Yeah, we'll see. We'll see what they do because I'm really curious about what's gonna be done here.
So everything I just said, axe it. Forget about it. Strike it from the record. It's not true at all.
Yeah, they have at least until 12:50 a.m. to continue with this. So essentially another hour to go. Oh boy, another hour.
At most.
Yeah, at most.
This
correct.
is the 1 hour mark where if they, by this point in 1 hour from now, they are either under T minus 10 minutes or they did not attempt the test. So
exactly.
Or did not
And
enter
then,
the ground sequencer.
And then we'd probably be asking ourselves, will they do a second wet dress if they are actually not going through the terminal count? See, not doing the whole thing of like holding at T-minus 30 seconds or 33 seconds and then recycling back to T-minus 10 minutes and whatnot. Not doing that, not a critical thing. They have already gone through terminal count, right? At least once. Going through terminal count is the thing that at least in my opinion will be make or break, right?
Yeah.
That, if you actually don't go through the terminal count and then you go and attempt to launch, that it's probably not very wise because then you go into the launch attempt and you have your crew out there with a fully loaded rocket and they are sitting on their backs and all that. And now you have a hold in the terminal count and now you have an issue here and there and whatever that you could have found out probably on a wet dress.
Yeah. we'll see what they're able to learn from tonight, and hopefully they are scheduled to provide an update tomorrow afternoon on the results of this test, and that is very likely when we will find out if they are going to continue with the launch date on February 8th, if they will move to either the 10th or 11th, or decide to move to March, and whether or not they will be satisfied with this singular wet dress rehearsal test tonight.
You know what, Sawyer? We should actually know. Hang on. Actually, backtrack a bit. Do we know what time that press conference is again?
I believe noon Eastern.
Noon Eastern. Okay, so by that point, yeah. So that is before the currently scheduled time for crew arrival here in Florida, which I believe is at 3 p.m. local time here on the east coast of Florida. We should know, but obviously by that point, whether or not they're actually coming or not, because we will have to be there for that if they are. So hopefully we know a bit more information sooner than that, whether or not the crew's coming, but that'll be a telltale sign of what NASA will actually be targeting. So hopefully we know a bit before then, and not closer to the actual press conference, or I guess the currently scheduled crew arrival.
I just realized, because
What?
like 12 p.m. Eastern, is that like a little bit over 12 hours from now?
Yeah.
That's gonna be an interesting night for these people
Yeah,
to
no
go through
kidding.
the data.
No
before
kidding.
that. Yeah. I
I'm sure
wouldn't be
they've already
surprised if
been-
they.
I was going to say, I'm sure they've already been analyzing data as they've been going, though.
That's
Oh,
true.
yeah.
But also, I wouldn't be surprised if at the end of the day they're like, you know what? Let's delay that by a couple of hours. We need some sleep, right? I don't know, but it wouldn't surprise me at all. Something like that were to happen.
Me neither. And again, we will be out there for when the crew does arrive, whenever that may be. Our team will be out there in full force. May not be able to live stream because the quality out at the shuttle landing facility, or launch and landing facility, excuse me, now is not the best. But we, of course, have photos from all of it that all of our members will have access to. Depending on which level you're at, we'll be able to determine how many of those photos you get to see. Let's continue on here. Let me thank some more people. Simba G, thank you for becoming a Capcom member. Capcom and above gets access to the NSF Discord, so hopefully we will see you there. J-Train saying, it's a classic, Tex. I mean, Florida Tank Watchers program. Yes, Florida Tank Watchers tonight. There we go, in full force. Comp Guy saying $5 for the Please Turn on Automated Closed Captioning Fund. The problem when we do that is that the latency becomes extremely long. So especially for something like launch, it can be difficult, but I will pass it along. Chris Ray saying, probably missed this earlier, but is the deluge system part of tonight's wet dress rehearsal? Thanks as always for all you do. Max, I don't believe it is.
No, it is not. So the water deluge system, or the sound suppression water system, I believe it's called in this case, or was at least during shuttle, I believe is begun to be spooled up at around T-minus 15 seconds, which is well beyond the point of terminal count. And at that point, you were getting into the neighborhood of the ROFIs igniting, or the radially outward firing igniters, which create a much safer environment for the RS-25s to ignite in by burning off excess hydrogen in their in their startup processes. So yeah, we will not see that either of those tonight. That is well beyond the terminal count marker. So the latest we should see the clock strike tonight, maybe 29 or 28 seconds, but that's pushing it, because terminal count is right at T-minus either 33 or 30. Alex or Sawyer, correct me on that, but it's right around there.
33.
35? Okay.
No, 33 is when they turn it over to the automated launch sequencer.
Yeah, I got it.
Yep.
Okay.
And I believe Philip Sloss was the one who taught me earlier that they no longer use ROFI, which is sad because I always called them that. I'll probably still call them that as we go through the count. But now it's the H-Bowies, the hydrogen burn-off igniters.
The H-Bowies? Oh, you know what?
Yeah.
That is what they were called during shuttle, but they weren't called H-Bowies. They were just called their official name. Good Lord.
The HBOIs?
Oh, H-Bowies.
It's also, I think, because they are no longer radially, like they burn up actually. So if you look back at Artemis 1, when they did the ignition sequence, they fire up instead of sort of like to the side. So I think that's why they sort of, retired, if you will, the old ROFI acronym and went with HBOE or BOE or whatever, because it's hydrogen burn-off igniters, and that sort of works. Like whatever orientation they are or something like that, it just works.
Yeah, I've heard HBOE. If you're Flavor Flav, I think it's HBOE, but I don't know.
HBOE or boy.
Little H
Oh boy.
boys.
Oh boy.
Oh boy.
It is now approaching midnight Eastern time, in case you can't tell. Which again, the
In
window
case you can't
for
tell.
by our competency mentally. The test will run all the way, can run until 1 a.m. Eastern time. That is when the test window closes. But again, it is as you see, holding it T-minus 10 minutes. So they essentially must resume this countdown by 12:50 a.m. Eastern time, which is just about 50-ish minutes from now, to be able to run the full test tonight, which they have already decreased from 2 wet dress rehearsal tests of getting down to right before the automated launch sequencer would take over, resetting, and then doing it again, to just the singular test now. So once they finish the test, they will not be resetting for another quote-unquote attempt. As a reminder, this T0 is not for an actual launch. It is a simulated T0 of as if they were to be launching on launch day, knowing that the automated launch sequencer, if they do get to that point, will automatically call an abort because the systems will not be set up in a launch configuration. Just a note in terms of the updates that we've received from NASA, the last one was 11:14 p.m. Eastern Time, announcing that the closeout crew had departed the launch pad at Launch Complex 39B, moving to their safety area away from it, meaning that all of the hatches are closed on the capsule as well as the outer shell. So at this point, we continue to wait for any updates from NASA, which have been coming via the Artemis blog, as well as a ticker at the bottom of one of their fixed feeds. Just for those wondering where we're at this particular hour. Benjamin asking, have you ever considered a Starbase Space Coast stream, but you switch to whatever launch you are actively covering whenever you go live? I mean, we do that. When we have launches ongoing, we will have separate multi-views there. Either specific multi-views for launches that are large, like we will most likely for Artemis, like we do for Starship, or other ones where even just for a Falcon 9 Starlink launch, our Space Coast Live teams are there tracking the launch. We have people that work remotely able to use the robotic cameras to help move things.
Just like this launch, right? Whenever SLS launches, you'll be able to see some of those camera views on Space Coast Live, but we will have dedicated coverage as well. It's not like, we suddenly stop Space Coast Live or we point the cameras from Space Coast Live, suddenly turn to another place or something like that. We, in fact, use those Space Coast Live cameras for that coverage as well. So, yeah. And you were saying also Starbase as well, Starship launches. You can also see it on Starbase Live as well. A lot of people, well, not a lot, but some people don't like our commentary. I'm okay with that, as long as you watch Starbase Live or Space Coast Live.
Yes, during launches, people always ask, why don't you offer a feed without the commentary? We do. That is Space Coast Live. And as well for members, too, for these large launches, especially for Starship, we will also have a members multi-view that will cycle through all of the different cameras and allow you to watch all of the views rather than just the select 4 that we usually have. So,
yeah,
all of that to keep in mind. Devin asking, what was the objective of completing 2 test counts back to back? Alex, you want to take that? Or do you want Max to take it? Either or.
I mean, 2 counts back to back. I'm guessing.
As in getting down to the 33-second mark, recycling to the T-minus 10-minute mark, and then trying again to just recycle again.
Well, the objective of that is both get an actual test of that with the actual vehicle, right? Because they've probably done that 1,000 times in simulations, but with the actual vehicle there, it's never done before. There's also a sort of, how to say this. So I read before a long list of different things that happen during the terminal count until T minus 33 seconds. When you hold and then recycle back, you have to unwind all of that. You have to undo all of those different procedures and then set up again for another attempt. That means doing a bunch of procedures that, you know, when you have the actual hardware on the pad, it's really interesting, and it sort of benefits your knowledge of the vehicle, right? Of its behavior. How long will it take you to actually, like, you have a certain expectation of how it will behave to go back to certain steps on and a certain condition, right? To be able to go back and recycle the count and things like that. But then when you actually have the vehicle out there, you do that, and well, it's a bit faster, or maybe it's a little bit longer, or it reacts this way or this other way, etc., etc. You actually have the vehicle out there. That's one of the big benefits of doing that, right? Of testing a condition that you never want to see in a launch attempt. In a launch attempt, you just want to go through the terminal count in one single go. But unfortunately, sometimes these things do happen, right? That you have to hold for whatever reason during the terminal count, and then you have to go back and recycle. Well, if that were to happen, what will happen? And this was sort of the idea behind that test objective, right? That, well, now that we have it out there on the pad, we can test this kind of scenario.
I have a question.
Yes.
Go ahead.
Feel free. Maybe I'm just tired and delirious, but I'm seeing some venting coming from the bottom, or from the area around the bottom of the right SRB, and I can't tell if that's just residual venting coming up from underneath from engine bleed, or if that's coming from the TSM area.
I think it is part of the engine.
Okay.
That looks like the engine bleeds under there. Or the
Yeah,
venting
because
the engine chill.
see from this angle, it's hard to tell that that's where it's coming from. It looks almost like it's coming from the right TSM area, which would be extremely worrying. But from the angle from the gantry over there, the angle is different. I'm tired and delirious. Kevin, don't yell at me. I'm sorry. I'm tired.
Yeah, that appears to be just the typical venting that we've been seeing from the 4 RS-25 engines underneath there. They've been chilled down, and of course, we've been seeing venting from underneath the launch tower there and from underneath the launch platform as the night has been going on. Still no updates yet from NASA on when they are targeting the T0 for tonight's attempt. We still continue to just watch the clock. Which, when it does come time for it, this isn't jinxing anything with using the S word or whatnot. We know they're going to detank tonight after the testing is complete. Do we know how long it takes to detank the vehicle following the test?
This is probably a Philip's last question. I do know they detank just by draining back the same way that they filled the rocket, right? They use the same lines to then drain back the rocket. Obviously, some of it gets lost to boil off. But how long it takes, I don't know if it takes about as long as loading it. It's not a straightforward answer because, as we've seen, for example, I'm making the example of Starship, but Starship uses a lot of pumps to be able to pump the propellant into the tanks. But when it's time to return back those propellants from the rocket to the ground systems, they do not run all of the pumps, and they don't run them also to essentially full. Sometimes they also stop at some points in the detanking process. So the detanking procedure for Starship, for example, it takes like an hour and a half, whereas the tanking itself is like 40-45 minutes. So it takes twice as long to detank Starship in that case. So that's why I said that I don't know if it takes about as long to load SLS, to drain SLS than to load it. But if it is, it could be a few hours. That's for sure.
Yes, and I know that the actual loading is used more of a pressurized system. It uses the differential pressure to help load up the tanks, if I recall correctly. I think Philip was mentioning that earlier. So I don't know how that works in the outbound lanes, shall we say. And I know Philip Sloss is typing in the back channel, so hopefully he can explain it a little better. But while we wait for that, Patrick Bob gifting 50 red team memberships as the red team stands by, hopefully not to go out to the pad. 50 new people became NSF Red Team members. Thank you so much for your generosity, especially the last couple days. We've been seeing you with the Raptor sides, with the launch the other night. Thank you so much, or with the roll the other night. Thank you so much for the continued support. And now more people will have access to all of the awesome photos that come into the members area on YouTube. And depending on when they launch SLS, potentially all of the other member perks that come during the launch streams. Thank you so much for that. Again, still waiting for any updates, still taking your questions, still getting delirious as we continue on with approximately 40 minutes remaining before they must begin that countdown if they are going to proceed with the wet dress rehearsal count tonight, entering the terminal count and letting the ground launch sequencer take over.
I do wonder what's going on right now at that launch control room. Because it's like...
Much discussion.
Yeah, right? I sort of hate as well that we are in a vacuum formation here where it's like... we have no idea what is going on. Right? Why is it that it's taking so long after the closeout crew departed the pad for now, sort of getting any information at all of what's going on there?
This must have been how, like...
the clock is ticking. The clock is ticking.
Whoa!
Ticking. Whoa!
Woo! Ticking.
Sorry to interrupt
There we
you there.
go.
We are now at T-minus 9 minutes, 50 seconds, and counting.
There we go. Okay.
So to answer your question, we are now in the official terminal count here for the Artemis II wet dress rehearsal. So now as they enter the terminal count here, as NASA put in their update just now, automated systems take control of countdown operations. Final checks of flight computers, engine bleed systems, and ground support equipment occur, and the rocket transitions to internal power, and the countdown proceeds towards simulated engine start. Terminal count is designed to confirm all systems can perform flawlessly under launch conditions, ensuring readiness for Artemis II, the first crewed mission of the Artemis campaign. And there you go. You can see now the clock active and correct on your screen as well. We will make sure that it continues counting as well from the official NASA clock too. But there we go. There is the official update now under 9 minutes into this. We expect this count to either end at T-minus 33 seconds or T-minus 29-ish seconds, somewhere within that range. So we will keep an eye on that. Coming up now should be the retraction of the crew access arm just about 30 seconds from now. That is that kind of white box in the upper right view of your screen there. That is what the crew uses to get on board. That is what the closeout crew just was working on previously. That will swing back away from the rocket. In the event of an emergency, that thing can swing back very quickly. But it does take its time on its way outward. It's finally happening. This is exciting. Getting into the count.
I see a little movement there, I think.
The protective hood?
Yes, I think. Yeah, there it goes.
Right on time. Crew access arm retraction is underway.
That is so cool.
Boy.
We're getting into it finally. Now it's exciting.
Think about 6 days from now.
This could
be it. Just saying.
7.5 minutes to go to the simulated T0. And there you can see it will go quite back and then lock itself into place to be out of the way for launch. One of the Japanese astronauts who flew on Crew 10 made a joke the other day on X about how it looks cold for people that would be up there since the wall doesn't go all the way up to the top like it does on the crew access arm over at SpaceX's pad next door at 39A.
I mean, that is a very good point.
1 minute away from the next milestone.
And once we hit that 6 minute mark, there are a bunch of milestones that happen. Yes, That is when the ground launch sequencer will give the go for the core stage tank to begin pressurizing to its flight levels. That is also when they arm the ascent pyros on Orion, and Orion's power gets set to internal. 3
wonder if
seconds
we'll
after
see-
that is when the core stage liquid hydrogen will stop replenishing.
Yeah, I wonder if we'll see that venting of the core stage liquid oxygen tank ending around that time, where they sort of start pressing the tanks for flight. Of course, no flight today, but they're rehearsing that. That's why it's a rehearsal.
Exactly. So that should be coming up, those couple of events, in the next 5 seconds or so. And we'll keep an eye out to see if any of that venting changes.
So what does it look like the current T0 is? Is it 1219 local or 1220?
I believe 1220. So again, at this point, core stage should begin pressurizing the Orion spacecraft on internal power, and the core stage wrapping up its liquid hydrogen replenish. If this were an actual launch as well, or sorry, 1219, not 1220. If we were on an actual launch now, this is the point where the launch escape system capability would become available. And that is also when the commander would be told from the ground that the LAS capability is available. Of course, there is no crew on board tonight, so there is no need to pull the crew away in the event something goes wrong, because they aren't there yet. Now coming up on about 5 minutes to go. Coming up in a couple of seconds. Yes, the flare stack going here. As we come up on a couple of events next, at T-minus 4 minutes, 40 seconds, that's when they will give the go for the liquid hydrogen high flow ejects.
Guys, we have a hold.
And the clock has stopped at T-minus 5 minutes, 15 seconds, which is just a couple seconds after the launch escape system, or launch abort system, would be armed.
Oof. Okay.
This is earlier than they had planned to hold. That was supposed to be at the T-minus 33 to 29-ish second mark.
So remember, now at this point in the count, they can only hold for about 3 minutes.
So start your timers.
Yep.
Yes. 3 minutes, then they would have to reset back to, or if they don't, they would reset back to the T-minus 10-minute mark.
Yep.
He had no word yet what caused the clock to stop. Still waiting to see any update on that. Interestingly, the clock on the NASA feed says it held at T-minus 4 minutes and 35 seconds, whereas the countdown clock you can see there at the press site says 5 minutes and 15 seconds. They just reset it to T-minus 10 minutes on the NASA stream.
Oh boy.
Not too sure what to trust right now.
Yeah.
I'm going to be honest.
Well, I think the countdown clock here at the press site is probably directly. Go ahead.
For a second and then stopped it again. Apologies. Continue.
No, you're good. I was just gonna say I think the countdown clock here at the press site is directly linked to the LCC. I could be wrong there. Maybe that's why the stream kept going and the clock here at the press site did not.
Philip is saying that the clock, the media center, not the one outside, but the one inside, it is actually linked to the official clock. It is still holding at T-minus 5 minutes and 15 seconds. So yeah, the one on the it is not reliable. Let's put it that way.
Okay, so we will go off of the information from the clock located at the media center, as well as potentially the outside clock. But again, we'll have to see. So at this
Philip
point,
saying in the back channel, if they cut off, then we should see the crew access arm re-extended. That'll be a telltale sign.
if so, would that mean that they are done for the night? That is the question.
Yeah, well, I guess it depends on the issue, and whether or not they can actually recycle or resolve whatever the issue is before then. Because see, it's 12:16 local time here, so they have about 45 minutes left in the window overall to work, which seems like a long time, but that passes very quickly, especially in times like this.
Exactly. At this point, we're still waiting for updates. We are actively, quickly refreshing all of the information sources that we have in front of us. While we wait for an update, let me quickly thank Patrick again for another 50 gifted Red Team memberships. That is 150 on the evening, not counting all the others you've already given this week. That is extremely
Crew
kind.
booster
Thank
going
you.
by the VAB. Look
That
at
is
this.
Ooh,
that
Crew
is for
12.
Crew 12. You could tell because of the NASA meatball and worm located on the second stage. Everything happening all at once here, folks. That is the Space Coast that never sleeps
Oh,
for you.
Crew Access Arm.
The
Oh
correct
dear.
arm is going back into place.
Yep.
Meanwhile,
So that
this will be
tells
going
you.
over to Slick 40 on the left side of your screen, by the way. That is for Crew 12. The Artemis II one remains at Launch Complex 39B as the Crew Access Arm moves back into place.
Welp.
Welp is
Will
a
be
good
cool.
word right now.
Yeah. Will be cool to have a bit more up-to-date information and in-depth information, if you will, as to what happened here. What was the hold, and are they even going to try again to go through terminal count?
That's the question of the night. I would love to know
Yeah,
what
right?
the issue was. Maybe they'll release some kind of update here in the next 5 or 10 minutes. But they have just over 40 minutes left in the window this morning to work. But the fact that they had to re-extend the crew access arm is not entirely promising.
Yes. As Philip pointed out, that is, if they do cut off, then we see it re-extend. So they have. So at this point, based off of their holding criteria, they can only hold in this position now for a short while longer before we get into concerning times. And again, Falcon 9, we have 2 vehicles that will be launching crew on your screen right now. On the left, we'll bring 4 people to the ISS. On the right, 4 people to the moon.
And mind you, as well, we also had presumably the Starlink Group 6-103 payload come back by the VAB heading back towards Hangar X2.
True, as SpaceX did announce earlier that they had an anomaly during the most recent Starlink launch out of Vandenberg in California, an issue with the second stage deorbit burn. So it's a chance that we may see things on hold a bit. It's possible, I wonder, if they're going to hold off on the Starlink launch and prioritize the Crew 12 mission as we see that booster roll out towards Slick 40. The crew launch will not be launching from 39A. That will be launching from Slick 40 at the Cape Canaveral Space Force Station, SpaceX's other pad and the busiest in the world.
And this is precisely why we say that the Kennedy Space Center and the Cape Canaveral Space Force Station are the space coast that never sleeps. The spaceport that never sleeps. Excuse me.
I was going to say,
guess,
is there tomorrow
I guess
on
all of the
Space
above.
Coast?
Again, for those joining, wondering about the hold on the wet dress rehearsal, the clock stopped at the T-minus 5 minute and 15-second mark. And an update on the ticker is that the countdown terminated at approximately T-minus 5 minutes, and that's
No
all
more
it says.
information. Time to refresh the blog.
Yes, that's the only update. And again, this is just from a small running banner that they have on one of their static camera feeds they're providing. Just countdown terminated at approximately T-minus 5 minutes. We can tell from all of the clocks at the press site that Philip Sloss is there that it was T-minus 5 minutes and 15 seconds. Also, those police lights that you see, those are not actually at 39B. That is the convoy for the Falcon 9 booster. So that doesn't mean that crews are rushing out to the pad or anything right now. So now we wait and see for any further updates on if they are going to proceed tonight. Again, as we've been pointing out, the window closes at 1 a.m. Eastern, which means with them, if they do reset back to the T-minus 10-minute mark, that would mean that by 12:50 a.m. Eastern time, they would have to be back into the countdown again if they want to make it within tonight's 4-hour window. And fueling began, by the way, for all of this at the L-minus 10-hour mark, with the original plan being a launch at a simulated launch time of 9 p.m. Eastern. So this has been going on since, I believe, about 10:30 a.m. Eastern time. We are now at 12:22 a.m. Eastern time the next day. And at this point, we continue to wait for updates. As soon as we hear anything, we will provide the updates to you. Boy, I don't know, Max being out there, did the vibe kind of change at that moment once the clock stopped?
Well, I'm over inside the hut right now. I'm not inside the press center, so I'm just honestly kind of all by myself. I know when the clock first picked up and began counting down again, I know D was in here over at the table, and then when the clock began to roll, D got up and sprinted outside. But I know obviously we all perked up. Oh, do we have an update on the blog?
No,
Oh,
I don't see one
okay.
at least.
The website for some reason keeps updating and telling me there's one more entry. But anyway,
But just, even though I know you're not with everybody else, just
yeah.
you can feel the vibe, almost like the air gets sucked out of the entire press site at certain events.
I mean, that as well, but you also heard all three of us like suddenly perk up, like, oh my god, like, okay, it's happening. It's like you just suddenly snap into focus and actually want to look at what's happening, because a lot happens in those 10 minutes, and that's why it passes so quickly. But yeah, good lord. Yeah, I don't even know. I have nothing else to say. So here,
Yeah, we got
I'm in
to that
tatters
5
right
minute,
now.
15-second mark very quickly. And here I am
Yeah.
running through things on the timeline, looking at what's coming up next. And then, as you pointed out, the clock stopped.
Yep.
So, yeah. Rev, by the way, while we have a second, thank you for becoming a PadRat member. And Silas, thank you as well for becoming a PadRat member. Very much appreciate it. Boy, you get your hopes up, but
Tonight's wet dress has been nothing short of a roller coaster, that's for sure.
and not even the abort system that they plan to use for Ares 1. Which, for those who
I'm
don't
just
know,
going to pretend you didn't say that.
For those who don't know, it was a literal roller coaster design. I think we've done an article on it at NASASpaceflight.com. I know we have the documents in L2, which is the paid section of our forums that we have at NASASpaceflight.com, full of so much cool repository information, shuttle, SLS, dare I say Constellation and Artemis, all of that. I legitimately, there's so much cool stuff in there. You could get lost in it for days. But yeah, if you get a chance and you're in there, check out the Ares 1 roller coaster. We continue to wait at this point. The fact that the crew access arm is back is usually not a good sign.
No. And the press site clock down here on the lawn is still holding at T-minus 5:15.
And they still have that one panel of LEDs that they need to fix.
It's so bothersome.
When you're this far into the count,
so annoying.
And they hold every little thing could be annoying, including a broken panel on the countdown clock.
At least it's not like it was earlier, where the numbers were literally misaligned, and the bottom banner with the hour, minute, and second labels were all wonky.
That was actually hysterical, I have to say.
It was, but also like those with OCD, and I know many of us do. It's just maddening.
And still waiting for an official word from NASA on anything at this point. A reminder that the planned update for the media is scheduled for tomorrow. Well, now today, technically the 3rd at noon Eastern time. We will see if they actually are able to hold it at that time, if they move it later in the day. The crew also was originally scheduled to arrive here at the Kennedy Space Center ahead of launch tomorrow at 3 p.m. Eastern. We'll see if they end up actually flying in or not. All of this is very much up in the air.
Not
literally.
Actually,
it's not in the air. It's still technically on the ground right now. But as the saying goes, better to be on the ground wishing you were in the air than in the air wishing you were on the ground. The problem is when your test is that you're going to stay on the ground anyway, it doesn't hold up as well for a wet dress test than it does a launch attempt.
I'm really eager to see what was the cause of failure or alarm here. I don't have the actual timeline in front of me. Did the hold, like, what milestone did the hold lineup best line up with, I guess?
The core stage ended liquid hydrogen replenish at T-minus 5 minutes and 57 seconds. Orion went to internal power at about that same time. The ascent pyros on Orion were armed. The core stage tank pressurization began at that moment. And then at T-minus 5 minute 20 seconds, so 5 seconds before the actual launch hold was called, the launch abort system capability became available. That was the only other call. So my guess is it's related to either something with the core stage LH2 replenish or possibly the tank pressurization.
That's my guess as well. And obviously that vent on the right side of the rocket there, you can see there like right before the LVSA is a sign that they never actually closed the LOX valve, so they weren't pressing the LOX tank there yet. I think that was still maybe a minute or two out from that mark. But if that's the case, Sawyer, then I guess we could hashtag blame hydrogen still.
We could. Let's see. Core stage LOX replenish termination was supposed to start at T-minus 4 minutes, and the ICPS was supposed to terminate LOX replenish at T-minus 3 minutes 30 seconds, with the purge sequence beginning at T-minus 3 minutes and 10 seconds. Yes, we can blame hydrogen. It is very limited edition merch that we may have to bring out again if they do another wet dress rehearsal, but hopefully they don't, because it's always hydrogen. This is kind of like our scrub merch that only if you're here for the scrubs, you get access to it. Only if you're here for a hydrogen leak during an Artemis attempt do you get to buy this shirt or this sweatshirt or the mug with it on it. So it's limited edition, limited time. Blame hydrogen. So while we wait for the official update, in the meantime, exclamation point blame. And we can blame hydrogen.
I'll still blame it anyways, even if this sort of holding the count at T-minus 5 minutes and 15 seconds was not because of hydrogen. I will still blame it for the fact that we're here at like 29 minutes past midnight Eastern, right? Yeah. Otherwise, it would have been a little bit earlier in the count.
That is true. The original simulated T0 was 9 p.m. Eastern. It is 12:30 a.m. Eastern time. And the timeline basically got delayed by approximately 2 to 3 hours because of 2 leaks on the tail service mast umbilical related to the loading of liquid hydrogen, something that we saw many times during Artemis 1's wet dress rehearsals, at which they did, I believe it was, 4 or 5, 6 of them? It was a lot.
I think it was 3 or 4, because they had 4 rollouts in total, 2 of which for wet dress rehearsals, 2 for launch attempts. They had 3 or 4 wet dress attempts, and yeah, they had 3 official launch attempts. So, in terms of how far they got into the countdown tonight, this being their first attempt at all.
I'm going to interrupt because we have an update. I apologize.
Go ahead. No, go, Sawyer, go.
The Artemis II wet dress rehearsal countdown was terminated at the T-minus 5 minute 15 second mark due to a liquid hydrogen leak.
Oh boy!
At the interface of the
so we can blame hydrogen.
Mast umbilical, which had experienced high concentrations of liquid hydrogen earlier in the countdown as well. The launch control team is working to ensure the Space Launch System rocket is in a safe configuration and begin draining its tanks. It is officially a scrub on tonight's attempt. We can officially blame hydrogen. As we were talking about, the tail service mast umbilical hydrogen leak officially strikes again, preventing a full wet dress rehearsal tonight, stopping about 4 minutes and 45 seconds earlier than planned. This is becoming the new ground umbilical carrier plate as the tail service mast umbilical.
It's funny because until Philip said this, I didn't realize they put the first core stage at Stennis through the green run, and they seemingly didn't have this kind of issue. And now they put it out there on the pad, and they do have issues with the tail service mast. Why don't they go to Stennis and like grab whatever thing they used to hook up to the rocket and just put it out there on the pad? maybe that one will work. I don't know. But yeah.
Yes, chat, blame hydrogen. It's always hydrogen. Hopefully we don't have to bring this merch out again. Hopefully this is a one and done, but we will see. So I guess the question next is, now what? I don't think we actually know.
Well, good question for tomorrow's press conference, I guess.
That is true. Again, at this point, we don't know if they are going to try again soon, if they have the ability to try again within this February launch window, all of that is unknown at this point. So if you're planning on coming to Florida for the launch attempt on February 8th, I would say that's towards the unlikely side now. Whether it goes the 10th or 11th, I think we'll find out more tomorrow, but we shall see. Let me thank some more people here while we all deal with the blame hydrogen dread here. Anna saying, Max, is it OCD or CDO in alphabetical order?
Yes.
Nice. Adam Ward, thank you for becoming a launch director. Again, one of the higher levels of support. In addition to the NSF Discord, you get your name at the end of all the NSF Lives and Flame Trench shows. Thank you so very much for that. And Orc Cloud with a $2 super chat saying, SLS needs a hydrogen diaper. # blame hydrogen. Now we're talking here. And there you go, Kevin Art back on the screen. Earlier, we were circling the tail service mast umbilical, and we put a little frowny face on it. At this case, yes, there it is. The frowny face remains with the tail service mast umbilical pointed to it. That is the leak location. That is where all of this came from. So, again, it's very finicky hydrogen, to say the least. And it is the smallest kind of atom on the smallest element on the periodic table, given that it's element number 1, as you've seen in our blame hydrogen ended up being unintentionally scrub shirts. It finds every spot that it can to leak. If there's any opening where it can leak out, it will. But now, yeah, here we are. I wish I had more to say at this point. I think we're all kind of a bit, I don't want to say stunned, but I think the adrenaline is wearing off and the crash is hitting now. All of the energy is leaking with the hydrogen. But man, I know all the questions now are, when launch? Are they going to have to do another one?
I mean, at this point, I would assume yes. The question is how soon, or when that's going to be. This is most likely not going to require a rollback. I want to make that very clear right now. Depending on the path forward, though, we'll have to wait and see what NASA wants to do. But if it's a simple TSM leak, they can probably just repair it over at the pad.
Yeah.
But this probably eliminates their odds of launching in February completely, depending on how fast they're able to fix it. Well, actually, might just be entirely. I don't know. Like, this is all speculation. We have no other official word than that tonight's wet dress is scrubbed. This is sort of like a Starlink going all the way to the end of the window and scrubbing. That's what this kind of feels like.
But more devastating, because at least with the Starlink, they can try again in 24 hours. They're not trying again in 24 hours with this test.
Absolutely not.
I do wonder, say they don't go ahead with February launch attempts, right? So we go to March launch attempts. I do wonder if they will try a wet dress instead of immediately, like this weekend or something like that. Maybe they sort of work on the tail service mast umbilical first, and then they go ahead and do another wet dress, or even just a tanking test, to be fair. We saw that during Artemis I, where there was, they worked on the tail service mass, right? And after working on them, they did not do a full wet dress rehearsal. They just did a tanking test, essentially the tanking procedures, without doing all of the terminal count stuff and everything. However, only going halfway through, going essentially down to T-minus 5 minutes and 15 seconds, if they were to repeat it, I'm going to guess that they will probably do a full wet dress. But that's probably, again, as you were saying, Max, like that's a lot of guessing on our part, right?
Yeah.
We just don't know what's going to happen in reality.
Yeah, that is very true. There's a lot that we still don't know yet at this point. And hopefully we will get those answers tomorrow in a scheduled media update. I will say though, if they do plan for March and you're planning to come in March, make your decision now. Hotels are going to skyrocket after tonight's attempt, I have a feeling.
Yeah.
At least it's not spring break.
It's getting close to it, actually. In the U.S., spring break kind of starts in March, especially for the Florida schools.
But the very first week of March?
It's technically the second week of March, the 6th.
Okay.
Yeah, yeah.
6th, 7th,
True.
8th,
Stop,
9th, that
Sawyer,
area.
stop it. Stop
That
it.
was not intended. Genuinely was not intended.
How else is he gonna say that? I don't.
The date after
You just don't, Alex. You just don't do that.
The dates after March 5th and prior to the 8th, in addition to the 8th and 9th. How about that?
Oh,
Preferred.
Lord.
But yes, so yeah, I really feel like I should have more to say right now, but I genuinely don't, given how late we are at this point into the stream, and the kind of air deflates out of you a little bit when you hear the word scrub on this, especially when you know it's a hydrogen leak, blame hydrogen, and it's the tail service mast umbilical. Hey, look at that. So I got the blame hydrogen hoodie. Perfect timing. Oh boy. No, I don't have any interest in some Titusville hotels. I'm the one who is a purveyor of them. I don't invest in them. I use them. So anyway, I made sure before tonight's attempt, for some reason, to book dates in March just in case. So can't blame me, but I was prepared. Oh boy. I guess the question is, what would be the quickest they could turn around now to do another wet dress rehearsal? If they were to try, let's say, for the 11th, how quickly would they be able to turn this around and now try and do another wet dress? Any idea?
I mean, Sawyer, it all depends on what the issue really is on the TSM, whether it's the seal or an actual or the hose. I don't know. Honestly, we don't know enough about it to really make any kind of speculation. I think the safe assumption, I believe, at this point would be to imagine that, given the nature of the leak being substantial enough to stop the count well before terminal count beyond t minus 33 seconds. In this case, it was at t minus 5 minutes and 15 seconds. I think that would warrant enough speculation to rule out the rest of this month completely. Again, speculation. We don't know. We literally have no idea. We will hopefully find out more tomorrow in the press conference, assuming they're still doing that. But we don't know.
That is true. Again, that's the problem with a program like this, where there's only been one other flight. It's not like Falcon or even something like Atlas, where there's heritage, where we know, okay, this is things they've done in the past. This is kind of what we can expect going forward. With this only being the second ever Artemis flight attempt, and the fact that the first one was, I don't want to say problematic, but had its issues, we'll say, complicates things of being able to say this is for sure what they can do, what they can't do. And they did upgrade their fuel capabilities to the pad, which, if they're in a normal 2-hour launch window, they can do a turnaround within 24 hours. The only difference here is that this was a 4-hour window rather than 2 hours. So I don't know if that precludes their ability to try again in 24 hours, if they would even want to try again in 24 hours based off of tonight or what the issue might be. So, especially because it also takes 48 hours from the on-station's call to then go all the way through a countdown and get to the test. So many variables.
For those that may have airplane tickets for February, if you do now move them to March, they'll probably be even cheaper. Just saying.
Not saying that we know anything, because we genuinely don't.
Exactly.
We will know as soon as you know.
That is true.
This is not one where I can say, "Oh, we have inside sources that are telling us this." No.
I wish.
NASA. We know what you know. Our information tonight came from refreshing the Artemis blog, because we are in 2026 and we use blogs.
Yeah.
As well as the official feed that they had with a ticker on the bottom. So if we do know anything, though, we will be sure to update you on all of our social channels That we can guarantee you. We are on Facebook, X, Instagram, TikTok, Threads, and Blue Sky. So you can check us out on all of the socials. As soon as we know something, we will post it there. I can promise you that. Let me quickly thank Fluffy here, saying, so SLS is not coming on then? Nope. Not tonight. But I have to thank everyone who is here tonight. This has been a wild ride. Joining me for this last portion of the stream and for the earlier portion of the stream here in the studio was Alex. Thank you for joining, Alex.
It's been a pleasure, and boy, was a long day today, right? We'll see what happens.
Max Evans out in the field and providing commentary. Thank you for both of those tonight.
Yeah, y'all. We say it often, and I'm going to say it again. This is just the nature of the game that we play, whether it be Falcon 9 or any other rocket, and in this case, the Space Launch System. It's just it's part of the game that we play, and this is not the last time it's going to happen. So, but we are here for it through the highs and the lows, the ups and the downs, the leaks and the launches. We will be here to cover it all. So, thank you very much for coming to hang out with us today and tonight, and we will hopefully see you again very soon.
I have to thank as well the team that was there before on commentary. Ryan Caton had also joined us earlier doing a lot of the hosting duties, in addition to Philip Sloss, who was out there on commentary and out in the field. And of course, we couldn't do this without our amazing field team. I'll be out there to join you guys for the launch attempt, but the ones holding it down through the cold, through the thick and thin, through everything of all these events. Max Evans, you out there as well. We also had D Wise out in the field, in addition to the commentary, and Jerry Pike. Need to make sure that he gets his thanks in there as well. That's the team on the ground for us today. Boy, there's a lot going on. So many people involved, and we appreciate everyone who joined us. And of course, as much as the views are great to bring in, we need to be able to show them to you. And we had our amazing duo of producers tonight, with Kevin Michael Reed providing the art and the voice of God. And we also had Jay Keegan doing a lot of the behind-the-scenes work, especially with the fiber feeds and all the videos coming in. Amazing teamwork by both Kevin and Jay. Don't forget, we also have teams that are not on the ground that are helping through all of this. We also have our robotic camera operators operating over at Space Coast Live, including Gage and Daniel, who are both over there. And don't forget, you'll be able to watch the detanking and everything going forward with Artemis, including if they end up going out to the pad tomorrow, whatever ends up happening. You can follow all of that on our Space Coast Live 24/7 feeds. Those do not stop unless the internet goes down. But you can follow all along there, so make sure you subscribe to know when we go live for next attempts, and also just to keep up to date with everything going on in spaceflight. I think we made it through. I am Sawyer Rosenstein. I have been your host for earlier in the stream and this final portion tonight. Thank you all for joining us. Again, stay tuned for the socials for the latest on Artemis II and SLS and all future attempts. And we'll see you for the next one.
And here we go.
There's the deluge. Here's ignition.
Doubling up.
Did you just do a Kerbal?
Back to the moon and beyond.
Put that in the big bag, Jingle. Back at home, we all have a lot of work to do, but from here, it sure looks like a perfect flow.
Propulsion continues to be nominal.
We did have an observation. 343 unfolds to go.
It's orange!
Water towers can fly!
Bingo! Right in the center.
Where's Jacqueline? There it is!
That was surreal.
That's not what we want to see.
No.
Oh my God.
Yikes. You bet. We don't need any more of these.